all the way around to...
No, yeah, I just want to avoid a trip hazard over here, if that's okay.
Okay.
You know what? Just come on over.
It's a Square terminal, right?
Yeah.
Check, 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 check. Ahoy, hoy! Welcome to SquiggleConf 2025. Woo! I'll be one of your hosts today. My name is Nick Nisi, and I am joined by Amy. Amy, you want to introduce yourself?
Hello, my name is Amy Dutton.
Now, this is SquiggleConf 2025. There was a SquiggleConf 2024. How many of you were at SquiggleConf 2024?
Yeah.
Right. Welcome back. As you know, we're in an aquarium, and I have a fun fact about that aquarium, actually. This aquarium, it has a turtle named Myrtle the turtle that's over 90 years old and has been here since 1970. Amazing. You're going to learn lots of fun things like that today, but also about web dev tooling and lots of really bad fish puns because we're in an aquarium.
Can't be helped.
Yeah, sorry. So
Not
as
sorry.
You,
Not sorry.
yeah, not sorry at all. As you know, this is the sequel to SquiggleConf 2024. Started off right there, and do we advance the slides?
Oh, I'm sorry. Wait a second. You're plugged in here? What? Okay. We're going to do a redo, everyone. Just hold tight. Okay, the slides. Yes, the slides. Can't do the show without the slides. Okay, wait.
Round of applause for the team. This is so hard to put together. So, as you walked in,
Just pull off the... Or you might have more to say. I thought we were going to take a second to get to the slides. The slides are not ready. I forgot to do that at the beginning of the session.
Oh, sweet. There we go.
sweet. Let's try that again. Check.
Good.
Okay.
There you go. You're good.
Yeah, there we go. All
Woohoo.
right.
The sequel of the sequel.
Yes. The sequel. And from there, we'll continue.
Awesome.
All right. So, we go to the next slide.
Yes.
All right. So, if you want to get on the Wi-Fi, this is the code. You can scan that, but it's the any AQ guest and underwater is the password.
Underwater. Give you guys a second to do that. I had no idea about Myrtle the turtle. Who would have thought?
Fascinating.
90
right?
years.
Over
I know,
500
right?
pounds.
What? I mean, what do you feed it? Well, that'll be a fact for later, I guess. What
Yeah.
do you feed a turtle? Okay, so this is for Discord. So everything that we're going to be doing in terms of questions and answers is going to be through Discord. So we encourage you to scan the QR code, join the Squiggle Discord if you're not part of it already.
Yep. Splash into Discord. You can scan that QR code.
Jumped ahead.
And when you get in, it's going to ask you some questions, including what year you're attending. You should select 2025. That is the current year.
Thank you
And
for
that will unlock a number of different talk channels for each of the speakers. And in there, you will be able to ask questions.
We also encourage you to change your name. You can do this just on a per Discord server basis, or if you're like, I don't want to affect all of the channels and servers that I'm part of, this is just for the SquiggleConf. But that just allows us to kind of know who you are, and when we're asking the questions, it's not just...
This question's from Myrtle the Turtle,
Myrtle.
2004.
Thank you. 2025. Yes, happy to. There you go. Yep, there is a channel for each speaker, kind of as Nick said, so as the speaker's talking, you can just add your questions, and then we'll be doing Q&As with them and can pull questions from the questions you guys have submitted. Okay. So that kind of gives you an idea of what all those channels are there on the side and what that looks like.
Now, of course, every conference has a wonderful list of sponsors, and this conference is no different. Let's take a moment and give a round of applause for the wonderful sponsors that made SquiggleConf happen. Thank you to each one of them.
We also want to say a special thanks to our partners, so MagnoliaConf, JS Heroes, and Artists for Humanity. So we're big fans of all of them.
And of course, the two meetups bringing the vibes to this conference are Boston TS Club and Michigan TypeScript. They are wonderful groups, and if you live in Boston or Michigan, you should definitely check them out. Let's give them a round of applause as well.
We do have a code of conduct, so the main thing is just to be kind to everyone, but if you do, in the off chance, see something, feel free to talk to either Nick or myself or anybody that is wearing a badge that says staff on it. You can also reach out privately on Discord, and we'd be more than happy to address any issues that you have, but let's be kind to one another.
Mm-hmm. All right, this is our lineup of day one speakers. Aren't they a catch?
Yes. It looks like there'll be some good talks.
Yeah. So, without further ado, let's go ahead and get started with our very first speaker. Well, let's welcome Anthony Fu to the stage. Anthony is our first starfish. Take it away, Anthony.
Thank you. Can you hear me? Okay, good. All right. Good morning, everyone. How's it going? Yeah. Yeah, it's my great honor to be here to giving the talk and meeting you all. So yeah. So about myself, my name is Anthony Fu, and I'm the core team member of Vite, Vue, and Nux. I also create a few open source projects like VTest, LiDiv, Uno CSS type challenges, and I'm also maintaining ESLint Stylish, Shiki, and 2/ right now. I work for Nux Lab, but recently got acquired by Vercel, so I'm now Vercel. And so I work full-time in open source, and I recently moved to Tokyo like a half a year ago. And if you come by, let me know. We can probably hang out. So you can find me on those with my website or those social media. All right, for a little bit more about my story. So I started my journey in open source with like a personal project called Bread Split in my college. And from that, I kind of create VS Code extension called I18 Ally, which is kind of probably my first open source project. And then I made Vue use the utility library for Vue, and since then I started contributing more to open source projects like Vue and Vite. And I built tools like SlideDiv and joined the Nux team, and then from that, I create VTest, etc. So I kind of end up with probably too many projects. So this is a graph I made to show the relationship of the project I work on, and perhaps some of you are already familiar with or probably using them in some project. What I want to say is just like I feel extremely lucky to be able to work on those projects and make them useful for the community, and eventually got this great opportunity to stand here to give the talk to you. So thanks everybody for coming, and thanks for all the staff for organizing the events and inviting me here. So for today's topic, so although I might be a little bit overreaching to to kind of take this ambitious topic, I'd like to share with you the experience and thoughts, like how we can make tools that people love from my own experience, and I hope it can give you some insights and inspirations of your own journey. So let's dive straight to the topic. So when it comes to like making tools people love, so the very first tip I would give is, I don't know. Well, I mean, I really don't know. We generally don't know. There's no such thing called 10 tips to succeed, or there's no formula to guarantee that we can definitely make people love our tools. So what we can do is to try and error, work with the community, hear their feedback, verify, evaluate, and iterate. So the real tip I would emphasize here is to try more and don't be afraid to fail. Even though I made quite a lot of tools people use, I actually made way more tools that's discontinuous or didn't work out. So it's totally fine for me to consider, as I consider them as a learning or like experimenting process. So for that, I would say that don't set too high expectations. So it's easy for us to get excited about the idea we're working on, but it may not necessarily to be the best fit for the community. Then I would suggest to establish a mechanism to verify your idea with the community, and then we can know where to improve, where to iterate. So the following tips, I would share more some practical tips that I learned from my own experience. So the second tip I would give is to solve the problems for yourself first. So you should be the first user of your tool, or you should be the reason why you made the tools in the first place. So to build from your own pain point, and eat your own dog food. So I'd say that building from your own pain point is a great way to coming up with ideas and provide you a strong motivation to work on it. So from the perspective of needs, because it's come from our own problem, like we encounter ourselves, so starting from our own needs allows us to give a deeper understanding of the problem and find a potential solution. And with our motivation comes to solving our own problems, it's also possibly that the others may find them helpful. And furthermore, our needs are likely to be shared by the others, so we can validate our ideas with the community. So finally, throughout the community discussions and contributions, we can iterate our own design and improve our solution to serve an even broader scenario. So by doing that, we basically gather the essential elements for continuous development of the project. That's what we are skilled at and enjoying, and what the community probably needs. So hope this can help you to make the project more practical and more sustainable in the long run. And then the third tip I would give is to be progressive. And progressive means that we should reduce the frictions for people to onboard and use our tools. So it'll be meaningless to kind of craft a great tool that no one knows how to use, right? So specifically, I think we should be progressive on following aspects. The first would be onboarding. So we should make the tools for people to, we should make it easy to be understanding and get started. So the tip I would give is to see if you can describe your tools clearly within one sentence. And if you can, it probably make the tools too complicated. And then we should be progressive on features. So start minimums and grow with the user. We should make the tools useful even in the simplest cases. For example, if you know Vite can start with a single index.html file and no more. And Nuxt can start with a single app.view file, etc. So it's easy for us to wanting to pack as many features as possible into our tool to make it more useful. But it can be overwhelming for users to start with a lot of features. So, and then we need to find a way to kind of review the features and as users find them useful. And then talk about extensibility to allow community to enhance the tools and enrich the ecosystem. We should make the tools extensible, which can be a plugin system, Okay, a plugin system for users to extend with their needs. And finally, I would say like being progressive on breaking change to provide the middle stage for migration. And this is probably the most important one, like to me, in software development. So breaking change are definitely necessary for software to improve. But how we do that is also crucial. So a common practice is to deprecate the old features and provide a warning to users to migrate to new features. And then we could provide forward and backward compatibility. And for users to opt into new behaviors in legacy versions or stay on the old behaviors in the new version, and for them to migrate at their own pace. Okay. All right. Okay. And a common practice, yeah. And for each of those steps actually deserves a major version. And it should be take care of like slowly. So if you see that in the open source community, like I feel like this is more like the trend, like more and more tools are doing that way, trying to minimize the breaking change and to make the things smoothly. Okay, yeah. And then as we mentioned a bit about the extensibility in the previous slides, the first tip I would give is to be extendable. To make the plugin system for your tools and allows the community to enhance it. I'm going to give a very bold statement here. So that, in my opinion, that's all the software should provide some kind of plugin system. Yeah. So before I explain it, I want to give my understanding of the definition of these two words, scripts and software. So how do you feel about these words? Even though scripts and software are technically the same thing under the hood, there are also differences if you look at the perspective from the user. So I would describe scripts as a one-off tools that you solve with to solve a specific problem. And most of the time, you throw them away after you use them. So it can be definitely helpful and save you a lot of time, but the code itself is usually not reusable. And software, on the other hand, is a tool that you use to solve a general problem. And it can be used for a long time. So you can adapt to different scenarios for others with different needs. So I would say software is the logic that adopts. The adaptabilities give life to code we wrote and benefit the others in the long run. When we want to build tools that people use, we want to try to make our tools less scripts but more software. Why we are talking about this? I think that extensibility is one of the very important ways to make software more adaptive, to have like more adaptability. For extensibility, we usually means a plugin system. So talking about the benefit of having a plugin system, I would say it allows you to build a community around your tool. It gives you the community power to build the extension features without being blocked by you or the maintainers. It also means it can scale better with the power of the community, like everybody can build extensions freely. And then, as an author or the maintainer, having a plugin system, you can also leverage it to experiment and verify your ideas without breaking changes to the core. So you can implement the experiment features as an opt-in plugin for people to try it and iterate it freely. And once it's stable enough, you think the idea is mature, you can then consider if you want to merge back to the core or still serve as a plugin. And then making a plugin system, especially a powerful one, would help you to design a better architecture for your tool. So you can have more flexible and extendable architecture where it can be more maintainable in the long run. And finally, as we mentioned before, a plugin system will help you to help your tool to be more extendable and cover more use cases, which can also benefit more people and maximizing the value of being a tool. All right. And with that in mind, I would say a good way to build a powerful plugin system is to make a core feature to make your core feature as a plugins. This would put you in a position of both API designer and API consumer at the same time, which would help you to design a more powerful plugin system. So let's take Vite as an example. So I don't know how many of you are familiar with the history of Vite. So Vite, as of today, is almost the default choice for web development for almost all the projects. But it's at its very beginning, it's experiments on development tools specifically for Vue. So as these ideas of having a native ESM dev server seem to work pretty well, even you start to think about maybe we should have this great dev server developments for the other framework as well. So starting from Vite 2.0, Vite becomes a framework agnostic front-end tooling and is no longer bound to Vue anymore. Instead, even extract the hard-coded Vue logic into a plugin, which also help to ensure Vite has a very powerful ecosystem that can support complex cases like Vue. And then we have a plugin to support React. We have the community to build a plugin for Svelte, which later becomes the official. And then we have crazy ideas like running a test runner with Vite as the same plugin pipeline, which end up to be Vitess. And now we have almost every meta framework built on top of Vite and sharing the great plugin ecosystem of Vite together. So this is just one of the examples. But we could see that without this moving of extracting Vue as a plugin, we wouldn't have all these great tools that empower our daily development today. And then the final tip I would give today is to work with a community, or to work with a user, depends on the type of the tools we are building. We can't build great tools out of nowhere. We need to work with the people and get them engaged and build together. The first thing I would suggest is to build your own identity. People need to know who is behind the tool, especially in open source. Software as tools is a little bit different from physical tools. Software evolves and needs maintenance. So knowing and trusting the authors and the maintainers behind a certain tool is important for us to get adoption. And then, of course, we should work with the users, listen to their feedback, and iterate. It sucks. Okay, building a software tool, especially for dev tools, is interesting. As your user is actually usually developers, meaning they could potentially contribute to the tool themselves. So making a good environment for contributions and maintaining a good feedback for them is important for your tool to get started. So for example, like replying to the comments and reviewing PRs in time to make people feel they are more engaged and they are part of the community, which potentially you could gather people. You could gather people with the same passion about the tools, and they may end up to building a team that scale the project further. And finally, we should collaborate with the other project authors and the maintainers outside of our project. Not only we could extend the ecosystem by introducing more integrations, but we can also learn from each other, spark new ideas, and to build a strong community together. So a quick recap to the tips I gave today, and there's many more things I want to get into in details, but due to the time limit, I couldn't really cover them all. So definitely reach me out if you're interested in hearing more about them, and you can also find my slides on my website, antfu.me, afterwards. So I actually give a few related talk before. The SaaS theory is about how we can expand the scope of our project, and the progressive path is about how we can reduce the friction for people to use our tools, and the yak shaving is about how to come up with ideas and execute them. And if you're interested, you can find the recording and slides as well. So in a word, needless to say, to build tools that people love, I think the only true tip is to put love and great care into the tools we make. And that's all for my talk. Thank you.
Give it up for Anthony. Thank
Yeah,
you so much
thank
for
you.
shelling out that wonderful knowledge. Would you please join
Yeah.
me in these
I'll let you
wonderful,
continue.
yeah, leave that there. Join me in these wonderfully crafted SquiggleConf chairs. Look at that, they got the logo right there. All right, now our wonderful audience has
Yeah.
got a few questions for you.
Okay.
So I will read the first one, and this is from Andrew B. And he says, all software should have a plugin system. Do you think this applies mainly to tools / libraries / frameworks, or does it also apply to apps and products?
Well, that's an interesting thing. I think I'm mostly thinking from the tooling perspective. Yeah, I think definitely like software, it has like apps things and tooling things. Yeah, I think it depends on definitely like what's the app itself, like you design for, like what's the target audience. But if your target audience is developers, you want people to use their tools, I think having like if your user is a developer, like developer has their own needs and they want to control the software, right? So I think like having a plugin system, it would be leveraging more possibility for the tool to be, yeah.
Yeah, I don't know if you caught that, but as a senior engineer, he did say it depends. Next question. This is from Becca Miller. How do you balance community feedback with your own opinionated vision for a framework? How do you decide when a suggestion is a great idea or out of scope?
Yeah, that's also a good topic. I think I should cover it. So I think having a balance is very important, like know when to say no. So I think that's also, you don't want to have your scope as like getting bigger and bigger that where you cannot maintain, or like you don't actually need all those features but people want it, so you can implement for them, but then you increase your maintenance surface. So that's why I think like plugin system would be very important, that you allows people to have different opinions where that you don't need to maintain those things. And then like for sure, like to balance the ideas is I would say it's art. So it take it kind of like depends like what you position this project to be. And usually like how we do that in open source is just we will have a feedback about like how we feel about like having this feature, and if we don't want to have it, we can provide some suggestions like how you can do that. So maybe like you can write your own plugin to do that, or there's other solution for that. So we should do that, yeah.
All right, next question. This is from Abby. How does one justify to my boss to invest in creating or investing in tooling when the business value isn't immediately quantifiable?
I usually think like if you kind of find ideas of building a tools out of your like daily work, like the project you're working on, so definitely you should prioritize the project you're working. But there's a little trick I would do is just like, if you see there's a potential to be a tool, but then right now you don't have the time to really polish it to be a tool, I would say like you can like probably create a folder in your project that's trying to like isolate the logic inside the things. So you don't put too much work to kind of like packaging it to a tool, but you have internal little tools that you trying to being isolated. And later, after your main task is finished, if you have more time, and if you still think about these things, so that means you probably think it's a good idea. And then you can go back and then to see if you can extract them to be. So you don't want to like really down to the rabbit hole, like too deep, where that you don't have the time to go back. So focus on your main task first, and then you can go back to see if you still like the idea.
All right, I think we have time for one more question. How do you build an audience for your software before you are a known quantity in the open source space?
I think that kind of tricky. I think there's a multiple way to do that. So I think first, you just like, if you want people to trust you, you have to build your identity, right? So there's a multiple way to do that. You can start to engage with the community. Like you can find some related community. So if you build a plugin for Vite, you probably want to get more participants in the Vite community and to see, and then you can talk to people in Discord or something like that, and having some feedback of the thing. And then to see like if you build a tool, and you can, like for example, like you build a solution for Vite, like probably solving some SSR issues, something like that. And then you can search for the Vite issues list to see if there's something related, or it can be a bug, or it can be a missing feature. And then you can comment below to say, oh, I built this solution, maybe you can try it. And to get feedback from also from the other user of Vite, and that's having the same problem as you.
Nice. If I didn't get to your question, you can find Anthony around the conference and ask him yourself. Yeah. Anthony, let's give him another round of applause.
Thank you.
Thank you so much.
Yeah. Okay, thank you. All right, where's your go?
Yeah, we're good. Just need to project. Thank you so much. That was a catch of a talk. Up next, we have Oliver Dunk. So Oliver's a pretty unique individual. He works on the Google Chrome team, works on their extensions. So I was talking to Oliver last night, and there's quite a bit that goes into creating an extension that I didn't even realize, because you're talking not only about how it interacts with the browser, but also any panels you have to pull up, any settings interfaces. So anyways, I'm sure it'll be a great talk. Welcome, Oliver.
Thank you. Hello, everyone. I'm so excited to be here. Hopefully you've seen the certification of the talk. Totally real. I just thought I'd do something fun because we're in an IMAX theater today. My name's Oliver Dunk. I'm a developer relations engineer on the Google Chrome team. And today I want to talk to you about building cross-browser dev tools with web extensions. Now, maybe you have a rough idea of what that might involve, but I want to make sure that everyone's on the same page and that we know what exactly does it mean to build developer tooling with extensions. So let's take a look at that. One really sort of well-known example would be extensions like Angular DevTools and React DevTools. And the idea behind these extensions is that they teach your browser to understand the framework that you're using in more detail. Now, of course, if you're using Angular or you're using React, ultimately everything just compiles down into HTML and JavaScript that can run in the browser. So you can use the browser's built-in DevTools. You can go ahead and look at what the generated elements are and play around in the console. But what you might miss out on are things like the component tree or the props that are being passed around. And so these extensions give your browser's DevTools a little bit more understanding of how the framework works and ensure that you can access all of that information for some sort of more detailed debugging. Another example I really like is this extension by Thomas Steiner on the Google Chrome team. This is the OPFS Explorer, and the idea behind this extension is that it lets you see data stored in the Origin Private File System API. This is a web API that lets you store data tied to your origin, and by default, there are no browser DevTools for this right now. And what Thomas was able to do was build some DevTools that help you see that data so that you can see the data that is stored in that API. Now, I want to be really clear, Tom is on the Google Chrome team. He can chat to the DevTools team, but he didn't have any special help with this. He wasn't using any private APIs. This is something he built using the public extension APIs and that you could build too. One final example that I want to talk about is this example that Oliver Turner spoke about at Svelte London. His organization builds a website, and sometimes different content is shown to different users. And the content that's shown to a particular user is based on a whole bunch of URL query parameters and hidden data which is inside the page. And so if you're determined enough, you can go and find that data and you can decode it and you can figure out why a given user is seeing certain content. But that's quite fiddly, so he built an extension which finds that data in the page and exposes it in DevTools, so it's easier for developers in his organization to see. And I think this is really nice as a use case because it's something that's very specific to his domain, to the application that he's working on, but he was able to build some developer tooling for his team. So to summarize, there are a few different reasons why you might choose to build developer tooling with an extension. For today's talk, we're actually going to focus largely on this first one. And this may or may not be the one that you're most likely to encounter. Actually, not everyone builds a framework or library, so maybe this isn't applicable, but I think we can still learn a lot by looking at how these extensions are built, and we can use that for whatever extensions we want to make. I do also realize that we're at SquiggleConf, so maybe I'm completely wrong and you're all building frameworks or libraries. That would be awesome. I'm not sure. As far as the talk, we're going to start here building a basic browser extension, make sure that everyone's on the same page, that we all know how a basic browser extension works. Hopefully that's something that we can all follow. By the end of the talk, we're going to be talking about how React DevTools is built. That's very complicated and in the weeds. I definitely don't understand it all. I don't expect you to understand it all, but hopefully we can have a bit of fun and again learn something. To give a film analogy, by the end we're going to be talking about how to build the DeLorean. And most people don't know how the DeLorean works. I think maybe Doc Brown is the only person that does, so it's okay if you don't follow everything. So with that said, let's go ahead and talk about building a basic browser extension. Ultimately, browser extensions are just directories on the disk. So we start by creating an empty directory that we call My Extensions directory. And I'm then going to go ahead and create one file inside of that directory, a file called manifest.json. This is the one required file for every extension, and it has 3 important keys. The first key is this name key, and this is a human-readable name for the extension. It's displayed in the UI so the user knows what extension they have installed, and it's useful just to identify the extension. Then we have the version key, and the version key is also shown to the user so they know what version of the extension they have installed, and it's used by the browser's update process so that when it sees a new version of your extension, it knows that it should update it and install it for the user. And finally, we have the manifest version key. Now, on the web, we try really, really hard to never make a breaking change. And in the extensions world, we also try to avoid breaking changes because they're not fun. But sometimes we do make breaking changes, and so when we do that, we increment the manifest version. And this allows us to very easily see by looking at the manifest what set of APIs and behaviors the developer of the extension was expecting, and that way the browser can either give those behaviors if it can, or say, hey, this extension was built for an older version of the platform and needs to be updated before you can use it. So those are all of the required keys. Because this is a talk about DevTools, I want to show you one more key, which is the DevTools_page key. Now, if I was to ask you to guess what this does, maybe you would expect that this points to a page that's actually going to be displayed to the user in DevTools. That's actually not the case. This is an invisible page which runs in the background and is a place where you can do some sort of behind-the-scenes work. You can call some special APIs to influence the DevTools UI that the user sees. So let's take a look at how that works in a little bit more detail. The devtools.html page is really, really simple. It's just a script tag that points to a devtools.js file. And then inside of that devtools.js file, we have this call to this special API, chrome.devtools.panels.create. And even though this is on the Chrome namespace, it's cross-browser, so this would also work in Firefox, say. The first parameter is the name of the panel, so we'll call it example panel. And then we have panel.html, which is the actual HTML document that we want to show within that panel. And this is now a really simple Hello World DevTools extension. So let's go ahead and take it for a spin. I have that directory structure that we just set up together here. You can see, for example, the manifest.json is just this manifest file that we created. I'm going to drag and drop that into the Chrome extensions page. And then if we go ahead and switch to a web page and open DevTools, you can see our brand new example panel. And right now, this is really simple. There's nothing there. But hopefully, you could imagine how if you have some useful developer tooling, you could put it in that panel.html file, and you've now given developers really easy access, a nice entry point into your developer tooling. I want to show you one more thing while we're here. I think this is really fun. Maybe some of you will think this is exciting too. DevTools is just a web application. It's built using JavaScript and HTML. And we can inspect web applications with DevTools. But because DevTools itself is a web application, we can inspect DevTools with DevTools. So to do this, we need to make sure DevTools is popped out into its own window. It can't be anchored to the side of the page. And then we're going to go ahead and press the Command-Shift-I, Control-Shift-I shortcut that opens DevTools. And what actually ends up happening is that we get DevTools opening for DevTools. So let's give that a try. Hopefully any second now. I might need to press the clicker one more time. There we go, perfect. So you can see we now have DevTools inspecting DevTools. I can go to the console, I can switch to my panel, and I can check, for example, those special APIs I have access to. So I can run chrome.devtools, and I can see all of those private APIs. And I just think this is like this crazy inception thing, like you're using DevTools to inspect DevTools. I think it's so cool. So that's our basic DevTools extension. I now want to talk about how to build a specific extension, maybe how Angular DevTools might work. I do just want to quickly caveat this by saying that not everything we're going to look at today is a public interface. So we're sort of looking in the weeds at how these frameworks work. I think this is really fun to learn about them, but these aren't necessarily interfaces that those framework authors were intending for us to use. So I just want to call that out and say maybe don't build anything production that depends on these specifics. Okay, so with that said, let's take a look at how to build an Angular DevTools extension. Well, you may have never noticed, but if you're building something using the Angular framework, in particular the development version of the framework, then it exposes some globals on every page. So we can go ahead and type ng, and we can see all of these globals. I also have $0 in this case, which is a reference to an HTML element. And I can run ng.getComponent. I can pass the HTML element, and I get back some basic information about the component that rendered that element. So it's this app component, it has a title prop, and hopefully you can see how this starts to give you access to some information which isn't available normally in DevTools. And so on top of this, we can actually build a DevTools extension. So let's do that. I've written this code. It's a little bit long. You don't need to read all of it right now. But the basic idea is that this builds a JSON structure which represents the DOM tree of the page. And then you can also see in the very middle, we're calling this ng.getComponent API. And so we're attaching on any props that were passed to that Angular component. And ultimately, the result of this is just a JSON structure that looks like this. So you can see the body key, you can see the Angular props, and then you can see the children. So we have a div and some script tags, etc. And so what we want to do now is run this from our developer tool so that we can get access to the DOM tree. Now, you might think that we could run this directly, but if we ran this in our panel.html file, we'd get back the DOM tree of panel.html, which isn't what we want. So we use this special API, chrome.devtools.inspectedwindow.eval, and this tells Chrome that we want to run some code in the context of the window that we're inspecting. And then once we get that DOM tree back, we can go ahead and actually render it to the page. So I have this code here. It just creates a div element, puts the name of the tag in there, and then renders all of the children. And this is our very first basic dev tool. So let's take a look at this running in action. I have an Angular app. This is just like the Hello World Angular app that you can find in the Angular documentation. I'm going to go ahead and open DevTools again, go to our panel. You see I can see the elements. I can click on one to jump over to the Elements panel. And I can also see this particular Angular component and all of the props that we use to render it. And so hopefully you can see how we now have a really simple developer tool that we've built sort of from the ground up. How about React? How does React work? Well, the way React DevTools works is slightly different, but it's still possible for us to understand. So let's take a look at that. The secret to React DevTools is this global React DevTools global hook. And if the React DevTools extension is installed, then it makes sure this is defined in the page. And then when the React framework is initializing, it sees that this is there, and it realizes, oh, the user has React DevTools, and it finds this inject and onCommit fiber root callback, and it uses that to actually pass some information about what's happening. So we can go ahead and take a look at that in practice. I'm going to go to a React website this time. This is just the react.dev website. I'm going to open DevTools again, and I have a breakpoint on the very first line of the very first script tag so that we can define that global before anything else has the chance to run. So let's do that. And then I'm going to go ahead and continue, resume the debugger. And as you can see, we get those callbacks fired. So the first one is telling us that we're using React DOM version 19, and then we get these other callbacks which have this sort of large object that's describing the whole state of React at this point. And so here you have the entire fiber tree, which is what React calls the sort of internal representation of all of the components. And hopefully you could imagine how you could listen for this callback in your DevTools panel and then start to render that component tree and build up some DevTools. And of course, React DevTools and Angular DevTools are both much more complex than what we've looked at today. They do a lot more. But I think this hopefully gives you an idea of the fact that this is all something that we could play around with. They're not doing anything crazy that's completely out of reach. I think generally a theme that I hope you get from this talk and that I hope you get from the conference as a whole is that everyone can build tooling. You don't have software engineers and then tooling engineers. Every software engineer can be a tooling engineer, and you should have a go at building your own tools. For the React stuff in particular, I got a lot of what I talked about from this really great talk, Building Better React DevTools with Replay Time Travel by Mark Erickson. This was a really great talk. It goes into a lot more detail than I went into, so I'd highly encourage you to go ahead and watch this. I want to talk about one more thing before we wrap up, and this is not actually a cross-browser capability. This is specific to Chromium. When Chrome DevTools wants to find out about the page, it's actually doing something slightly different to what we were doing. It's not running JavaScript to find out about the DOM tree, but actually DevTools sends a command to the browser process written in C++ using the Chrome DevTools protocol. And this allows the DevTools to ask the browser about some information about its understanding of the page. And there are lots of different commands here. There's some really advanced capabilities. So for example, these commands can be used to control the sort of DevTools emulation features where you can emulate running on a different device or under different network conditions. And so hopefully you can imagine how if we could call these commands, if we could invoke these commands, then we could do some really powerful things. And actually that's possible within extensions. So we have this Chrome.debugger API, and this is an API that lets your extension send those Chrome DevTools protocol commands. And so I can show you sort of a code example to show what that might look like. We start off by defining a target, and this is just a tab ID. We attach to the tab, and then we send a couple of commands, dom.enable to enable the set of DOM commands, and then dom.getDocument to get a representation of the DOM tree. And you can see the result that we get back is actually very similar to that JSON structure that we built earlier, where it describes the DOM tree. It has some internal IDs for some of the nodes, but ultimately we find out that there's a document node, and then within that there's the body, and you could use this to build some developer tooling. Now, overall from this talk, as I said, I hope it gives you some inspiration. If you're not building a framework like React or Angular, then maybe you're not going to end up building an extension like React DevTools or Angular DevTools. But I think there are DevTools that we could all benefit from, whether it's something to help with a CSS feature that you find hard to understand, or there's something that is very specific to the internal product that you're working on that could use better developer tooling. And so I think this is something that everyone should play around with, and it can be a lot of fun. But otherwise, that's everything. My name's Oliver Dunk. You can find me on Blue Sky. I'm also on some of the other social platforms, but I haven't listed them all out here. I'll also be at the conference both today and tomorrow, so if you want to come and find me and ask questions, you're more than welcome to. And I have some Chrome stickers, so I can give you some Chrome stickers if you come and find me. But otherwise, that's everything. Thank you so much.
Awesome. Thanks, Oliver. Let's come over here for some Q&A. And if you guys are looking at the Discord, there's several questions that people are adding. One thing that we're using to determine what questions to ask is based on the emojis. So if you see a question that you really want to be asked, make sure that you add a reaction there for that particular question. Oliver, the first question I want to ask is, what new features in the extensions platform are you most excited about?
Oh, that's a good question. I think one thing that I'm really excited about is we have a cross-browser group called the Web Extensions Community Group, where we get together to talk about sort of how we want to evolve the platform as a whole and making sure that we move in step with each other across all of the different browser vendors. And recently we've been coming up with a lot of sort of little nice-to-haves that aren't like groundbreaking features in themselves, but just like make something small slightly easier to do. Like extensions can open a side panel, which is like some UI on the side of the page. And right now, if you want to figure out if that's open or closed, it's really tricky. But we're adding just like on closed and on opened events, and they make it so much simpler. And so I like that we're at the point of sort of finding these nice little features that just make it more fun to build extensions and slightly easier.
Sure. It's sometimes those small things that make such a huge improvement in terms of the quality of life.
Yeah, absolutely.
Justin asked, is there a standard UI toolkit for DevTool panels so that it feels like it belongs in the browser, not trying to keep up with how first-party panels look and feel?
That's such a good question. Yeah, thank you to whoever asked it. And it's really tricky. The short answer, unfortunately, is not at the moment. We don't have like any sort of standard UI toolkit. It's really tricky. We've tried to do this sort of thing with other parts of extensions in the past. And the hard thing is, if we provide a toolkit, then it will look really great today. But then if in the future the browser changes, do we try and change the toolkit so that extensions look different, but without the extension developer having to do anything? And like in some ways that feels good, but it also means we're changing the look of the extension without the developer's input. Or do we let the extension fall behind, but then eventually the extension is going to look really dated? So it's a hard problem, but I think it's a good problem to talk about.
Yeah. Kirk asked, how portable are DevTools extensions to other browsers?
It's another really good question. So, I mean, DevTools to some extent are always browser-specific, but the basics of the DevTools API is supported in Firefox, and I think also supported in Safari as well. So like things like being able to create a panel and show some UI there, you should be able to do cross-browser. Once you get into like the Chrome DevTools protocol that I was showing, that is a little bit more browser-specific just because the browsers are all moving very quickly to add new developer tooling.
Alexander asked, do you have any thoughts on DevTools as web extension versus DevTools as part of your application? So
yeah.
I think kind of leaning in towards like TanStack DevTools or Nux DevTools, that kind of thing.
Yeah, I like both. I think React DevTools and Angular DevTools are really great. I also I've used Svelte before, and they have some more like in-page debugging capabilities. I think there are times where one maybe makes sense. So for example, anything where you want to debug a production application, then you don't want UI that's going to show to users. So like that really makes sense in DevTools. If it's a development build, then I think both can work well, and it's just sort of whatever makes the most sense for you.
Awesome. Thanks again, Oliver, for a great talk.
Thank you so much. Thank you, everyone.
All right. Thank you, Oliver.
Thank you.
Amy, head on back this way. Now, not only is Amy emceeing this conference, but she's also speaking. That's what we call efficient.
Ooh, nice one.
But I do have to say, your laptop is locked and you need to unlock it so you can get the slides up.
Just a little finger.
Yeah, real quick, how's everyone enjoying the conference so far? Thank you for being active in Discord with those questions. It really helps. It's a lot of fun, and I think that we get a lot out of it. And be sure to follow up in there and keep the conversations going.
Awesome.
All right, and with that, your talk is JavaScript Framework Cage Match, but maybe because of the theme, it should be a tank match?
A shark. Oh, that's funny. So this is a JavaScript framework cage match. So who would like to be our first fighters? Just kidding. So what frameworks are we talking about specifically? We're going to be looking at Next.js, Redwood SDK, Astro, and Remix. And so when you're talking about tooling, a framework is in some ways the main tool that I reach for and really defines my developer experience. So even if you don't use JavaScript or React, my hope is that you'll be able to apply some of the same concepts and principles and ideas to the tools that you usually use. So when I'm evaluating frameworks, in this particular instance, I try to stick primarily to React so that I'm comparing apples to apples. So even though something like Astro allows you to bring your own front end, for the purpose of this talk, let's just assume that I'm referring to React. So to evaluate these frameworks, what I ended up doing was I ended up building the same application on all 4 frameworks. That way I'm trying to solve the same types of problems. And I think that's really the key. Whenever you're trying to evaluate a framework or a tool or anything, really build something, because it's in the building that you're able to really learn it, push the edges, and determine those real-world problems. That will give you more than watching any YouTube video or reading a tutorial or even attending a conference talk, as good as this talk is going to be. So you just encounter different problems when you're building. So as you know, my name is Amy Dutton. I am a lead maintainer on the Redwood JS core team, so I do want to add that disclaimer there that I do work on Redwood full-time. So, and we do kind of think of Redwood as the underdog. I was at ReactConf a year ago, April, and was just surprised by how many people did not know Redwood, had never even heard of it. So I do want to give you a few details, hopefully without turning this into a commercial. And then we'll look into like the code samples and really give a fair look at every single framework. So my first interaction with Redwood is I co-host a podcast called Compressed FM, and my co-host at the time, James Quick, he knew David Price, who was one of the co-founders for Redwood. So he invited him on the show to have a conversation, and really, and if you're interested, you can see that particular episode. But in that conversation, David basically pitched me Redwood and was like, if you want to look into everything that we offer, I suggest you go look at the tutorial. And we have a tutorial there that's really a master class in building a full stack application. So I went and looked at the tutorial and was basically sold. So a year and a half later, I ended up joining the team full time. So that's how much I really appreciated and enjoyed what the Redwood team was doing. So Redwood has been around for 5 years. It was co-founded by Tom Preston Warner. He co-founded a little project, maybe you've heard of it, called GitHub. Or if you've used a .toml file, he is actually the Tom in Toml, which is pretty interesting. So I'd say his track record is pretty good. But after he left GitHub, he ended up founding an investment firm called Preston Warner Ventures. And so his way of giving back to the development community was creating this open source project called Redwood that would allow other developers to build on top of it. So it is an independent open source project, but it is funded by Preston Warner Ventures. About a year ago, Tom kind of stepped back from the project a little bit and handed it over to another co-founder full-time. And so we have really changed Redwood almost entirely. So it used to utilize GraphQL. We had first-party support for Storybook, Jest, and Prisma. But then when we redid everything, we ended up building everything on top of Cloudflare and really leaning into React Server components. So it's been a huge change, but I think it has been for the good, for sure. So I really do believe that a rising tide lifts all boats. And that's one of my favorite things about working on a framework is really seeing what everybody is doing, because I think that there's good ideas all around. We're all generally trying to solve the same problems, maybe just in a different way. So I love comparing these things. I don't think anybody has the exact right or perfect answer. A lot of it just comes down to the problem that you're trying to solve. Now, my 5th grade teacher in English, she taught me that when you want to write a paper or do anything, you tell somebody what you're going to do, then you do it, and then you tell them how you did it. I remember thinking that was so redundant. But here, I do want to give you a roadmap for where we are going and what we're trying to do. So what actually makes up a framework? I would say there's generally 5 different things. We'll also talk about why use a framework. Which framework should you use? And if you'll allow me to do BuzzFeed, it's not what you think. So what makes a framework? So as we dive into these examples and try and figure out what really separates one framework from the other, let's start by talking about what actually makes a framework. So I mean, if they're all using React under the hood, then they all have that same underlying technology. Syntax, another fantastic podcast, they had an episode specifically on this topic. So if you're interested, I've tried to include QR codes anytime I'm making references to different resources and things like that. So, but Scott Tilinsky also tweeted about it, and the thread and the comments are really interesting if you do want to take the time to read through that. So I've tried to screenshot some of the highlights and include them in this talk. So, like I said, I had fun going through the replies, and some of the things are not exactly what you would expect, but some things are just interesting what people really care about, and some of them aren't necessarily tech-related. So let's look at the router first. The router gives you a way for people to get to your data. Then you also have CRUD operations, create, read, update, and delete. And CRUD is probably 90% of building any application. So we take a set of data, we want to be able to view it, manipulate it, pivot it, filter it, and sort it. We make inferences and decisions on that data. And I'd argue that when we're talking about AI, that data is going to become even more important because that's really the proprietary piece of any application is the data, and we'll really separate it from one application to the next. Let's also talk about rendering. So how does that data get rendered and shown to the user? Are we talking about the client side or the server side? Are we talking about build time or when the user actually makes a request? And then let's also talk about the developer experience. So how do you feel when you're using an application? Do you feel like you're able to move faster or slower when you're working with that particular framework? And then I think the other piece is longevity. So, and really that boils down to trust, right? Can we trust the framework that we're building on? Do they have our best interests at heart when they're building that framework? And is it going to be around next year, or is it going to be around 10 years from now? So let's look at the first one, the router. So there's a couple different approaches to the router, and so we'll get into some code, because I know that's what everybody loves. In Astro, they're using a file-based routing system. So as soon as you add a file to your project, that becomes a route. So in this case, we have a comments.astro file, which then becomes /comments. You can also create a dynamic route by using square brackets. So in this particular case, we have square brackets around ID, and so then that can be, say, /link/Google or whatever. That allows you to inject whatever variable you want in terms of route. In Remix, you can nest routes, so you can say, again, /link/Google, but they have a flattened file system. So yes, adding a file to your project does create a new route, but you don't have multiple nested folders for those routes. So this is kind of interesting. If you look at the sign-up page that the arrow is pointing to, it has _auth.signup. The auth, we'll talk about in a minute, is really designating a layout. But if you're working with dynamic content, they use a $sign. You can also use files and folders, but if you're using a folder, you have to have that route.tsx file so that it recognizes that particular file as a page. Now, Redwood uses a config or a file-based approach. So since everything is built on top of Cloudflare workers, we have a workers.tsx file that defines all of your routes within a single file. And personally, this has become my favorite way to handle routing. And why? Well, because with file and folder-based routing systems, your file organization is tied directly to your routes. So if the route needs to change, say you have a PM that comes to you and says, I don't want to use /signup, I want to use register, then that has a potential to break different import paths, and you have to reorganize your folder just because you want to change the URL. But with a config file, you're able to kind of work around that. So here, let's see. Let's keep going. I'm going to show you how this works exactly. Now, if you look at this route, so this is defining a specific route. The first parameter here is the request. So this is another thing that's really interesting, is focusing on the request response lifecycle. So the first parameter is essentially that URL that you're passing in, and the second parameter is a response. So this can be a generic response, or it can be a React component, or say JSON. The way that we handle layouts is we have a layout function. So that first parameter is the name of the React component that you want to render, and the second parameter is really an array of all the routes that that gets applied to. So it's kind of easy to trace down which layouts are being applied to which routes. Now, one thing to keep in mind when you're working with routing systems is how they scale. So for a large side project, this was my file structure for a remix. There were so many files and pages, it was so hard to keep track of it. And what makes it difficult, too, is that the layout, I mentioned that _auth earlier, the layout is included within the file name. And so you're trying to process two different pieces of information when you're processing the list of files. And with VS Code or Cursor or whatever your IDE is, trying to resize that sidebar based on how long that file name is, it can be a little difficult. Now, in all fairness, just to make sure that I'm giving Remix a fair evaluation, they do have a configuration option that you can use. And we'll talk a little bit about it more, but they are pivoting more towards leaning into React Router and kind of changing how they approach Remix in general. Okay, so let's talk about CRUD. So let's start with the R part, which is the reading data. So within Remix, they have a data loader pattern. So on every page, you have a function that exports a loader function, and this runs on the server. And then within that same component page, you'll have a use loader data hook at the top that will allow you to get that information from that function. And then you can loop over it and display your data. In Astro, at the top of every page, they use something called fences, which is just 3 dashes at the top, and then at the bottom of that section that you want to run on the server, you have 3 more dashes. So it is nice being able to have that designation of this is what runs on the server, and everything else can run on the client. Next is a little bit more complicated because there's so many options, and they actually have 2 different APIs with their pages and their app API. But for now, we're just going to focus on the app side with React Server components. So this is an example of them using the app API, and here you can make a database call directly within the component, but it is running on the server. With Redwood SDK, it actually looks very similar to that. So this particular project is using Prisma, and you'll notice that I can make that call directly within my component. And of course, the beauty of all of this is that your query, your database call, lives as close to the data that's displaying it, or your component that's displaying it, as possible. Okay, from a C side, from the create, that's really talking about forms, right? So within the next JS app API, there's a new thing called form actions. And actually, this is more of a React thing than a Next thing. We've kind of, in some ways, conflated React and Next. But it is a React thing. And this is a server action, in this case called create invoice. And that runs on the server. And you can see at the top, there is a directive that says use server. With Remix, they have their own form component. And if you don't pass it an action, it'll automatically run on that particular URL or that same path. And then each page has an action function. So we've already talked about they have a loader function. They also have an actions function. And that's where the form gets submitted, it takes the request, and then it does something. And so there are a few nuances there. Within Remix, you can also use a form fetcher, and that use fetcher hook will allow you to update without having to update the entire page, and just the parts that get changed. So this is great in terms of reactivity, and it also has patterns for handling things optimistically. So, but the only weird thing is you do have to wrap everything within a form tag. With Astro, you can use just a generic standard form tag. So here I created an API route to handle the form submission, and then you have to create a separate file for that particular API. So that's what it looks like within the API folder. And then I have a function called post, since it's a post request, that will handle that. Within Redwood, we also are using that action, but in this particular case, my component on the left side of the screen is a client component. So it calls a function within your component there. And then, here's the special sauce, I guess. I mean, it's not special to Redwood, but what makes this particular example work is that we have a server function inside. So this actually calls the code that's on the right side, another external file that runs on the server. And then that gets passed back. And the trick there is the await. So it's going to wait to hear back from the server, and then it can update the UI however it needs to. Now, in terms of rendering, this really comes down to when and where. Are you talking about build time versus request time, or are you talking about client versus the server? There's a lot of acronyms here. I tend to get them a little mixed up, so let's just talk through them briefly. But you have client-side rendering, CSR. So that means it happens on the client in the browser at the time that the user requests it. Then you have SSR, or server-side rendering, so that's on the server at the time that it's requested. You have SSG, which is static site generation, so that happens on the server at build time. You also have ISR, and I think this is really unique to Next and Vercel. It's called incremental static regeneration. So it's kind of a combination or a hybrid of all of these different approaches. So you have pages that are generated on the server, but they don't have to be redeployed, like you don't have to redeploy your entire site. The pages are built when they're requested, but they're heavily cached. So as you're trying to decide, okay, which of these acronyms do I use, a lot of times you want to consider SEO. Now, Google has gotten a lot better about processing JavaScript and being able to read that, but there's also other things that need to know what that stuff is. So for example, if you're unfurling, it's like, yes, Google might be good from an SEO standpoint, but you might try and unfurl a URL and show a preview that can't necessarily read the JavaScript all the time. It also has to take speed into consideration. So when these requests are being made, how are you caching those things? You have to think about updates. How frequently are you updating your site? So I've maxed out build times with some providers. Like it takes 15 minutes to build the site. So if you have an error, you have to change it and then wait 15 minutes for it to be updated. So depending on your project, that could actually be quite a bit of time. So here's a look at which frameworks support which render methods. Or if you prefer a chart, this is a little bit easier to digest, I think. Let's move on and keep talking about the DX, or the developer experience. So I mentioned the tweet thread or the X thread earlier. This is one of those screenshots. How will this improve my productivity against how much bloat it will add? So that's a consideration. Also, least amount of size per hour, or the ability to organize code by logical concern. So these are all things that people take into consideration when you're thinking about the DX. So with DX, I think a lot of it comes to folder structure. How are you organizing your project, and how are you working with the files? But also middleware is a huge part of that. So there are differences between the folder configurations, but again, they're pretty minimal. The biggest difference when you're talking about how files and folders are named is, say, like for a router.tsx file. How many people have encountered this, where you have a bunch of different pages open, and in your tab bar across the top, they all say route.tsx or page.tsx. So it can sometimes be difficult to find exactly what you're looking for. With middleware, this has to do with how are you modifying your requests and responses. So middleware allows you to redirect users, you can rewrite URLs, you can add headers, you can check for authentication. And all frameworks support middleware. And I point this out because this time last year, that was not true. So Remix recently added it, as well as Redwood. Now, with middleware and Next, they have their own file called middleware.ts that really handles everything. So depending on what you're doing, that file can actually get quite long. There's also a matcher at the bottom of the file that will match all the URLs that you're trying to filter through. So this can also be a little bit of a gotcha. Excuse me. I've been working on projects where I couldn't figure out why something wasn't working or wasn't loading, and it was because the middleware pattern didn't match quite exactly. Astro also has its own dedicated middleware.js file. So in this example from their documentation, they're taking the request and doing something with it. And then at the end, once it's run, they call a next function. So that will either call the next piece of middleware, or the user can go onto the route that they were trying to access. So with Remix, this is an interesting solution, is that there's a function on the page where they export middleware. So we already talked about how they're exporting loaders and actions. There's also a section for exporting middleware. So that kind of makes sense. Excuse me. So this gives you a little bit more insight into how things are running, because all of those things are on the page that you're working with. Redwood is completely different. So within the workers.tsx file, everything is listed as an array. So I think that is actually makes it easier to figure out what's happening, because it just runs linearly. It processes that array, and so you know exactly when the middleware is running and when the page is trying to render. So at the top of that define app function, you can include all the functions that you want to run before your page loads. With Redwood SDK, we also have a concept called interrupters. So you don't have to check for a specific path every time. You don't have to have that matching piece with a bunch of regex. You can specify exactly which pages of the middleware should run. So in this case, I have a prefix, which is kind of interesting. I haven't really talked about that, but a prefix allows you to put a piece or URL segment in front of all the URLs that you're listing. So in this case, I'm using admin. It's the admin section of the site. I have admin routes, which is really just an array of routes. I've abstracted it here for readability. But that second parameter is an array of all the middleware or all the interrupters, all the functions that you want to run before that page loads. So here I can check for authentication. So with longevity, we talked about trust a little bit. So how likely is this project going to be maintained 5 years from now? You don't want to invest a bunch of time trying to learn something and then find out later that it's being discontinued. So with each of these projects, first let's talk about how long they've been around. So Next has been around since 2016. It's the older project. Remix and Redwood SDK were started in 2020. Who is funding the project? That's another piece to when you talk about longevity. How do we know that it's being sustained? Netlify is currently hosting Astro, or sponsoring Astro. Remix has Shopify. Next has Vercel, and as I mentioned, Redwood SDK has Preston Warner Ventures. So, but one note I will say about Astro is they do have a range of sponsors. So if you look at their page, they have several companies behind them, not just Netlify. Now, kind of the X factor in terms of longevity is Remix, right? They've said they're taking a nap. I think we have a little bit more insight now into what that means, but they've basically conflated Remix and React Router. And then they've said that Remix is going to be its own thing. So all the examples here are using Remix as it is now, but it will change slightly. But in terms of their history, they're the people behind React Router, as I mentioned, which has been around before all of these frameworks. So I'd say their history is pretty good. So why use a framework? The main thing is it does allow you to develop faster. It is more performant and allows the framework author to take care of a lot of the hard parts so that you don't have to. And so that does lead us to the final question, which framework should you use? Redwood SDK. Just kidding. Just kidding. It really depends. I mean, that's really the best developer answer, right? Astro is interesting because you can bring your own framework, as I mentioned. If you don't want to use React, you can use Svelte or Vue. In fact, you can use all three if you want, but I would not recommend that. But in the past, they focused more on content sites. So they said if you're not working on a content site, then you might not be for us. In fact, that's on their homepage. But really, there's no reason why you can't use it for a full-fledged application. When it comes out of the box, Astro supports Markdown and MDX, which is really helpful. You can just include a .md or .mdx file, and that automatically becomes a route. And then a good example of this is Starlight. So I don't know if any of you have used it for documentation. It's a site template that they provide. It is beautiful. We actually are using it right now with Redwood SDK, so I'm a fan of that. With Next has the majority of support in terms of community. AI does recommend Next all the time. And then if you have integrations or you're plugging in with other code, it's easy to find Next-specific examples. So that is a plug for Next, especially if you're a beginner. Now, I'm going to go back to the render side of the conversation and really focus on the options that Next gives you. This can be both a good thing and a bad thing. It's great because you have flexibility, you can make a choice, and you can control it on a per-page basis. But sometimes it can be a bad thing if you have decision fatigue, and I'm not sure which rendering method to reach for. Now, currently, Next has led the charge on React Server components. They are kind of married to the Vercel team. They're paying for 2 full-time members. These aren't bad things. They're just things to consider when you're making a choice. With Remix, I really do like their data loader pattern. I love that they really lean into browser APIs, but they're kind of like taking a nap. And also, I will highlight they have a conference next month where I'm sure they'll announce some of the changes that they've been working on and some of their new features. With Redwood, we've really cozied ourselves up to Cloudflare, so if you like Cloudflare, that's a great option. With Cloudflare, you automatically get a database, you get storage, you get cron jobs, you get queues, and so it's nice having that all included, and you're not having to make those decisions. So how do you pick? I would say that this is kind of an interesting conversation, right? We all want to know, oh, what tech stack are you using, that kind of thing. And I have these circular conversations in my head all the time. If I use Astro, then I get this. If I use Redwood SDK, I get that. But I think the key is really to experiment, to build things, form your own opinions, and then go all in on one. Get as productive as you can on one framework, and let that be your tool of choice. Create your own packages and libraries on top of that. So I mentioned my podcast a few times before. I can't tell you how many founders that we've had on the show and have asked, like, what are your suggestions? And 9 times out of 10, they will say, choose boring tech. And I know that's not the answer that everybody wants, but the key is to focus on the problem and not necessarily the framework, because the end user has no idea what particular framework you're using. And so really, a lot of it does come down to that DX piece that we talked about. How has that experience worked for you? So if you are interested in continuing the conversation, I'm sure there'll be Q&As if you want to add questions to the Discord, but you can also find me at Self-Teach Me on most platforms. This is Nick.
Thank you, Amy. Yeah. You certainly cast a wide net around these frameworks.
Thank you. Oh, you get the seat now.
Got you some tea.
Oh, good.
Thank you, everyone, for the amazing conversations going on in Discord. I'm going to pick a few and ask Amy some questions. So the first one, out of all the factors to evaluate frameworks on, What have you observed seems to carry the most weight in developer opinion? And this is from Becca Miller.
Oh, thanks, Becca. Yeah, a huge part right now is AI. Let's be honest. If you're trying to either vibe code a project or you're stuck, a lot of the recommendations have been around Next, for good or for not. But that does make a huge difference. And so I know that's a problem that I feel like we all have to solve so that we're not writing old code that's 5 years old or based on whatever the models are.
Yeah, definitely. From Jen Looper, AI is starting to recommend React, speaking of, by default, and mentions Lovable as an example. Do you think this is going to stifle front-end framework adoption going forward?
That's a good question. Framework, when you're writing a framework, a lot of it does come down to funding. It's just the world that we live in. The developers that are working on those frameworks, they have to make money. And unfortunately, I can't buy my children food based on GitHub stars. That would be amazing if I could. But you know, a lot of that is trying to figure out, okay, how do we make this sustainable? And so with Lovable, if they're tying to a specific framework, or like Vercel, this is why they've cozied up next to Next, and you have those integrations with hosting, because that's how they're able to pay for those things. With Redwood, right now we're funded by Preston Warner Ventures, as I mentioned, but we've cozied up next to Cloudflare, and so you almost have to have that infrastructure support in order to have it long term. So I don't know if I totally answered the question, but a lot of those things depend on what is the funding underneath it to determine what the future of that looks like.
I heard it depends.
Okay, good. Good. I'm a good developer then.
Yeah. Speaking of Cloudflare, Steve Delonzo asks, I want to hear more about the decision to couple Redwood to a single vendor. Workers are great, but lock-in is risky.
Yes. Okay, so this is a great question. So if you're familiar with Redwood JS, that's kind of how or Redwood GraphQL, that's how we're separating them. We had GraphQL support you could host on just about anywhere you wanted. We had first-party support for Storybook, Jest, Prisma, all the things. When you're talking about a small team, a lot of our time was spent managing those integrations. And it does make a beautiful developer experience because all those things were working, but we were also making all of those decisions and opinions for you. And those worked when we first started the project, but sometimes like, you might not want to run Jest tests. You might want to reach for Playwright or vtest or any of those other things, but we've already made that decision for you. And so when we pivoted, we decided we're going to make fewer decisions in terms of lock-in, but that way the people that are with us, these are the things that they want, and these are the things that we can guarantee. And so it actually made our decisions a lot easier, because if Cloudflare supports it, we're doing it. If not, the community is more than welcome to step up and fill that gap. But from a team of 4 right now, this is what we're going to stand on.
That's awesome. Yeah, sometimes constraints are really good for focusing.
Yes.
Another question, Blake Heyman asks, while exploring different frameworks for this talk, were there any aspects of non-Redwood frameworks you really liked and might want to adopt into Redwood?
Ooh, yeah, good question. So this was interesting. I was looking through React router stuff recently, trying to see, okay, how have things updated? And their configuration router is really interesting, and a lot of those patterns mirror what we do within Redwood. They're not exact, but they are options. Another one that I didn't mention that's also a great framework that I really respect, the founder, is TanStack. I know Tanner's done a great job in just trying to provide community support and, again, trying to find ways to make that framework sustainable as well.
Yeah, for sure. One more quick question from Gabriel. If you're looking for a framework for a production application, which of these options gives you the best long-term scalability?
Oh, that's a good question. So some of it depends, I think. Depends on what you're trying to do. So, for example, we had a conversation this past week with I don't know if I can say that. We had a conversation with Better Off because a huge part of authentication is dealing with middleware. And they really liked how Redwood handles our middleware. And you have that interrupter pattern. You're basically running through an array. And so with something like Next, you have a giant configuration file. So that can become more difficult. So In that case, it might make sense to reach for Redwood. Or if you're working with a bunch of juniors that are vibe coding and looking to ChatGPT and Lovable and all those things, it might make more sense to look at Next because those are already the things that it's trained on and that person can move faster. So I think there's several variables that you have to take into consideration.
Awesome. Well, thank you so much, Amy. Will you please join me back at the MC role over here? Let's give her a round of applause. All right. Well, as a good senior engineer, she said it depends a lot. And we know we've been going off the deep end this morning. And now it is time for a break. So we're going to take a break. Feel free to leave the auditorium, use the restroom, grab a drink. And I believe we're going to put a timer up on the screen. And we'll see you back here in 15 minutes. Thank you.
up that ISO down on camera 1.
Down.
Is there a histogram that you can pull up?
Yeah. Okay. I put it down to stop.
Background, but you can see the. Thank you. All right, man. You're all set. Thank you.
Keep it down. Yeah, let's keep it down.
How's that?
Stand in front of it totally.
Totally?
It was just a little bit. Yeah. Okay, that's better, yeah.
Sorry, can I have you here one more time? So now, let's do the same thing, but take a look at his face. See if that changes. So, no light.
Like, yeah, just a little bit.
We need it. Can you do that? Oh, sorry, I meant cover that.
Oh, come on, back. Yes, that I definitely can do. No?
Block it. I don't think we need that. I don't think we need that. Is there a dimmer? Yes, please. Thank you so much.
I mean, full power.
Yeah, I mean, I don't think we need it. I really don't. But I don't know if that's a Dimitri choice, but I honestly think it will.
I'm back, everybody. So I have another fun fact about Boston. Does anybody eat Fig Newtons? Really? Well, apparently, I didn't even know this. The Fig Newton was named after a Boston suburb. There's Newton, Massachusetts. Who knew? Not me. So up next, we have Jake Bailey. Welcome to the stage, Jake.
Hello. Excellent. Hi, everyone. Hope you're having a good conference so far. I'm Jake. I work on the TypeScript team at Microsoft. I have a lot to go through, so I'm going to get right into it. All right. This is a redundant question, I think, for a lot of you, but I'm just going to quickly go recap what TypeScript is. In short, it's just JavaScript with types. TypeScript is a superset of JavaScript with a rich type system and tool chain, and it's the thing that you use to check for errors in your code. TypeScript has a lot of goodies, and I'm not going to talk about any of them today, so don't ask me about them, please. TypeScript launched back in 2012 with the promise of allowing for the development of application-scale JavaScript code bases, whatever you define that as. I think before TypeScript, JavaScript at scale was pretty rough, to say the least. I feel like that's agreeable. And I think since then, TypeScript has grown more than we could imagine, becoming one of the most popular languages out there. Currently, it's at number 3 on GitHub, behind Python and JavaScript itself. Last year, Python beat out JavaScript, but TS and JS together, I think, are probably the biggest. And I think JavaScript losing to second place, becoming second place, sorry, is probably our fault because most JavaScript devs are actually TypeScript devs. Last year's State of JS survey asked thousands how much time they spent between JS and TS, and only 8% of people said they didn't use TypeScript at all. But the thing is that all JavaScript devs are TypeScript devs too, because TypeScript is what powers JS support in most editors. If you have a hover, that's us. If you have completions, that's us. Syntax errors, that's us too, even in untyped JavaScript files. The TypeScript tool chain is what makes all those features work, be it in both languages. Now, like most languages, TypeScript is written in TypeScript. That I think is not unusual. Most languages are written themselves, but since TypeScript is just JavaScript, what's unusual is having a compiler written in JavaScript. There's a tremendous benefit to being self-hosted. We get immediate feedback from our own code. If something is buggy in the language or the editor support, we go fix it. And the TypeScript community, of course, knows TypeScript, so they can send us fixes. But there are challenges here. JavaScript wasn't designed for writing compilers. I feel like that's self-evident. There's lots of design constraints in the language that are more suited for browser DOM stuff, sandboxing. You can't share objects between threads, so if you want to do multi-threading, you've got to serialize the data between them, which sort of defeats the purpose most of the time. Async await means function coloring, so you can't, it's pretty challenging sometimes to write concurrent code, and there's a non-zero cost of building all those promises. And many builds of JavaScript have a memory limit, including the runtime that's bundled with VS Code. So Electron in VS Code, there's a 4 gig memory limit, and so people hit out-of-memory errors in giant code bases. We tried to squeeze as much out of the language as we could with lots of profiling, monopolization. This is an optimization specific to JavaScript. But we still have performance woes and ooms. People are getting code bases that are larger and larger over time. We know people that have like a 15 million line code base, and that's fun. Now, to be clear, JavaScript is always improving, but even if we get some of these details improved or fixed, it's a long time before we're able to use them. And so last fall, we started asking ourselves the question everyone had been asking us about forever, which is, could we rewrite TypeScript in another language? This is something that we said no to for a really long time. We kept working to squeeze more and more out of JavaScript, but we're hitting off walls to try and just prototype something. Now, obviously, there's a lot of cool languages out there. Sorry. There's Rust. Rust is popular. Everyone wants to rewrite everything in Rust. Lots of JavaScript rules write things in Rust. Go is precedent via ESBuild, which I think is like the pioneer of compiled language JS tools. One of the newer JS runtimes, Bun, is written in Zig. Flow is written in OCaml. And at Microsoft, we have C#, which has heavy investment at Microsoft. It has Node.js bindings too. So if we think about the requirements we have for this effort, obviously, we want to be fast. That's the whole point, right? We want to compile the native code. We want a strong support for shared memory concurrency. And we also want it to be multi-platform because JavaScript runs anywhere, so we were able to run anywhere Node ran or the browser, right? So we got to make sure that cross-platform stuff works too. But there's another key gotcha here, which is that TypeScript doesn't have a specification. Many languages have specifications. TypeScript is one of the languages that only has a canonical implementation. So the spec is just whatever the 150,000 lines of code in our compiler actually just do. People depend on obscure behaviors, whether or not we know how them. It's like Hiram's law, but like worse somehow. And even if we have a spec, there are behaviors that our people depend on that we might not even specify. So for example, TypeScript has union types. The order of things inside those types is undefined, and we probably wouldn't even define them in a spec. So if we defined a spec for the language, it may not be compatible anyway. So the upshot is that we can't rewrite the code base, we need to port it. That it has to be fundamentally the same code base, just in another language, preserving as much of the original behavior as possible. So if we add on to our list of requirements here, we know that whatever we choose needs to be actually possible to port into. That means that we probably want a language that is structurally similar to TypeScript, superficial or not. That means tending away from OOP patterns. We don't use those in the TypeScript code base. We have data and functions and interfaces. We also want to make sure that we have garbage collection. JavaScript has garbage collection, so trying to rewrite everything to fit that mold is sort of a challenge. We also have cyclic data structures, so we have ASTs that point up and down the tree. We have types that are recursive, so we need to make sure that that's ergonomic. And of course, it needs to be easy to learn because we need to get everyone on the team up to speed quickly, actually finish the thing, and be able to have people still contribute to us. Now, with these requirements in mind, one of the languages looks like the right fit, and that was Go. Now, this isn't a Go intro to Go talk. I think someone will give a Go talk later. But in short, Go is a statically typed compiled language. It has a very simple syntax, only has like 25 keywords. It's sort of like C, but with a runtime that does GC and concurrency, plus a really good tool chain. It's superficially similar to TypeScript, since JavaScript is similar to Java, which is similar to C. But there's a couple of notable features. So Go has structs, beta type that contain fields. Go has methods, which are functions that are associated with types. Type declarations can have basically any type, so you can make a type called myint that's an int that has a different name entirely. And you can put methods on those types, which is pretty fun. Go has interface types. If you know TypeScript, you're probably pretty familiar with the way that these might look. And just like in TypeScript, you don't actually declare that a type implements an interface. You don't have to do that. If it has the right methods, it just works. So in this example, mallard and person are both duck for some reason. They both have a quack method that returns a string. This is different from like a nominal typing language where you say like duck or mallard implements duck or something. Go also has a bunch of built-in collection types, maps, slices, just like JavaScript does. For a compiled language, especially one that came out in like 2009, this is pretty unique. Usually this kind of thing in a compiled language is left to third-party libraries. So if you're in like C++, like there's like the standard library, which is actually not bundled with the language, right? And it means build system pain for other languages. So this is a nice little advantage. Compiled languages make a big deal about where memory is allocated as well. If it's on the stack, then it's automatically freed. But if it's on the heap, you need to be able to free it at some point later. Go avoids this problem entirely. If you're used to C, this code probably looks terrifying. But the Go compiler can analyze this code and say, oh, you took the address of something, you're returning it. Okay, well, that's probably going to escape to the heap. Now, the compiler may be optimized and not put it on the heap, but the fact that you don't need to figure out where things live is a pretty nice feature. And since in Go you don't free heap allocated memory, Go has a runtime which runs a garbage collector. So the garbage collector periodically scans the memory for unreferenced objects and then frees them automatically. Everything up to this point has had a TS to JS analog where Go starts to differentiate itself as concurrency. Unlike JavaScript, Rust, C#, Go, it doesn't use async await or promises. Instead, it uses things called Go routines, which are lightweight threads. Go runtimes takes care of scheduling them into OS threads. You can spawn thousands of them without a problem. And you're allowed to communicate between different Go routines with channels, or just use more traditional matrix forms. It also has a super simple build system with cross-compilation, but I'm not going to go into that. In fact, if you're interested in Go, I would go take the tour. I'm not going to talk about that anymore. So, anyway, let's go back to prototyping here. In the beginning, we started hand porting Go from the bottom up, starting with the scanner and the parser. A few of us futzed around with other languages to make sure we felt comfortable with this. And pretty soon we found that the parsing phase of TypeScript was 5 times faster without any optimizations. It just one-to-one copied the same code. And the handwritten code looked extremely similar to the original TypeScript, proving that this might just be feasible. You get a rough idea what the porting looks like. Let's look at an example here. Our old code was effectively class-free. Functions close over inner state with inner functions that do the work, and then we export with big scare quotes an API through an object. Interestingly, this is the fastest way to do it in JavaScript. In Go, though, we can more simply write plain structs and methods. We don't need polymorphism or inheritance. It's just data and functions. And so early on when we were doing this, I wrote a tool that loosely transforms TypeScript code into Go code. So TS2Go uses TypeScript's API to parse out itself, and then converts the TypeScript syntax into Go code, using type information to write down types when needed. And so, for example, code that looks like this gets turned into code that looks like this. It's pretty much the same stuff, right? Code that looks like this, maybe there's more complicated stuff, bitwise operations and type assertions gets converted into this. So, you know, corporate needs to find the differences between this picture and this picture. Oh, they're the same picture. It's not all a perfect one-to-one, though. The code might be syntactically valid, but it's not necessarily going to compile. So for here, you can see there's an or, which in JavaScript means take the left side if it's truthy, otherwise take the right side. But in Go, that would have to be an if statement. So there's a bit of manual massaging that's required. Go also doesn't have a ternary operator, so that gets turned into like a fake call with an if-else function. And this is not a safe transformation per se. The call always evaluates the argument, so the else case would always run, and this might have a side effect, so you need to also inspect some stuff. But the tool does the job for the most part. So with TS2Go in hand, we've started pouring more and more code. Pretty soon the binder was done. I'll talk about those phases later. Some of the type checker, the perf continues to be great. And then we throw in concurrency. And this is Go, so it's a couple lines of code with the Go routines, right? And we're over 10x, and we're pretty happy. At this point, we're like, okay, we got to keep going. This is doing really well. And so we bring in the rest of the team. We have 10 people learning Go for the first time. I think I might have been the only one who had written like a meaningful amount of code, and I think many of us have even only worked professionally in TypeScript. But the learning period was pretty short. Pretty soon we had a virtual file system going, basic CLI. Every step unblocked more stuff until we were all working on different aspects. Fast forward a little bit, we made enough progress to test on a big number of projects, and the performance boost holds. So VS Code, which is like a 1.5 million line code base, used to take 80 seconds on my machine to compile, and now it's down to like 7. That's pretty good. And the same speed up applied even for smaller projects. Fast forward a few more months, VS Code is now compiling cleanly without any errors. We're pretty happy, everything's looking good, and we announced it on March 11th. And the response, I think, was overwhelming. I think most people were kind of flabbergasted about it. The YouTubers were really liking it. And of course, as I expected, most questions were asked about, well, why didn't you write it in Rust? Why didn't you write it in C#? Why didn't you write it in Zig? Why didn't you write it in C++? Okay, I don't know if I'm going to ask that one. There were lots of Reddit threads, Blue Sky threads. My favorite thing is people scrolling past the entire release blog just to comment on the bottom after they had skipped the explanation, which was great. Love that. But thankfully, some people in our community understood what really mattered, which was, could it still run Doom? We'll see. Now, the excitement didn't limit itself to the TypeScript community. The Gophers were excited too. Right away, Go contributors were testing out our code. On the same day that we announced, someone filed a bug on the Go compiler saying that it's slow to compile our compiler. 2 days later, our compiler becomes a Go compiler benchmark. That's pretty sweet. Later, there are a pair of changes that speed up the compilation of our checker package by like 5 times, so now we're no longer that fast, that slow to compile, and that's in Go 125. Okay, but enough about like the reaction and stuff, so let's talk about the details. This is where it's going to get fun. One of the main reasons we were so successful in porting the code base was due to our extensive testing. TypeScript is nearing 100,000 tests. My machine is lucky. I can run it in like 2 minutes. In CI, it's more like 15. A significant number of our tests are in the form of compiler tests, where we write some code out, and the test harness then runs the compiler on that code, spitting out baselines. So for example, we can create type baselines, where we walk every single node in the AST and ask, what's the type of this node? What's the type here? What's the type there? And so on, storing that result. If we're working on a change to the compiler, we break something, we'll know because the baselines will change. We can commit these files to the repo, so we can review them in PRs as well. I think these are also called snapshots or golden files. They're really good kinds of tests. We also can do the same thing for messages. We got some nice squiggles, squiggles. Thank you. And the key part is that we can re-implement the same test code in our new compiler in Go and run the same tests against both, and then diff the baselines. We can commit those diffs to the repo so we can have diffs of baselines in the repo and then burn them down until we fix the differences between the two compilers. This was the main way that we were able to track progress and figure out what to focus on. Sometimes we'd send a PR and we'd fix a couple baselines. Other times we'd fix something and it was like 500,000 lines of diffs deleted. And in the new code base, tests run a whole lot faster. My machine can run the whole test suite in like 20 seconds. All right, so in the process of the port, we had to think about data layout. As Go and JavaScript are, of course, very different in the way that they represent objects in memory. For our AST, the most obvious layout is to use a node interface, where we define every single node implements interface, and then we define specific node types for each of them. Now, within the AST, though, we store a huge number of references, and these often appear as node interface values. In Go, interfaces are fat pointers. They contain a pointer to the data and also a pointer to the type that they are. So it actually costs twice as much to have these references in the AST. Compiling VS Code allocates more than 9 million nodes, and we know people that have 10 times larger code bases than VS Code. So this could add up. And maybe this isn't much, but what's worse is that most of them are nil, which is empty, right? They're just in case. So for example, most if statements don't even have an else clause. So we're paying for the memory cost of that for all these allocations. And then worst of all, we kept assigning nil pointers and node interface values, and that's a whole different topic, a classic Go code mistake, which you can ask me about later if you want. And further, we had this really weird dissonance between some types where we had pointer to identifier in some places and node in others. And it's not like Go where you can sort of cross-compatible and cast them. It's sort of like that, but it got really weird where we'd have helpers that worked with one and didn't work with the other, and that got really frustrating. And then even worse, in Go, you can't assign in TypeScript you can do array of number and assign that to array of any. That's totally fine, but you can't do that in Go because there are static types that really exist at runtime. And so if you have a slice of pointer to a parameter and a slice of node, you can't do anything with them together. You need to try to use generics in Go, which you can have generic methods, and it doesn't really work out. So early on, we switched on to a new AST representation in which everything is a struct. Then base node type contains all the common fields, its position, source text, parent, and then we embed that in each of the other nodes. We only ever then pass around the node pointers, and then we can basically take the address of the node inside of the inner type to pass that around instead. And then if you want to go back from the node pointer to the original function type, we then stick a pointer that's an interface type inside of the node itself, so it references itself so it can go back out to the wider type. It's kind of goofy. And the upshot of that is that the slices, we can just use pointer to node everywhere. None of this is particularly nice, that it's a little unsafe, we can't have a specific type here, but it means that we stop writing helpers that have to copy arrays around. And the nice thing is that because node is no longer an interface, it can have methods, so we can define helpers for downcasts, we can define helpers for different computations. This layout's not perfect. If you're gonna write Go, I wouldn't recommend trying to do this, but it's the way that we ended up doing it. Now to allocate AST nodes, we have methods on a factory struct. The factory is there for bookkeeping reasons, but when we profiled our parser, we found that we had a huge number of allocations. This comes out of pprof. And so 37% of all the allocations were just parsing out identifiers in our AST. So if you ever write out foo, identifier, if you write function, there's identifiers everywhere, right? In Go, it's not free to allocate the memory. You have to call into the runtime to make an allocation. And so reducing the amount of allocations that you do can help improve your performance. And so we made this thing called a pool, maybe it's Arena, whose job it is to allocate nodes, where it can allocate a large slice and just hand out addresses to inside of the array to allocate memory in bulk. And the effect of this is a 20% boost in performance in parsing out checker.ts, which is a massive file, and 96% fewer allocations. Now, JavaScript does not have value types outside of primitive values, so there's no objects as keys. We had to stringify everything in our old code base. You've probably written code maybe similar to this. This isn't as slow as you might think it is, and I'll talk about that later, but we had to stick a special character in there to delimit where the one number is and the other one is. In Go, we don't have to do this. We just say, yep, it's a struct, and structs are values. And so this becomes a lot simpler. And in fact, we don't even need to have type IDs anymore because pointers are numbers too. And so we don't even need type IDs half the time to actually do plain comparisons. Composite map keys like this are coming for JavaScript, I think, hopefully in the near future. So that'd be really nice. Another fun difference between the languages is string encoding. When we parse files, we hold on to the original source text, but JS, C#, Java, store strings is UTF-16. JS runtimes can be a little clever about this and store ASCII sometimes, but in practice, though, our strings were still stored as UTF-8, and we used stored as UTF-16, and we used UTF-16 positions for everything. And yet, most JavaScript source is UTF-8, and so in Go, we just load it all up as UTF-8 strings, which is really handy because we can use less memory to hold the same amount of code and just index things directly. Getting this to work was pretty tricky. We have to audit everything that uses this like slices, but the result is pretty much worth it. Now, of course, concurrency is the big thing here. Half our speed up is from concurrency, and we probably wouldn't have done this if it had not been for the concurrency. But to understand how we use concurrency, I kind of have to go through the way TypeScript compiles code. The first phase is parsing, where we parse out all the code in ASTs, we process imports, so on and so forth. We then bind the code, where we produce symbol tables and do like control flow graphs. We then do type checking. This is a small box for a big step. And then we emit the code, where we turn it from TypeScript into JavaScript, and then down-level the syntax for older runtimes and write out the files. Now, we can't do anything in parallel in JavaScript in a single thread, and so the parsing phase just goes through every single file one at a time. The binding phase goes through every single file one at a time. The checking phase goes through every, you get the pattern here, right? We're only doing one thing at a time for all these different steps. But in the new Go code base, we're able to do a lot better, where parsing a file just does it all in parallel, because parsing a file doesn't involve any other files. You might have to process imports in parallel, but you're able to use all the cores on the machine to parse out all the files. Binding doesn't depend on anything, so we do it all concurrently too. And the emit phase doesn't use much of anything either, so it's all concurrent. But the checking phase is the real weird one, because how do you type check stuff concurrently? Like, are we going to add mutexes to all our data structures to try to make that work? Like, what's the story there? And so, the key thing here is that our checker does not work like a traditional compiler, where you have to like process the entire file. Instead, our checker walks around the AST, processing things on demand, only grabbing the types of things that it actually needs. All the information is stored locally to the checker. But even more critically, you can ask for the types anywhere that you want. So if you hover on like a random node, it'll just do the minimum amount of work to answer the question that was asked. We refer to this as like helicoptering, where you can just swoop in randomly around the file and get information. And then if the code changes, we can just like throw away the entire checker and start all over again. Because of this design, we're presented with a unique solution to our concurrent checking problem, where instead of checking each file concurrently, we instead make a fixed number of checkers and have each checker operate on a subset of the files. There might be duplicated work between the files, but the amount of duplicated work is actually pretty small. And so the overall effect is like a pretty good net win, and we avoided having to make our checker concurrency safe. All this together makes a difference between just using like one of your cores and using all the cores. Shockingly though, when we started adding concurrency, we had very little to fix. Our design already had shared and immutable ASTs, and that was required to make things in the old compiler work between multiple builds and when you're typing in the editor, so you don't like reparse every single file as your user types. The checker can remain single-threaded, like I said, because of all of its state held internally, and we just spawn more than one of them. And then the emit phase is really parallel, right? But sometimes emit can depend on the checking phase. So for example, enums, right, and lots of different features, import elision require the checker. And so there's a couple of mutexes sticking on the checker to sort of serialize that for the emit phase. The race detector in Go did though catch a bunch of places where we made mistakes. So for example, in this part of the checker here, we were mutating our control flow graph. This pattern is like totally fine in JavaScript because nothing preempts you. You just do one thing and then you can put it back again. But in Go, you can't just like touch a thing and then put it back again afterwards. That doesn't work at all. And so we had to change our code to store this information somewhere else. And this was a common trend where we were just kind of hacky in the old code and we had to be a little more formal afterwards. Go has a race detector that can detect these things, and that was pretty critical to tracing down these issues. Now, one of the biggest challenges though with concurrency is how TypeScript handles internal orderings of types. Every single AST node, symbol, and type has a unique ID, and these IDs are assigned based on the order in which they're walked in the AST during checking. For example, unions, we sort them by IDs, so if you make a union, it actually won't be stored in the order that you expect it to be. And so, because they're ordered by the type IDs, if you have two checkers doing different things from different files, they can walk the same code in different directions and come up with different IDs. And this posed a problem where you could tweak some code and it would break. And in fact, this is a real bug that was filed, I think, for like 5.8 or 5.9. And if you swap the order in this union, it's the same code, except because we swap the order of the union, it has an error. And this is really bad. No one likes this. And so in the new code, we had to solve this problem somehow. And so we did that by introducing new sorting functions for nodes, symbols, and types that don't depend on IDs. So for example, nodes can be sorted by which file they're part of, since we have a deterministic file ordering. Symbols can be sorted by where they are in the AST, so building on the previous sort, but also like their names, if they're named symbols. And it only falls back on an ID for like the rarest cases that I think I put a panic in this code and it didn't even fail. So it basically never happens. And then types, the really complicated ones, we can sort those by their flags. So whatever they're like a number. So like a number could be sorted before a string at all times. And for string literals, for example, if we want to sort them in a union, instead of just the first time you see a number, sort them by the ID, we instead sort them by like their actual literals. So now in the new version of the code, if you have a union of A, B, C, D, E, F, it's actually going to be A, B, C, D, E, F. It's not going to be random order depending on whether or not the checker saw them in the race order, which I think is something people asked for a long time. Now, that does mean that some programs that compile today might not compile the new Go code because the orderings are going to be different, but we've sort of tried to pin down all these issues, and most code seems to work totally fine. Another key area that we're changing things is the way that we're talking to editors. As I said before, TypeScript, the tool chain, also includes a language server because we're powering the editor support. And in the new code base, we're switching to the LSP, the language server protocol. Most people familiar with editors are probably asking, like, what do you mean? We weren't already LSP. I think there's talk about LSP later. But no, TypeScript predates the LSP, and in fact, I think inspired the LSP. And so people have been asking us to switch to LSP forever. And so this port is a great opportunity to do so. And the main thing is that the old protocol was synchronous, where if you wrote a completion, it wouldn't be able to do anything until the completion finished. If you asked for diagnostics, the errors in the code, it wouldn't be able to do anything until that finished. But in the Go code, we want to be asynchronous. We want to be doing multiple things at once if we can. And the LSP directly does that on purpose. And so we're able to implement our new code base with Go doing more than one thing at once. And so the language server is like a lot snappier because we're able to actually answer hovers at the same time that we're doing a diagnostic call. This was a bit tricky to get right because most of our code was ported over, and so it was kind of hacky, and so we had to redo it a couple weeks ago to eliminate all the data races. One other aspect we're really happy with in the new language server is the startup performance. So we can't do anything until we've parsed and bound the files, but in the new code base we can do all this stuff concurrently, which is going to make things a lot faster. So for example, restarting TS server takes about 6 seconds to load in the old code base, but the new LSP can do it in like half a second. Of course, there are always Go gotchas. Can you spot the bug in this code? Silence. Well, the issue is that it should have been equals, not colon equals, because in Go, that's a declaration, and the code wanted to return a result. This is a bug that happened all the time, and so I wrote an analyzer to do this, and after merging the analyzer, we never had that problem again. Now, if you remember in old code base, we had code that looked something like this. Our binder closed over data and functions. In this bit, we are binding all the children of a node with a for each child helper function. In Go, this is really similar. The only difference is that we're using methods instead of functions. But we had a performance problem here, and we didn't understand why until we looked at it and we're like, oh, actually, every time you do this, it allocates a binding. And so we had to basically pull out this method into a field so that it wasn't rebound with like a this every time. And this saved like, 16% performance. And this is actually really similar to a concept in JavaScript where if you call this function with, if you do this.handle, it's going to crash because there's no this anymore, right? And so you find yourself writing this.bind or pulling it up. And you can see we just did that in Go. It's the same thing. Okay, here's another one. In Go, this is a big no-no because every time you do this, it allocates the string. You're supposed to use a string builder. In JavaScript, this is actually totally fine. The runtimes optimize this because they can build a tree and then never evaluate the thing. So even if you like pop it into a map as a map key, it won't even put the string together. And so we had to fix a bunch of these elements in the Go code. And of course, the biggest friction of all is the language features that we miss from TypeScript. Nil safety, so undefined null checking, right, in TypeScript. Headline feature, not present in Go. We get nil panics. There's no union types. There's no generic methods. That's sad. There's no ternary operator. You're never going to fix that one, I think, on purpose. But all in all, I think we're willing to go through this pain as long as it makes TypeScript faster for people. So where are we today? We put out a preview build a few months ago. It's even more feature complete than it used to be. Editor support has been constantly improving. Our preview package has like 20,000 downloads. I don't know who these people are, but they're using it. It's great. Big users switched over. So Slack, for example, their build used to take like 6 minutes, and now it's roughly 40 seconds. Figma switched over, and VS Code are trying it out as well. There's also a new linter being worked on. It's been switched over to, I think, the Oxlint team. And it's like 30 times faster, and all they had to do was do the worst possible hacks in the world to make it work. Now we're working on a bunch of great stuff. Much of our effort is currently spent on editor functionality. A lot of stuff's working now. Auto imports, I think, got merged like a couple weeks ago. Rename. Our big language server refactor means a more straightforward path to implementing speculative edits. We're finishing up emit transforms, public API, and we're working on mainly performance. So TypeScript 6.0 will include a bunch of deprecations to help smooth this over for TypeScript 7.0, which is the one we're going to make, the one powered by Go. But in overall, we're pretty happy with this. I think the future is bright here. We're really excited to continue the effort. Go's been working pretty well for us. And I really appreciate all you here. And like, I think I'm over time a little bit, so let's get to the questions. You can find me on all the socials if you want. And please try it out and tell us what you like or what you don't like.
Wonderful. Thanks, Jake. We can head over this way. I think one of the big questions everybody wants to know is, does Doom run faster?
Dimitri?
Wait, you set it up earlier, right? Okay,
If you guys will keep submitting your questions through Discord, you guys are doing a fantastic job with both the questions and the reactions, so thank you. One question, this comes from, let's see, Mark. When we say TypeScript is faster, what does that mean for me as a dev that actually uses TypeScript? Just that TSC is faster, or is there more of an impact?
So it's specifically about the TypeScript toolchain. This was, I think, a contentious thing on the blog post because we said a faster TypeScript. We didn't say TypeScript is fast. Like, it's really complicated to message these things. And what it means is that if you run TSC, it's going to be 10 times faster. If you use your editor, it's going to be a lot more snappy and can do things faster. That's the main thing. At the end of the day, TypeScript is just JavaScript, so we're not making JavaScript faster because that's a completely different concern from us. And so it's all about making the tool chain faster, so when you compile, you go faster.
Awesome. Now, Gabriel asked, if you had to do it all over again, would you still use Go?
That's a great question. I don't know. We are constrained by people's existing code, and so that was a big factor in making it work because we can literally take our old code and slap it in a new language and it just works. It's totally possible that if we were to from scratch it, we could have done it in Rust or something like that. But it's, I mean, the learning curve on those languages is like quite different. And like, you know, none of us wrote Go. Well, none of us wrote Rust either. You know, we have some people that wrote C# before. Some people may have done Rust. Some people have done Go. So I don't know the answer to that, honestly. Can I say it depends? No.
Yes, you can.
I don't know if it depends.
Well, Josh asked, was there any AI used to assist with the port?
So early on, when we were doing the porting, we tried it, and it didn't work very well. And you might be surprised to learn that there's no existing corpus for TypeScript compilers written in Go. And so it wasn't very good at doing it. And so the tool that I wrote did the bulk of it, and then it was basically Anders just sitting down and like doing it. Like, I think he wrote like 100,000 lines of the code basically by hand. And well, I mean, he copied and pasted out of the tool, right, and fixed it up. we've had some success in later stuff for, like, for example, we're backporting changes from the old compiler to the new. It's weird. Backporting from the old compiler is strange, right? But we're porting code back, and like now that it can see the rest of the code, it can see the pattern, and so that's more successful. But the initial days, like it didn't work very well, and this was like a year ago, and things have, I think, have certainly changed in that time.
Sure. Oh, Clark asked, what is the most cursed problem you encountered in the porting process?
Probably the nil boxing thing. So I should explain that a little further. So in Go, interfaces are like a pointer to data, but a pointer to the type. But it's totally valid to implement in the Go interface with a nil pointer, which is really strange if you think about it. But like it's actually useful sometimes. But in TypeScript, if I say a function returns a or undefined, and then I return it through another function that is a different type entirely, it would just be another undefined. So like if I had a or undefined return through a or b or undefined, it's still undefined. But you end up in these situations where you try to return a specific type through an interface type, and then you don't realize that you've done it. So it was infectious all over our code base, and so we chose to just avoid the issue altogether and try to make everything concrete, which turned out for perf reasons as well. So that was probably the most cursed issue, but there's lots of other issues that I could talk about with Go.
So Oliver asked, how much of the speed up do you attribute to Go versus just rewriting, letting you optimize and clear out some of the backlog?
Basically, I could say all of it is language stuff. Like, there are some things that we improved, but the stuff that we've improved is sort of really minimal and more for us in convenience terms. So I would not say that it was actually just us rewriting things. We did find some goofy things that were like, oh, why the heck did we write it that way in the first place? And that's not good. But most of it was actually like bug related. Like we said, oh, actually this was a bug that we never realized was there. And so the performance, I think, was just totally attributable to language differences, like accessing an array. What does that look like in Go? It's like a single instruction load. What does it look like in JavaScript? Well, it depends on whether, like with the runtime, we'll optimize it. It can sometimes do pretty good. Other times, someone's patched your prototype, and now it's like slow as hell, right? So like, there's lots. It's just like a different world, right? So some things are faster in JavaScript, surprisingly, but a lot of stuff is just different in Go because of the way that it is. So. Pete
asked, should everyone else port their apps to Golang too? Why is the compiler special?
Well, no, you shouldn't, because it's a binary. So like your web apps, I mean, your front ends obviously can't. Like, I mean, you can put it in WASM, but like that seems like a bit much. Like, you're already in the DOM. Like, everything works great in the DOM. Like, please write your code in JavaScript. Not saying as a person that needs you to write JavaScript to continue working on the compiler for JavaScript, but I mean, for backend, like, it could make sense, but like, I think it's different. It's different. I mean, you gave the talk where you were showing RSC, like, you know, back end, front end, where the delineation doesn't exist. Like, it's a completely different style of code. So like, I'm not even going to claim that like one way is better than the other way, right? So I think the compiler is different because we need it to be as fast as possible for everyone, and like most invocations of TypeScript are either in the editor or at the CLI, where like you just want to be done with it, right? It has to go fast.
Awesome. Well, thank you, Jake. Everybody give another round of applause.
Awesome. Quick fact about the aquarium. One of the first things that you see when you walk in is the penguin exhibit. And there's 3 species of penguins in there: African, little blue, and rockhopper. And you know, you can kind of think of that as like a snapshot test, a snapshot of what they have and how they exhibit it. So if you ever see an emperor in there, you know that something's wrong, and you need to look into that. Anyway, without further ado, I hope that you can glean something about Gleam and snapshot testing from our next speaker, Giacomo Cavalieri.
Okay, thank you everyone for the welcome. It's such a pleasure being here in front of such a lovely audience. My name is Giacomo. I am one of the people who is working on the Gleam programming language. If you've never heard of it, it's a functional programming language. It tries to have great developer experience. I think it's something we all appreciate here. And really, I'm not here to talk about Gleam, though, but I'm here to talk about tests. And I'm the only thing between you and lunch, so let's get started with testing. So tests are really good. I think we can all agree with that. We do need tests. Maybe we are rewriting the TypeScript compiler, and we need to make sure that everything works right. And the simplest test we can write is a unit test that in Glim can look like this. So we are asserting that something is equal something else. So 1 + 1 should equal 2. And if math is not broken and we run our test, well, we see everything go green, and the tests are passing. If something is wrong, maybe there's a bug in our code, maybe we made a typo or something, we see the test failing, and we can go and fix it. So far, so good. Unit tests are really good for us, and they give us the confidence to change our code, even more importantly than the correctness aspect. Because with tests, we can change our code without that constant fear of some bugs sneaking into our code base. So 1 + 1 = 2 is a pretty cool example, but we wish that writing tests was this simple in real code bases. So let's have a look at something that is a little bit more involved. Let's say we are writing a tool to be used by developers, a command line tool. And the thing we love doing is writing tools that people love. And we want to make sure that, for example, there is a nice help text for the tool we're writing. That is the most important part of our application. That is what everyone is reading when they don't know what to do. And so, if we want to test that that help text we are producing is correct, well, if we're writing an assertion, there's really no escaping it. We need to assert that that thing we're producing is exactly equal to the given string. Now, imagine writing this kind of test. It can be quite boring, sitting down and having to write that. And that's the thing. Writing tests can feel like a chore, something boring, repetitive, error-prone, and something we do not want to do. And say we've been good, with a lot of teeth grinding, we've written all those tests, and now something changes. Now the tests are failing. What do we need to do in that case? Well, we need to go back, figure out where the strings have changed, where our assertions have changed, and go and manually fix everything. If writing them the first time was boring, now imagine maintaining these tests as your output changes. That is even more boring, even more error-prone, repetitive, and usually what we do is we say the famous last words, well, we don't need to test this. Of course it's going to work. So how can we make this better? Well, if you know the title of the talk, you might get an idea of where I'm going. Snapshot testing can really help us here. On the surface, it's pretty straightforward. Snapshot testing makes a simple promise, taking care of all those assertions for us automatically with little to no effort on our part. And that sounds a bit too good to be true, so let's have a look at an example. This is the test we would have written earlier with an assertion, and this is how we can rewrite it using a snapshot testing library, Bird in this case, which I'm the author of. So it looks a bit magical. Let's go over it. Here, we are still producing the content of the snapshot, the thing we want to be testing. There's no escaping that. But instead of making an assertion, we're asking the snapshot testing library to make a snapshot, whatever that means, and then we're also giving it a title. And this looks a bit mind-bending because there's no expected value there. How can the library know when the test should fail or should succeed? Well, it cannot read our mind. I'm not that good a developer, so no mind reading in Birdie. How does it work? Well, if we run our test, let's try it out, we see that everything fails. Not really exciting, because we are stuck in the red part of the red-green refactor cycle. We can't move on. So what do? Well, beside this failing test, we also see a little box now, a little output from our test, saying exactly what was produced by our function. And it's also giving us a little hint. Try running this to review the snapshot. So now things start falling into place. A human needs to be in the loop. Someone needs to be reviewing the snapshot. And I think that means it's time for something quite scary for me, that is a live demo. So let's see what this looks like in practice in a real project. So here I have my CLI, and I'm producing the alt text and snapshotting it. Here I'm using a little piece of syntactic sugar in Glim. This is basically just passing this as the first argument to the function. We can rewrite it like this. It doesn't change. So let's run the test, and we see that it fails. So let's do what Birdie is asking us here. Let's review the snapshot and see what the process looks like. Once we run it, we are presented with all the snapshots one by one, and we can have a look at them and see if they look right, if the output is indeed what we were expecting, or if there is a bug in our code. This looks right, so we can accept it. And now, this is where the magic happens, because if we run our tests again, everything goes green. We're no longer in the red part of the red-green refactor cycle. We can move on. What is happening under the hood is the snapshot testing library. It's saving those files, those snapshots in a file so that it can compare the output of your function with what it should look like. What we said was the right output. And this means that it can also be really smart if something changes, because instead of just making the test fail now, it can present us with a beautiful diff view of exactly what has changed, making it a breeze to review what has changed and see if the change is actually wanted, because maybe this is indeed what we wanted, or if we introduced a bug in our code base and we need to go and fix it. So we can review it again and look at it. And this fits in quite nicely with the way we're used to work with version control systems. We're already pretty used to looking at diffs, seeing if they are right, reviewing them, accepting them, or rejecting them. So it fits in quite nicely with our already working mental model of how these workflows should work. So this is right, we can accept it, and again, we can go on with our lives. Now, how simple is that? Instead of having to pinpoint for the exact change, the exact point where something has changed. So now maybe you're thinking of using snapshot testing in your code, and maybe you see places where it can be useful, but you start running into issues. Say we're testing now that our JSON payload has the shape we wanted. But if we do this, we get a compile time error. It says it wanted a string, the snapshot testing function, and instead we're giving it a JSON, which is not quite a string yet. It's an object. So how do we deal with this? Well, if our data is not a string, the answer is, well, turn it into one, which might be not totally satisfying, but we'll get to that. So here, we are turning our JSON into a string manually, and then we can go on, and this is our test. We can snapshot it and get all the goodies there. Now, this leads to a follow-up question that is, wait, really, do I really need to turn all my data into strings manually before I can produce a snapshot? And the answer, again, might not be to your liking, but it is yes. And that's actually a good thing, so hang in there and bear with me for a second. There's actually a couple of reasons why this is good. First of all, that means there's no hidden magic in the snapshot testing library. What you feed to the snapshot testing function is byte by byte what you're going to see in your snapshot, in the output. So if something looks off, you know that is your fault, and not the fault of some one-size-fits-all algorithm that tries to cram anything into a string. And that also means that you are completely in control of what your snapshot will look like, which is 100% of the times what you want to do, the right thing to do. So let's have a look at a couple of real-world examples of what I mean by this. And we will start with the Glim compiler. So this is a test that is testing the language server, which is an amazingly complex piece of tech. It's what is giving us code actions, autocompletions, syntax highlighting with little boxes, telling us the type of things when we go over them with our cursor. And here we're testing exactly that. So we want to make sure that if we are hovering over the Weeble variable, the language server is going to tell us that that is an integer, highlighting it, which might be pretty simple here, but if your expression is really complex and you cannot immediately see the type of it, it's super useful. So how do we test this? Well, we made a snapshot in the Glim compiler at first, just dumping the data structure the language server is replying with into a snapshot. And that is indeed the output we wanted. So it is highlighting the bytes from 24 to 29 in our original code. Those correspond to the Weeble variable. And then it's giving us a markdown string with the int string written in it, which is what we wanted. But I'm asking you, is this a good snapshot test? Well, I wouldn't say it is, because reviewing it is quite painful. After all, we're looking for a better developer experience here. So how do I know that those numbers are right? I need to go back to my code and painfully count the bytes, seeing that, yes, 24 to 29 are the bytes of the Weeble variable that is going to be highlighted. That's not really pleasant, isn't it? So what I set up to do is improve it and instead make a snapshot that looks something like this, that is showing us in the snapshot, in the original code, the bytes that are being highlighted. And how cool is that? Because at a glance, just like that, we can see that indeed that is correct. That is what we wanted to see. And we can see that the Weeble variable is highlighted, and the content of the window we're going to be seeing in our editor contains a markdown string with the int string written in it. Another example comes from a person in the Glean community. They were building a library to do CSS animations, and that can get quite complex. You can do linear animation, cubic tweening with ease in and out. It's really complex, mathy stuff that goes way over my head. But at the end of the day, what you need to do is you need to write the math. You are fed with 3 numbers, and you need to spit out another number, and that magically produces an animation or something. But how do you test this? How do you test that this implementation is correct? Well, you could go about it writing something like this. So we need to make sure that if we are interpolating 0 between 0 and 5, we get 0 back, and so on and so forth. And also, testing equality for floating point numbers is quite tricky. That's not really pleasant. Those numbers could be random, and they are. I put there random numbers. I couldn't be bothered doing the math myself. And that's the point. You cannot trust that those tests are actually right. Imagine you are someone reviewing this code. How do you review it? You need to sit down with pen and paper and make sure that the math is right. Not really pleasant. So what this person did is they used the function to instead make a plot, which is something we humans can actually look at. And then they are snapshotting it. And so the test now looks something like this. And isn't it amazing that at a glance, we can see that this is indeed a cubic function with in and out easing. Imagine reviewing this kind of test when you're given a PR, or reviewing a test where you need to sit down and do some math. I think one is pretty clearly the winner here. And it's amazing because we humans are really good at spotting patterns. We can see that something is correct at a glance, and that makes it pretty pleasant. And I also think it is a mind-blowing example. I would have never thought of making something like this, so I'm really happy that they showed me that. So that's what I mean by writing snapshot tests with an intentional look. We want to make sure that the look of a snapshot is making it easy to review, because that's what we want after all. We're switching to snapshot testing because we want a better developer experience. There's also a couple other rules we can follow to do effective snapshot testing. First of all, use long descriptive titles for our snapshots. Just like with pull requests, a title is kind of preparing us for what is to come. So for what we are expecting from this code, from the snapshot we will be reading. If we see CLI test as a title, well, that is compact. We've saved a few keystrokes, but it's not really telling us anything. If instead we see a long title that is telling us what to look out for in that snapshot, that's going to make our life a whole lot easier when we are reviewing it. Also, keep your snapshot small. With unit tests, it's pretty straightforward because it's in the name. A unit test is a unit. It's self-contained, it's small, it's testing one single thing, and should be independent from all the other ones. Well, this goes exactly for snapshot tests as well. So try to keep your snapshots small. For the same reason that on a Friday evening, you don't want to see thousands and thousands of lines of a PR, because reviewing that is a pain. No one wants to do that. And the same goes for snapshots. If it is thousands of lines long, imagine reading through that and keeping in your head all those things you need to be checking out for. It's really hard. That means that maybe you need to be refactoring your tests. Maybe you're trying to cram too many things into a single snapshot, and you could split it into different tests to make it more pleasant for yourself to review and for other people to review. And finally, and most importantly, I think, don't overdo it. I would never dare to write a snapshot test for something as simple as saying that 1 + 1 should equal 2, or something that can easily be tested with an assertion. We learn some new tech. It's really cool and shiny. We want to use it everywhere. But sometimes it's also good to use something else. Still, I do believe that snapshot testing should really be the default, and then you fall back to unit testing when something is not the right fit for the tool. And if you don't trust me, we can have a look at the Glean compiler, for example. Here we have over 4,000 tests. And out of those 4,000 tests, try and guess how many snapshots are there. Well, it's way above 3,000. And I cannot understate how much time this has saved us. Because one, writing tests is Well, pleasant. You write a test, you see some visual output, and you're good to go. It's pretty nice. And as reviewers and people who have to merge code, seeing that there's a snapshot and that it looks right, well, that is life-changing, because it's way easier to visually inspect something and see that that is correct, rather than going through the code and having to inspect all the little invariants and be careful about everything. And so this is it. This is snapshot testing in Gleam. Hopefully now you can appreciate how this can lead to smarter testing, while at the same time doing less work, or at least doing something that feels pleasant and not like a chore, boring and repetitive. And it really is a great tool when writing the tests and the assertions starts feeling like a chore, is boring, and even more importantly, when maintaining those tests, like maybe in a TypeScript compiler, can be really hard if your output changes, and you want to make sure that that stays the same. And so this is it. Thank you so much for listening to me today. Let's keep in touch. All the examples I have here come from people who have told me about snapshot tests. So if you have any interesting snapshot testing stories, or you want to learn more about Gleam or whatever, well, you know how to reach me. My name is Giacomo. The little starfish you see here, which now I realize fits in quite nicely with the SquiggleConf theme, is Lucy, Gleam's own mascot. And thank you so much for listening to me today.
Thank you, Giacomo. Please join me in the squiggle chairs. And thank you again to the audience for the lively chat. There are a lot of great questions in there. Let me start with the first one. This one's from Becca Miller, and it looks like she clarifies, but what's too big to be a unit test but still small enough to be a maintainable snapshot?
Oh, can I use the "it depends" answer?
Of course.
Well, I think as a good guiding principle, I always like to start with thinking, how can I make this a snapshot? So my default is try and make it a snapshot, because it's really hard to have a unit tests that are really that small. So by default, I try and see if I can fit it into something cohesive that looks nice in a snapshot and is easy to review. If you feel like the pain of writing it starts overcoming the benefits, and the test is not really going to change over time, well, then I think it's a good place to use a unit test assertion.
Nice. Another question. What are the trade-offs between inline and file-based snapshots? This is from David.
Oh, I've never really worked with inline snapshot testing. So for the audience who doesn't know this, inline snapshot testing, instead of saving the snapshot to a file, saves it right in your code. So you will see that in a string in your code. I cannot really give you an answer because I haven't worked with that, so I'm not really authoritative on that.
We love it when you say you don't know. LLMs do not do that often enough, so thank you. Do you ever write the snapshots by hand to do test-driven development with the snapshot tests?
No, I usually start with a pretty printing function that will turn my data, my asserted data, into a snapshot, and I think that putting some work into that is going to pay dividends later, because it's going to make the whole, then writing tests a whole lot easier for many different tests.
And I think we have time for one more. Let's see. Are the snapshots themselves diffable and stored in version control? Is that how you'd recommend using it?
Yes. You actually need to store the snapshots in your version control system, because those will be needed by any CI test running that is going to look for those snapshots and then compare the output of your tests. So yes, you will need to keep track of them in your code, because they're just as important as your code. Snapshot testing is sometimes called golden value testing, because those are your golden values. Those are the things you care about, and so you should be tracking them.
Awesome. And then I'll sneak one more in here. When can we expect a Go port of Gleam?
I don't think anytime soon. We have written the compiler in Rust, so...
In Rust.
Yeah. When can we expect a rewrite in Rust of the TypeScript compiler?
All right, thank you so much, Giacomo.
Thank you.
Let's give him a round of applause.
Thank you.
This way. Thank you.
Awesome. So next up on the schedule is lunch. We just wanted to offer a few recommendations. So the first one is State Street Provisions. So this is across the street. There's directions there for walking. It has some great comfort food, seafood, burgers, lobster rolls. So if that sounds interesting to you.
Yeah, and the next one is the famous Faneuil Hall Marketplace. This is a very famous food market. It's kind of like a food court. There's dozens of restaurants in there with a wide variety. And if you're interested in lobster rolls, there's multiple vendors within there.
I feel like lobster rolls
Yeah.
the thing to do. There's also Ned Devine's. So this is a cozy Irish pub. I was looking on their TripAdvisor. It looks like they have a lot of fish and chips, burgers, if you're interested in that, seafood, clam chowder, fried clams.
And finally, Wagamama. This has great ramen, rice bowls, curry, and more.
Awesome. So those are the recommendations. Before you leave, though, we do want to take a family photo. So I'm going to give a few instructions. If you guys want to head this way, there's cords on this end. So we're going to file out this way and take a picture down here in the front. We want to try and get everybody to push forward so that we're within the light. We want to be able to see everybody's face. So, and then we will see you back after lunch at 2:15. So if you guys want to come on down now, we'll take that picture.
Thank you.
time following tutorials when I first got started. I would try to run a tutorial, and it just wouldn't work. I would try to run sample code that I found in an API reference, and it just failed, and it just broke. And it was really kind of hard to kind of follow along. And so that led to me kind of sharing code publicly via talks, via writing, and then I became an educator, and I taught a class on programming at NYU, and then I started doing developer relations. And so while I was doing that, a lot of the tasks assigned to me was sample code related. So I would write sample code for a new API that was launching. I worked at Twitter at the time, and we were launching like a new set of endpoints. And so I was the one who wrote all the code for that. Or I would write tutorials, and that would be sample code. And so I really started to think about sample code. And in 2019, December of 2019, somebody asked me to submit to speak at Brooklyn.js, and I was like, oh, I'm not really like writing a lot of code right now. I'm just writing all this sample code, and like it's really different. And so that's how I got started giving this talk. I haven't given this talk in a long time, but really excited, just because my friend was like, wait, there are like a lot of cool things that you're talking about and thinking about when you think about sample code, and it really helped me become a better developer just through that process. So you might be wondering, what is sample code? So sample code is code for others to use. It is code that usually lives in documentation, quick start guides, blog posts, videos. It is really just code for others. It is code that I sometimes usually live code at conferences like this one. It is really any code that is not designed for like end-to-end use, but designed to kind of kickstart you and help get you started. And there's a couple of core principles I think about when I think about writing sample code. So a lot of times people ask me, because I do developer relations, and I'm a tool creator, I make code for others, right? I have a lot of open source projects, things like that. And so people are always like, are you a developer? And I was like, yeah, I'm a developer. I write a lot of code. And my job is not only to write code for a small team of others to use, my job is to write code for millions of people if I do it right. I want you to take my code, and I want it to live in your code base at some time in its life cycle. And so our job as people who work and create tools is to write code for millions of people. And so when I think about this, I think about kind of like, I really want you to kind of take a look at the code sample and be like, oh my God, I didn't know I could do that. Wow, like, whoa, all right, like, now I know how I can make my code happen. Wow, I didn't think I could do the thing. And so for me, optimizing for wonder is like one of these core principles that kind of drives me to kind of create sample code. And I really kind of think about it as like, all right, I want you to just be in awe when you see the code, but I also want it to be super simple. I don't want anything that doesn't need to be there. I want you to take a look at it and know exactly what's happening, and to really kind of make it as simple as possible. A lot of times when people look at my code, they're like, whoa, that's simple. And I'm like, yeah, I did it, cool. Like, I want that. That's like the response that I want. I want you to be like, whoa, I never thought I could do this, but balancing that like clever with that simplicity. And I think good sample code does this extremely well. And yesterday I was having a conversation with Oliver, who's somewhere, I think, in the audience, and he asked me about when I write sample code, if I write sample code in TypeScript or JavaScript. And my response was, well, who am I writing the sample code for? And this really kind of gets into kind of thinking about your audience. The answer to Oliver's question is both. If I'm writing for TypeScript developers, I will write in TypeScript. If I'm writing for JavaScript developers, I will write in JavaScript. Sometimes I'll do it if I want to hit kind of a broad segment of people. But really, when it comes down to it, the question I ask myself is like, who's my audience and how do they want to see code? And so tailoring code to the skill level of the intended audience, this is like that timeless factor. Whether you're making like beginner tutorials or advanced API docs, respecting your reader's background, and it really kind of helps prevent frustration and build confidence. I know that for me personally, once I was able to get some sample code up and running, I was like, oh my God, I did the thing, I felt the thing. Like, that feeling is what makes developers want to keep using your product for a long, long time. So let's think about how sample code is different from regular code. And And this is something I spend a lot of time thinking about. So I've been helping out today at the Elastic booth, and if you go to the booth, you'll see a banner. And if you look behind the banner, it's really messy. And so when I think about code for proof of concept applications, this is just like, a lot of times, like, kind of my side projects, I make a lot of music with code, and it involves sampling myself screaming, and like, a lot of that code just works. Some of it, like, literally is stuff you should never do, ever. Like, I play a lot with like loudness and things like that, and it's super messy. But it gets the job done, and it works, and it makes sounds, and it makes like loud, aggressive sounds, and that's what I want that code to do. And like, it's messy, but it works. Just like the banner that we have at the Elastic booth. It's messy, but it works. And then when you write code as part of like a software engineering team, you really want to make sure that your code doesn't cause any bugs. You want it to be part of a system. You want it to play well with others. This is very different. It's similar. There's some similar capabilities, and there's some similar things you want to think about. But really, at the end of the day, you want your code to be part of like a larger system, especially because most of us work in modern systems that have lots of microservices. We really want to make sure that like when we're writing code, usually at work for maintainable systems, we really want to make sure that it's kind of to the point, but it also just like prevents anything that could possibly go wrong. And that's a bit different from sample code. Sample code, the way that I like to kind of think about how this should work is like, can you build off of it? I like to think about sample code as like Lego blocks, and I am like the first Lego block. And I actually had this experience when I worked at Twitter. We had launched a new endpoint called Filtered Stream, and I like wrote a demo using Filtered Stream, and I actually wrote the sample code for the Filtered Stream endpoint, and then I tried to build my application on top of that. Like, I literally just cut and pasted my own code and tried to build on top of it, and I was like, whoa, this was like an educative experience. I learned so much just building on top of my own sample code, and that's really kind of like the point of sample code, is that you want your users to be able to build on top of it. So, sorry, just getting used to using a clicker. Yay. All right, so let's talk about the process for building sample code that I use. So the first thing I want to kind of talk about is kind of how I get started writing sample code. So for me, a lot of this is kind of, I spend a lot of time just building code, but I also like will do screen recordings of me building. I'll take a lot of screenshots. I've even had like a notebook where I've like literally written any bug I've faced, anything like that, because that can later become a troubleshooting guide. Anything that wasn't like super straightforward, I could use that. And it can become a tutorial. It can become the troubleshooting section of my GitHub repo where it might live. But I also record like all of the things that go right and wrong, so I learn about my process, and then I take screenshots along the way as well. And really, at the end of the day, your code is your first impression, especially if you're building developer-focused tools. So using linters like ESLint and Prettier Run, that's really helpful. But for me, while building sample code, I'll actually take my messy code and run it through a linter, and I'm like, OK, it's less messy now. And that's like that confidence boost that I need. I think about it like putting makeup on the code. I'm like, all right, cool. Like, it's looking a little bit better. I'm getting in that, like, I'm getting there. And so, yeah. I am currently a tech reviewer on a blog called Search Labs for Elastic. And what's really interesting is that like our sample code uses a linter called Black. And so it's been fun to kind of like see the code transform over that as well. So the thing I think a lot about when I'm making sample code is how quickly can you get to Hello World? So it was funny that we talked about a bridge as part of the introduction. And I think about sample code as like a bridge. Like, my job is to help get developers to where they want to go. I want to inspire their creativity with simplicity, but I also want to kind of provide that bridge for them to kind of build into their own applications. So really, like what I like to think about is I want you to get started as quickly as possible. I want you to get past the Hello World part of building as quickly as you possibly can. And then from there, then you could build something awesome based on that. And then I really kind of like think about that as I kind of go through my code and do like another round of refinement is like, okay, like what is the quickest path to move forward? And then from there, I like to think about what is the kind of that one singular goal? What is the most atomic singular goal that I can address with my code? And then from there, I really like to be able to kind of look at the code and know exactly what's going on. I want it to be realistic but minimal. I want to show practical usage without overwhelming boilerplate. And I want to provide context, kind of letting my readers know like where and why it's useful. And then there's a couple of things I like to keep in mind during the process. One, I want to have my code be readable. I want it to be reusable, and I want it to be consistent. So I want to have kind of variable names that matter, that you can be like, oh, I see what's happening here. That makes a lot of sense. I personally, when I write code, raise your hand if you do this, I have a lot of like one-letter variable names in like the messy but work stage. Like A, I have so many variable names, A. That's not really helpful for sample code because you can't look at the variable A and know what's happening unless you have like a product called A, but most of us don't. And then, especially when I'm like writing code at first, I'll have lots of the same variable names. I'll use like nested things, and it can get really complicated. And you don't want any of that for sample code. And you want your function names to be readable, but you also want to have like functions that can be reused throughout your entire code sample. And you want to make it consistent, so you're not doing one thing in one part and something different in a different part of the code sample. You want it to be kind of like one consistent way of having that. So yeah. And then the other thing, this is actually my favorite part of talking about this, is functions like paragraphs. So a lot of times when I write tutorials, I'll start with an outline, and then I'll write the code sample. And I'll try to make the code sample look exactly like the outline. And I like to kind of think about it like each of my functions are paragraphs, and then from there, the main function that I have at the end, that's the conclusion. And I think about it as if I'm like writing a story. And that's been a really helpful framework for making my code super modular. And modular code is really great for testing, but it's also really, really great for writing sample code. So each function only does one thing. You can test each piece individually, which you totally should do for sample code as well. And functions kind of work together like building blocks. They can be used in many different contexts. So at a high level, my process is that I have the working code. From there, I figure out what the goal is. From there, I figure out kind of like what is that most simple version. And then I make it as modular as possible. And then I try to break it, which is super fun because I can like basically be like, okay, cool. Like now that I have everything kind of working, what if I take out lines? What if I like try to twist it up? And that's usually like the point where I'm like, okay, like now I'm really getting to that point. And then after I figure out how to break it, then I can, from there, kind of turn it into something bigger. So I spent a lot of time kind of refining my code samples. I really want it to be simple and to the point. I almost always like feel like a slasher where I'm like, okay, so what doesn't need to be there? Let's like delete, delete, delete until you get the simplest version. And then I spent a lot of time thinking about security by default. I want you to be able to look at the code sample and figure out exactly what that main point is. And I don't want it to be too long. I want it to be like, kind of like a medium, short to medium in length. And then from there, I break it up if it's too long. And then from here, I love having lightly commented code. I used to be like the type of gal that was like, nah, my code, like, I want you to be able to look at it with no comments, but I've learned that like, I've kind of relaxed my stance on this, and lightly commented code actually works really well. So I don't want to have like essays, I don't want anything too long, but I do want enough context that you can kind of look at it and see what's going on. I get really distracted if there's like, if every line of code is commented, it's just hard for me to read. And I've also found that like while writing code, code comments can become relics really easily. I'll keep something in and then I'll make changes, and then like 6 months later I'll be like, wait, what? Like, that comment doesn't even make any sense. And so I really try to make sure that that is something that I'm considering and thinking about. And then going beyond the code sample, I have some thoughts about READMEs. So I want them to be really simple. I want them to provide the structure of all of the code that's in the repository. I want to know how to set things up. I want to know how to run it. And I also want to know any like troubleshooting pieces of information that are needed. And then the other thing I love is playgrounds. I love kind of making interactive code samples. I love creating these types of tools. At Elastic, we have a generative AI playground where you can actually like cut and paste the code. And like I was playing with like some RAG applications a couple of months ago, and I was like, whoa, okay, cool, I get the code. And I love having that code as that starting point. And the first place I ever played with this, and it felt really magical, was with Postman. And I remember like the moment of like playing with the API parameters and being like, oh my God, I get this code, and like I could see what's happening. And that to me like feels really magical. And so I love when there is kind of that reusable playground that you can play with, and that you have that kind of interactive moment where you're like, oh, cool, like, let me play with this, and then let me see the code, and then that code can end up inside of my application. And I think about that a lot as I'm creating code samples. And then you also want to make sure that you get your sample code reviewed just like any other code. I've worked a couple of places where we've had a lot of rigor for like code that's shipped, but we don't have that same rigor for code samples and code snippets. And the way that I like to get started is to start off by actually having AI review my code. And this is something I got started with pretty recently. I saw my friend Adrienne speak at Nebraska Code, and she wrote the book, Looks Good to Me. It's about code reviews. And she was suggesting that AI is a pretty good starting point these days to start with code reviews. And I actually tried it for my last 2 code samples I wrote. And actually, one of the things that AI brought up that I was like, nah, AI, you're like hallucinating. Like, I don't think that's the issue. It actually came up twice in peer review. And so it's kind of interesting to kind of start with that as well. So I, these days, get started with kind of having an AI review. The prompts I use is, tell me what's good about this code sample. Tell me what needs to be improved. So I get like kind of the full context of that. And then from there, I try to go into peer review. I try to get a diverse group of people. Subject matter experts, absolutely. People who have never used the technology before but are really strong in whatever language that I'm writing. That's also a great type of person to try to get that peer review from as well. And then I try to iterate and try to like respond to some of the feedback I've gotten and really try to like incorporate it. And then I spend some time building on top of the code. And then I try to get feedback from the wider community. And I find that this is actually really helpful for like making my code samples better. I was on the Twitter developer community forums when I worked at Twitter, and somebody saw a code sample I wrote in R, and they were like, why did you use this technology? And it was like, I think it was like one of the methods I use. They're like, nobody uses that, but it is faster. And I was like, yes. And then I asked some people from the R community that I knew, and I was like, hey, what do you think of this feedback? And they're like, actually, like more people use it this other way. And I was like, okay, cool, I'll make that change. And so being able to kind of get that feedback and listen to it is really important. And then if you've ever had me review your code sample, you may know this, but I, especially if I'm reviewing a tutorial, I will try to like make it work. And I will like pretend I know nothing and just try to build with it. And really try to like break it in as many ways as possible. And this may sound silly, but your users are going to do this. And so I really try when I'm reviewing to like, you know, especially if I'm reviewing a tutorial, I will like run every single line in the tutorial and try to like follow the directions 100% as written. And that's really helpful for like illuminating how people are going to use it, because, you know, with a lot of our sample code, people come from many different backgrounds, many different education levels, many different cultures, and so you never know how people are actually going to be working with it. So really thinking about accessibility in that process is really helpful, and really making sure that like it can work is really helpful. And sometimes I've had code that's worked, and it works for a long time, and then it doesn't work. Raise your hand if that's happened to you. That's happened to me more times than I can imagine. Code doesn't age very well, especially in the modern age. Things move really quickly, especially in the AI space. And so, you know, deprecated libraries come up. Especially if you're using AI, it will often feel like it's stuck in the past when it's creating code for you. And you'll be like, wait, what? Like, that is not the practice that is best practice anymore. But I could see at the time of training that that was the best practice. And so thinking about that is really helpful. You know, avoiding deprecated libraries, thinking about security, all of that is really important. I wrote some code recently that used fast MCP in the Python context. It was actually really weird code that I'll talk about in a minute that actually is Python code that generated TypeScript. And from the time I started the project to the time that I finished it, fast MCP 2.0 came about, and I thought that fast MCP was like bleeding edge when I started using it, and within like 3 months, there was already a fast MCP 2, and some of my code went out of date really quickly. So let's talk for a second about AI. Please, if you're using AI to generate code samples, that's okay, but review it just like any other piece of code. Make sure you're having that level of rigor with it. It's okay to have some AI help, but you want to test it and make sure that things work the way that you think that they do. And so, yeah, let's talk about a piece of code that I wrote recently. So I built this MCP server that basically will generate elastic synthetic tests for me. And it was kind of cool because it was Python code that generated TypeScript. And what was really interesting about it is that the first time I was using the code, or I wrote the code, my MCP server like basically talked itself into a loop and couldn't create the tests I was trying to get it to create. And I was like, oh my god, like 20 minutes, and then it like ran out of tokens, and then I wasn't supposed to use that endpoint for like a month, which was really funny. And so from there, I was like, okay, let's make sure that the mechanics work. So I spent some time like really testing and making sure that the mechanics were working. And so I had this like templated test that would always kind of return the same things. And I found that like to prevent the LLM from going too crazy, I was able to kind of combine it with like my own kind of templated code to kind of create sample code. And I really wanted to make sure that like when it would output the results, you can actually see what was generated by the LLM and what wasn't. And this was actually something that was like really important to me, was to be able to kind of, for you to be able to see what came from the template, and also from you to be able to see what came from the LLM, because early versions had a lot of issues. And then testing is super important with code. And this is no exception for sample code. One of the companies that I worked at, we had a bug bash, and we would include our sample code as part, and our documentation as part of the bug bash. Creating tests for code samples is super important, and also employing observability tactics is super helpful as well. And then feedback loops. Make sure that you're open to feedback. I like to start from a blank slate. I like to run things in as close to a fresh environment as possible every time, because just in case I don't have a dependency or something that I needed, it's really helpful. And then I also like to have a lot of analytics and feedback loops. I love having automated validation, CI/CD pipelines to lint, test, and update code samples continuously. And also, just make sure that you're testing your code samples and making sure that everything works as written to maintain credibility. So I have some key takeaways to kind of close things out. One is keep your code clear and simple. Write code that anyone can read at a glance. Test your code samples. If you take one thing out of this talk, test your code samples. And then also make sure that you're providing context and intent. Automate your testing using a CI/CD framework, and also design for inclusivity and security, and think about accessibility. Think about the wide range of developers that may be using your sample code. There's a couple of things to avoid. Overly clever, dense code that prioritizes flair over clarity. Insecure libraries with things like hard-coded API keys, outdated libraries, unsafe practices. All of that is not the best. Yeah, do not have insecure defaults. None of that. You want to avoid having raw code with no explanation of where, when, or why to use it. And I don't know if you've experienced this, but I've tried to work with code samples in the past that have had kind of like Docker containers that are super confusing, examples that require like lots of instructions with cloning repos, heavy dependencies, complex setup. Just to run a hello world application is always like too much for me. So really try to keep it as simple as possible. Thank you so much for having me. If you want to see kind of a lot of the code I've been reviewing, take a look at Elasticsearch Labs. All of the code and everything can be found there. This is one of my favorite topics to talk about, so thank you so much to SquiggleConf for making this happen. I'm actually getting married at the aquarium in December, so I was like really, and so I was really excited to both be speaking at a JavaScript conference and getting married in like the same facility. So lots of fun things are happening. I've always wanted my code to be on iMac screen, and that's happened. So yeah, talk to me about sample code. I want to know what's working for you, what's not working. If you agree or disagree with anything, if you're building sample code, if you don't know how to get started, please, please, please talk to me about sample code. It's one of my favorite topics. Find me and talk to me about sample code. Thank you so much for having me. And yeah, really excited to be here.
Awesome. Thank you, Jessica. You can head over here for a round of Q&A. I think what I appreciate about your talk is that a lot of things with sample code are just really good coding practices in general.
Yeah, I think that's right. I think the way that I like to think about it is a lot of just like writing good code. I think the one thing that's like the most important is to like make it modular, because like you really just want people to be able to like figure out kind of like what's happening. I know for me, sometimes I spend a lot of time when I first get started, like I'll just write everything like line by line. I won't even care about like functions or best practices. And then taking that time to kind of make sure that I incorporate the best practices and put in things like error handling and things like that, that's really helpful.
Awesome. We had a question from Owen. Sometimes samples omit imports or dependencies for brevity. I even thought about that when I was putting my presentation together. I didn't include a bunch of import statements at the top. It looks better at a glance, but often it makes things ambiguous, especially with copy and pasting things. So slightly longer, but more complete, explicit, but not as elegant for showing off. So where do you kind of draw the line there with sample code versus just saying linking out to a demo app?
Yeah, this is something I think about a lot, and this is actually, you know, if you read any of my tutorials, they're always like, everything is included, and I've gotten some feedback that it should have kind of some more of that like high level, like not everything needs to be included. Owen, you mentioned one of my pet peeves, so thank you for that. Every time I see that on a screen, I'm always like, nails on a chalkboard, mostly because like, I remember one of the first mistakes I made as a developer was that I cut and pasted like some sample code, and I was like, oh, cool, like here's my API key. And then of course I committed my API key to GitHub, and that was like, you know, a junior developer mistake. I'm sure I'm not the only person in this room who's made that mistake, but I did cut and paste a code sample, and I think about that moment all the time. And so our job, you know, we're not just speaking to people who speak the same language as us, we're speaking to people who want to speak the same language as us and who might not be able to. So, you know, it is a balance, and being able to balance that like cleverness, especially if you're showing like very long code samples, mixed with that kind of like simplicity is something I spend a lot of time thinking about. Thanks, Owen, for that question. That's something that I've noticed in the past.
Catherine asked, do you have a method or a process for maintaining example or existing code samples? We struggle with keeping our code base of sample apps and demos updated with every release. So whether that's a React release, a framework release, or a product release.
Yeah, so I actually have, especially when I'm in the developer relations context, I have a calendar invite for myself to look at my old samples and just like run it. I know that I've had this happen where like people have messaged me on building with tutorials that I've built, and they've been like, hey, like I'm stuck at step 5, like what's going on? And then I'll try to run it, and I'm like, I'm stuck at step 5 now too. And so I really try to like have a calendar invite. Some of the linting techniques help, some of, you know, having, you know, using CI/CD, things like that, that helps. Tests help, so you know when your tests are breaking, but really like, especially with some of it, just spending that time and just making sure that you're like, you write the code and then you put a calendar invite 6 months from there to be like, okay, let's test this. That's like a process that really helps for me. And I'd love to hear from others if they have processes that work for them too.
Ho asked, I have the opposite problem that you mentioned with your variable name A.
Yeah.
I have an obsession of trying to name variables as exactly as what they really do, and they end up being really long and hurting readability in a different way. So do you have a tip for naming variables in a descriptive but succinct way?
Yeah, I try. So this is something I've been doing lately is I've been using actually a thesaurus, or I'll be asking for one word that describes that. That helps. I really just like, for example, if I'm building, you know, let's say I'm building an MCP server, because that's one of the examples that I showed today. And I have kind of like a variable that kind of makes that happen. I'll call it something like build MCP. But yeah, I have seen the opposite problem in action, and then just kind of thinking about simplicity. And this is also one of the things that like as you're refining your code samples, making sure that you like take a look at it, taking like walk away from it for a second and then come back to it, that really helps. And being like, oh, well, like even if I made this change, can I still read it? Also asking your colleagues for help. Peer review is always really helpful to be like, hey, like I don't know if this is descriptive or not. Like, can you tell me? And especially looking for like newer developers on your team, that can be really helpful. I'll ask the next question.
So one of the questions that Pete asked was, how do you start from a blank slate when testing code samples? Are you using like a Docker container or something like that?
Yeah, I do a lot of Docker containers. So I write both Python and JavaScript, and as I showed, sometimes Python that makes JavaScript. One of the things that I use a lot is virtual environments in the Python ecosystem, Docker containers sometimes. With Elastic in particular, we have lots of different ways to set up clusters, and so you could host, you could host your server on premises, you can run it locally, you can, there's lots of different options. You could run a cloud service for it. So I'll try it in all 3 different ways, just to kind of give it like, to be like, okay, I'm starting from scratch, I'm making my server, now I'm running the sample, like, does it work? And that's really helpful. So yeah, lots of just like, trying to be to start from a blank place as much as possible. I used to have a Windows computer because I would work on a Mac, and I would go home and run my same code because it was all publicly available on my Windows machine. So yeah, the more I could do it, and just different ways, different virtual machines. I'd love to hear from others about this too, but I've tried pretty much everything that you can think of to like, I've even asked like people who I knew didn't have the same background as me, being like, hey, can you run this? Cool, like just let me know what happens. Like, can you follow these directions and just let me know if it works? And that's really helpful.
Yeah, that's a great point. Not only testing in terms of unit testing, but also platform testing. But thank you, Jessica, for your talk. Appreciate it.
Yeah, thanks for having me.
Thank you, Jessica. You know, as I walk through the aquarium, I think a lot about what that's trying to do. It's trying to show you what these marine animals look like in their natural environment. But they're not in their natural environment. They're in a safe aquarium. And there's things that keep them alive and keep them healthy, things like the filters. If you think about it, that's a lot like Storybook, right? Storybook is like an aquarium for your components. And the healthiness of that is, the filters for that is like the accessibility, making sure that they don't just look pretty, but they're healthy. And to talk about Storybook and accessibility, we have the creator of Chromatic and maintainer of Storybook, Dominic Nguyen. Dominic, head on up.
Thanks so much, Nick. Really appreciate it. Hey, everyone. So yeah, my name's Dominic, and I want to just start off with expressing that this is a safe space. And I want you to raise your hand if your team has done an accessibility audit ever. All right, keep your hands up, okay? Keep your hands up if that audit has taken longer than a week. All right, and keep them up if they've taken longer than a month. How about 3 months? How about, I see one person, 6 months. Now that we're being honest, did that audit have the impact that you were imagining? It didn't for me. And it didn't for a platform engineer that I spoke to just a few weeks ago. And I see this all the time. You spend months on VPAT. For those of you that don't know what that is, that's a voluntary product accessibility template. It's basically like a manual checklist. Think about your worst Excel nightmare. That's what it is. And these things take a really long time. And by the time you're finished, your code base has moved on. It's basically outdated as soon as it's complete. And so everyone gets a back patch, sure, but deep down, you know, hey, nothing actually changed, right? Nothing's going to change. So hi, everyone. My name is Dominic. Nick gave me a really fantastic intro. I'm the co-founder of Chromatic, the company behind Storybook. Storybook, for those of you who do not know, it's an open source front-end tool. It's downloaded by 38 million times a month. It's used by half the Fortune 50. And I'm here to share our plan. Oops, how did that get there? Our plan to make every front end accessible. And what the hell do I know about front ends, right? Well, I helped launch Apollo GraphQL, design the first logo, helped ship the first cloud product for Apollo. I worked at early days of JavaScript at Meteor.js. It was the first full-stack JavaScript framework, responsible for things like pioneering hot module reloading, client-side data in JavaScript, component architecture. And I noticed that, like, look, the industry has been pushing web accessibility for the last 20 years, right? And kind of all we got is this really laggy and expensive process that is centered around these VPAT reports. It's like Office Space has come to life, and I'm now living in it. And meanwhile, there's a bunch of regulation that just passed a couple months ago, and more is getting added every day, that puts accessibility on the same level as performance and security in terms of like compliance. So this new regulation is like has teams scrambling, like, oh my God, like what am I going to do, right? I don't want a lawsuit, scrambling to reach this compliant state. And since code is ultimately what is under scrutiny, it's us developers that are kind of left holding the bag, right? Like whether we want it or not, it's like our responsibility all of a sudden. And this responsibility comes with a couple of challenges, right? It's tricky to scan every state of your app. You have pre-existing accessibility debt that wasn't even your fault, but now you have to deal with it. You have to prevent new violations while continuing to ship code. And the issues are found too late because they are often found by manual QA people outside of the development pipeline. And because of these challenges and how structural they are to teams and organizations, you end up hearing two opposing truths. The first truth is, hey, accessibility is the right thing to do. Like, you've probably heard that, right? Like, sure it is. And also, accessibility slows my engineering velocity. And depending on where you sit, those things can both be true, or either can be true. We're kind of in a dilemma here. And this reminds me of conversations that we had about security and performance in the last 20 years. So it got me to thinking, and the Storybook team to thinking, like, golly, what if we took a page out of those playbooks and treated accessibility as a pipeline instead of a checklist? So in development, if we treated it as a pipeline, you would be able to test and fix locally, and all in a component-first manner. And you can do that with a tool like Storybook. In CI, you can catch regressions across every single state of your application automatically. And it tells you when you're wrong, so you can fix it immediately in your development process instead of like weeks after in QA. And then after you merge, well, what if you could get a instantaneous report of your compliance status delivered to you that tracked what you had, like the progress that you made, and the progress that you still need to make. So I'm going to jump over here for a demo to show you what that could actually look like. And bear with me, this is a live demo, so I might get things wrong. You might see a blue screen of death here. All right. As you can tell, I was looking at cheeseburgers. No. So first of all, for the folks that don't know what Storybook is a way for you to express every single state of your application, to be able to teleport to that state later. Now, why the hell would you want to do this, right? So let's take a look at this restaurant card, for instance. So this restaurant card has a bunch of states, depending on if it's new, if it's a closed restaurant, if it is loading. And in my application, this demo application is what we call meal drop. It's basically an Uber Eats, right? And why you want to do that is because sometimes you don't want to run the entire app stack in order to jump directly to the state that you're working on. You might have to work on an empty state. You might have to work on a loading state. You're not trying to kind of seed a new database on your local machine in order to do that. So Storybook eliminates that pain for you and helps you focus only on the front end in front of you. So now, pretend that I had my PM asked me to change a badge color to be consistent with the banner. I effectively want to make my badge have this tint. So I'm going to go and do that by jumping into Storybook, finding my badge component, right? Here's what it is, or here's where it is. Let's zoom into it. So that's what it looks like. And my job is to change the color. Simple enough, right? And one thing also to note is that Storybook has accessibility scans built right in. So you can instantly see what the status of this component is as you're developing. So all I have to do is go into this badge.tsx, change the color of badge to banner, right? Easy. So over here, I can see that everything passed. I'll rerun it again just so you know that there's nothing magical happening. It's just scanning this component and telling me that things are looking great. So I'm ready to commit and open up a PR. So I've opened up a PR over here with the changed files. Let's see if this works. Yep, exactly as I imagined, right? But as I scroll down, I'm looking, a bunch of checks have run for me in CI. And some of these checks are UI tests. And UI tests correspond to these accessibility tests that I'm running on every single state. So if I click on this, that's going to take me to a tool called Chromatic. So Chromatic does accessibility regression testing, basically runs a bunch of parallelized browsers and tests every state in parallel. So you can see, like, oh, I thought I had fixed this, or I had updated my badge and everything was accessible. Look, like there's no changes, but clearly something is wrong, right? So if I click on this, I can see, hey, there's clearly the badge didn't do what I wanted it to. Why is that? So if I click directly on the component, I can see, look, there's a color contrast issue here, but I thought I didn't have a color contrast issue. So if I go to Storybook, which can also be published online, I can see that, hey, this badge that was tested, that should match my badge in development, is actually, like, there's an issue, right? Like, and there's clearly a color contrast issue. Now I can go back to development and see, like, oh, you know what? I think it's because I was only testing this badge in dark mode. And if I go to light mode, I'll see this violation appear right in front of me. And so that's an example of just quickly getting accessibility feedback directly in your CI pipeline. But that's not all. So if I continue going through this, I can see the unintended side effects of my badge change across my entire application. And so here it is in the restaurant card. Here it is in like multiple states of the restaurant card. The category page for restaurants, even on my home page. So what you're seeing is like the cascading effects of how an accessibility error in a component can actually manifest itself across your application, kind of wreaking havoc on you as a development team. All right, so what is actually going on behind the scenes? So Chromatic captures a baseline of accessibility violations and then compares any new commit to that baseline. So it effectively is all your violations at one point in time and then compared to all your violations that you just committed. And in diffing those two things, you can see what is new and what's changed to quickly identify, hey, this is actually my fault. On my PR, I made this error, not, and you can ignore the other errors that other people made. Cool. So that's a really quick demo. I wanted to show you one more thing. So this is an accessibility dashboard that we've created for Chromatic and Storybook. What it does is it tracks your accessibility posture over time. Now, why the hell is this important, right? If you are running, if your organization has been around for longer than 2 years, you probably have a mountain of accessibility debt that you have yet to resolve. Now, you could do nothing about it and keep the status quo, but the status quo is actually going to put you at risk. Or you could track it and see how that compares over time and how your efforts to fix and remediate these issues are having an impact on your compliance status. So this is the actual compliance. We have the actual number of violations that we have for chromatic.com. 7,506. Now that's a lot, right? God, like, I guess I should be embarrassed, but really, like, where we started was 18,000. And over the past 3 months, we've been, like, a lot of folks in our team have had a concerted effort to fix these issues for us. So we're trending in the right direction. All right, let's get back to presentation. So everything I showed you is a trade-off. Like, all automation is ultimately a trade-off. So let's examine like the actual trade space of the pipeline strategy versus other common strategies for accessibility testing. Those common strategies are having a full-time auditor or having an external audit with a scanner, so hiring an agency to do it. So a pipeline gives you 7 times more coverage. And I was actually surprised at first, right? Like, I thought a human auditor would have a better detection rate and better coverage. But really, like, studies have found, like, people are just humans. You get 62.9% detection based on these studies. And even when you combine 2 experts, you cap out at 76% like detection. Pipelines are 92% less expensive than a full-time auditor. And because manual testing only gives you a certain amount of coverage, a tiny amount of coverage, you have a bunch of undetected liabilities that you have to deal with. So to summarize some of the numbers, you get 7x more test coverage with the pipeline for 92% less money and 1,000 times faster feedback. Like, no brainer, right? But as with anything, there are no silver bullets in software engineering. And a pipeline can only cover 50% of your total application surface area. For the rest, you'll still need humans. But if you're aiming for coverage and compliance, you could do worse than starting your journey with a pipeline and layering on human judgment later on. And that can give you the best of both worlds. So at Storybook, we are trying to reimagine accessibility testing for developers and move it away from accessibility testing only for manual QA people. So, and we believe that this is the most pragmatic approach to actually making an impact on the broader ecosystem and front ends at large. So if you haven't tried Storybook, you can try it out now. That's the command to run it. And then if you want an overview of the workflow that I just talked about, you can just take a picture of that. That QR code will give you an overview. Connect on me connect on socials or on LinkedIn. That's my handle. And talk to me later or today about front end infrastructure. I'd love to meet you. Thanks.
Thank you, Dominic. Head on over to the squiggle chair.
Yes.
All right, we've got lots of awesome questions, so thank you again to the audience. Let me start with one. How do I convince leadership to care about this?
There are a bunch of different ways. Ultimately, leadership cares about like liability, risk, and velocity, right? And you can frame it in those terms. Accessibility is a risk for you. That's one way. I would hesitate to frame it as like, hey, this is good for the world or good for things. It's more about, okay, is this gonna help me sell more, or is this going to help me reduce risk?
Yeah, I like that. Bottom line. Get to the bottom line.
Yeah.
How does the accessibility hotness work on Storybook for React Native?
Gosh.
Or does the accessibility hotness work on Storybook React Native?
I don't think so, because React Native, you have to render all of that stuff in an actual device, so you don't get some of the tooling that we're so used to in web there by default. I will say that if you run Storybook with React Native-Web, you can render all of that stuff in a web environment and then get all the tooling that I showed you earlier.
Nice. Do you think Storybook is very useful for large monorepo applications that have hundreds of unique components?
Yes, absolutely. The larger your application surface area, the more that I found that you need Storybook. Like, that's why it's adopted by so many of the giant enterprises. It's that like there are too many cooks in the kitchen when you get to that scale, and you need certain test harnesses and like harnesses like Storybook to give you the security and confidence when you ship. That was a great question, though.
Yeah. Got time for maybe one more?
Yeah.
Vanya asks, do you think there is a chance that Chromatic will ever work with Cosmos, or will it be exclusive to Storybook?
That's a really great question. I think it's going to be well, Chromatic works with Playwright and Cypress right now. So maybe, but we're probably going to stick to Storybook when it comes to like a component front-end tool.
Nice. I'll throw one more in here.
Yeah, of course.
What scanning engine does Chromatic use? Axe? Is it its own code, or is it something else?
Yeah, so we've like aligned on the standard that is Axe, because every other dev tool, like even in your Chrome DevTools, uses Axe. That means there's less like cross-team training in order to get familiar with the tool. You want, ultimately, you want like a tool that everyone kind of knows. And there are benefits and downsides to using Axe in terms of like detection rate, but I would much rather trade that for ease of understanding for newbies.
Yeah. Awesome. Well, there are way too many questions left to answer, so please check out the Discord. And thank you, everyone. Give it up for Dominic.
Thanks, y'all.
All right.
Before the next wave of talks, we're going to have a milk and cookies break. So if you will join us out in the lobby, all of the Oreo options that are out there are gluten-free. So we have about 20 minutes before the next talk.
And I've heard raving reviews of the M&M one.
As I was walking, I was like, it probably applies to now, too.
Yes, exactly. Awesome. Yeah, that sounds awesome. Great. Okay. All right. It's going great. I think so, yeah. Yeah, it is. I believe it.
Let me tell you that I saw your boyfriend walking down the street. He was standing all shaky, hands all sweaty, and he could hardly speak. I might as well take a minute or two to put you onto some game. You got a boy like him, a man like me.
Oh, really? The computer is here. So instead of, it should work. So instead of pointing at that sort of, this is where the actions happen. Okay. So yeah, when you're out here, I will leave it. I was gonna say this is a
You're doing
time
stuff.
here. Yeah, but I'm just like, you know what? It's okay. I guess they came to Detroit a couple months ago.
Oh yeah, they were in Toronto.
I didn't realize like they were talking about like how much analog and everything.
Well, I guess.
Oh, I guess not. Yeah, yeah. We learned last year the most unfortunate way possible that where is it about? It's the very last. We learned that if you start a Google Slide presentation and then somewhere else in another computer edit it, this computer that's presented will not receive the updates. That's the world funniest class setup on the internet.
Yeah, because all I did was for the presenter, I just put the time stamps
Oh, okay.
like in there, so then I can
Oh.
like on the sections.
What's a note to know your time?
Yeah.
Okay, so we should reset this. I can reset for you. Can you like stop?
Oh no.
Oh yeah, that's true.
Yeah.
Yeah. Okay. Yeah. All right. Gotcha. Thanks. Do you have like words that you put on here?
Just on like a couple.
Oh, okay.
Intro slide and then
Great.
on
If you have any
sections. Yeah.
So you could make them here.
No, no, that's good. That's not my
Yeah. Got it.
Each section I can glance over that one, but I'll be looking at the
Yeah, I watched your video on
Michigan. I first set up.
Oh, really? Oh, yeah. It's come a long way
Or
since
the
that.
case, sorry.
Oh, yeah.
Set up.
We should probably link like tomorrow morning or something, or maybe tonight. I'll take another video and like find a 100% conference. Yeah. Like it's like we're like but you have to go out.
Yeah, that's great.
Oh yeah. Yeah, this is all. I feel like I'm the same person I was. Randy got us. Yeah, because I don't know, like okay, great. I mean, in all honesty, like yeah, we're like it's just like many things going on at once. Managing the stream is a lot of work. Right? Can you confirm, thoroughly confirmed that we can absolutely do the stream and do an amazing job. I'd love to go to the outside. We can charge for it. We'll figure that out later, but we can handle it. It's doable. I work downstairs. Monica. It might have been. Is Josh calling people in?
Yes.
Does Ned DeVries have a second level?
We're gonna time it perfectly.
Or who's a place with a second level? The Royale.
Oh, is that, my kids can watch that all the time.
Pretty sure.
No, it's a cat. I think that's like, everything's a cow. Is that what that is?
Sort of. I'm gonna take it off the screen though, so we don't get pinned down. I know you don't. It's part of the reason I'm doing it. All right, great. We gotta start over. Wait. Oh, I'm doing the wrong thing. This is for me. This is for me. You know what?
I'm gonna be a DJ now.
This is like a dream of mine, you know? You rent an IMAX screen, you put kitty stuff up. That's just how it fucking goes. I'm gonna sit and watch it. Right? Yeah. I mean, it's gonna live large. You gotta live large.
People out from the.
Oh, no.
He wants to debug this. Is it okay?
I manually adjusted for now.
Now, are you do you want me to say senior? Are you senior software? Just software. Just developer.
Or software developer.
Okay.
So that's broken. We need camera 2 back. We just got camera 2.
It's like such a small
Up there.
You just have like one.
Couple minutes.
David Sheret.
Yeah.
Is this Phoenix? Yeah. Dude, this album ruled my world in high school. We used to listen to this album on the
Who's going out? David is
I'm going next.
and then who's going Good. We're good.
Welcome back, everybody. So I'm really excited about this next talk. So if you are a small fish, say a junior developer, or you are a big fish, a senior developer, and you're trying to work on documentation or figure things out, you might reach for JS docs so you're not swimming around like a shark trying to figure out what's going on. So you can thank ChatGPT for these terrible puns. Hilarious. So I would like to welcome to the stage David Sheret. He is a developer at Dino.
Hi, everyone. Yeah, so this talk, it's going to be on JSR, designing package registry module resolution. My name, I have to point this way. My name is David Sheret. I work at Dino, and I helped design and implement what I'm going to talk about today. So the goal of this talk is that you understand how JSR module resolution works in Dino and how it got to where it is here today. So first section, we'll talk about Dino and JSR. What are they? The history pre-JSR, how module resolution evolved in Dino before JSR. Then we'll look at the goals for the registry, like how we would like JSR to work. The implementation of how JSR actually ended up working. And then we'll look at how it works in Node.js, as well as what are some of the future problems we would like to solve that haven't been solved yet. So yeah, Dino and JSR, what are they? Sorry, I'm not getting used to this clicker yet. There we go. So Dino, what is Dino? It's a JavaScript and TypeScript runtime, similar to Node.js. It's secure by default, so you can't do anything like with the file system or network access by default. It has built-in tooling, a formatter, linter, test runner, a whole bunch more. It's built on web standards. It has an NPM client. It's the Dino install subcommand. And there's a whole lot more in there. I won't get into it. There we go. What is JSR? So JSR is an open source package registry for JavaScript and TypeScript. It's ECMAScript modules only. There's no CommonJS allowed. It's a great developer experience, and it works with NPM package managers or natively in Dino. And you can find it at jsr.io. So the history of how we got how module resolution involved in Dino before JSR. And initially in Dino 1.0, it was mostly about web standards. So you have like relative specifiers. So you're in a module, and you want to import another module relative to that current one. So you have that. There was no probing for files or directory imports. It was fast. It works well once you deploy it remotely because it's not probing at a bunch of endpoints to get that module. And extensions are required, so it's not ambiguous. So if you have something like data.js, and you specify data.js, it's going to load that. And if you have data.ts, it's going to load data.ts. And then you have absolute specifiers where it doesn't matter which module you're in, you can import something in an absolute path. And this led to the creation of the dinoland/x registry using HTTPS imports. And that essentially acted like a file server. So you just upload a bunch of files to the server, and then anyone can import them. And then you have, a lot of people don't know this, but you don't have to put in Dino like these specifiers in the imports everywhere. You can have bare specifiers, and then you can map them using the import map standard in Dino. So here we have some bare specifiers, and then an import map.json. And before in Dino 1.0, you had to specify this -- import map, and then specify the path to that import map. And then we had Dino 2.0. So Dino 1.0 came out, it was May 2020. And then Dino 2.0 was around this time last year. And it was mostly about node compatibility and NPM compat. So we introduced NPM specifiers where you can inline in a specifier say, OK, I want to implement this NPM package at this version constraint. And it works great in scenarios like Jupyter Notebooks. And then, of course, package.json support came. People have Node projects, they want to use Dino with it. So we added package.json support, so a Dino install subcommand came out of that. And then also Node modules support the ability to use PNPM, Yarn, whatever NPM client you want. And then things started getting more, like still embracing web standards, but having some Dino-specific stuff. So we created Dino.json auto-discovery and an inline import map. So now you don't need to specify this import map flag. You can just put your import map inline in a Dino.json, and it will load that automatically for you and map these bare specifiers. Now, what are our registry goals? How would we like JSR to work? So one of our goals is to only download imported code. So a great thing about dinoland/x is the module you import, you're only downloading that module. You're not getting the entire package. So in this case, we're importing the std package, and we're using the fs/endofline.ts export or that URL. And we only download that. We're not getting everything else within the std package. And this is a goal we'd like with HTTPS specifiers. But NPM, it doesn't exactly work like this. It downloads the whole package, and then also all the dependencies of that package. So if you're only using one export and it doesn't use a certain dependency, you're going to get that dependency regardless, even though you're only using one export. Another thing we'd like is parallel downloading within a package. So when we go to import a package, we'd like to get everything at once within that package. Problem with HTTPS specifiers, you import a module, and then it has to load that module, so that takes time, and then you have to parse it, and then you have to execute it, and do all the loading and resolving, and then you can now go and download the next module that it imported, and that leads to a lot of waterfalling, which is not great with HTTPS specifiers. But with NPM, you download the package and you get it all at once. Like maybe a whole lot more than you want, but it's just one download. And we also wanted to support authoring libraries with bare specifiers. So with dinoland/x, there wasn't a way to say, to actually use bare specifiers and publish them, because there wasn't a way, because at the time, import maps weren't composable, and we didn't, you couldn't have multiple import maps, you can only have a single one. That's now possible, but yeah, so one of our goals with JSR was just to make it possible to do that. And of course, NPM supports this by having an explicit install step where it then resolves the bare specifiers using node resolution. And another goal we had was semver resolution, so package deduplication. With dinoland/x and HTTPS specifiers, you'd often get many copies of the same package over and over. Like it would be, you'd have not the exact same package, but maybe like a patch version, and because everything's importing saying exactly what it wants. And whereas with NPM, it has semver constraints, so we'd like that as well. And another thing we'd like is a clear definition of a package, like which one of these URLs is the package. You can kind of tell by looking at it, but maybe some registry does things slightly different. And if you don't have a clear definition of a package, it makes things a little bit complicated. So that wasn't possible with dinoland or HTTPS specifiers. And whereas NPM has a clearly defined packages. You know what a package is in NPM. Another goal was package internal modules, so not making it easy to import something you don't want your consumers to import, like the ability to have private files. So NPM supports this using the package exports, whereas on dinoland/x or HTTPS specifiers in general, you can just import whatever you want. There was this convention that came around with this underscore internals, or like you put an underscore before the module to say, hey, this is private, but people would ignore it, and you'd get people depending on your private code, which is kind of annoying. Another goal we had was to not expose the internal file structure. So say you have a JavaScript module that people are using, and you want to change it to TypeScript. You wouldn't want to expose this. And so there should be a way to change the internal file structure without affecting the public API. And because like HTTPS specifiers is like dinoland/x, it's whatever you upload. You could change your project, and you're changing the public API, which is not great. So yeah, with package.json, it handles that by having package exports, where you can do it like a mapping from the export to the specific module within your package. And then we also wanted still TypeScript as sources, so it's something we really like. Shipping TypeScript makes things easy for library consumers, because when they look at the code, they're looking at exactly what was authored. So HTTPS specifiers did support it, but it was very slow for reasons I'll get into later. And then, of course, like Node and TypeScript doesn't support NPM, like TypeScript sources in NPM packages. It requires DTS files. So yeah, type checking needs to be fast, and the package, what we want is for the package internals to not be parsed or type checked. And then we also don't want any of our dependencies that aren't part of our public API of the package to be type checked. And that was a huge problem with HTTPS specifiers, because you could use a package within your, like a dependency could use another dependency, and that's not part of the public API, the types public API, but it would still be passed to TypeScript. And also the implementations of all those packages, the sources were being type checked. It's very slow. We'd rather only the public API be type checked. So dnoland/x was slow, but NPM was much faster because it's targeted declaration files. And then we also want workspace resolution. So it should be possible to work on multiple packages in the same Git repo. And they should resolve to each other during development, and then once they publish, they should resolve to the remote package. So dnoland/x had like basically no support with this, whereas NPM supports workspaces nowadays. And then we also wanted the ability to use a local copy of a remote package. So you grab the Git repo of a package, and you want to use that local one as a dependency, and maybe make some patches to it or something, or you want to test it out. So that was somewhat possible with HTTPS specifiers with import maps, but it was very complex. And it's not always possible to map HTTPS specifiers to the file system, because you could have different casing, and so you could have case-sensitive HTTPS specifiers, but case-insensitive file systems, and it doesn't always work out. And NPM does support linking, but in my opinion, it's not that great of an experience. So another goal we had was a less noisy log file. So the log file should only contain one checksum per package. With HTTPS specifiers, it was very noisy because there's no package definition, which is one of the previous goals. You would get a checksum per module within the package. So if you, say, import something specific for a package, you would get all those modules locked in your log file. And then you say you go later, import more stuff, you're getting like so many entries in the log file. And that wasn't great. Whereas NPM has a single checksum per package, which is nice. And then we wanted to prevent code importing outside the registry. And one of the reasons for that is security. So, importing outside the registry. And ideally, dependencies in the registry should only import from that registry. So dnoland/x, you could import whatever domain you wanted. You could import, and NPM dependencies or Git dependencies, or not really Git dependencies, but just a whole bunch of stuff. And what would happen is domains would expire, and people would be depending on code, and now a domain is expired, and their code no longer works. Wasn't great. And also, NPM is not great on this either. NPM allows importing from outside the registry. It's not a centralized registry. I have this package published on NPM, and it has a Git dependency, and it also has another dependency on this random URL I made. And it's you can just swap it out. It will get locked in the lock file, and so if you have a lock file, it's okay, but it's not that great, and NPM install just installs it. It doesn't care. And I think also as well, a lot of those security scanner stuff, I'm not sure it actually scans those kind of dependencies. It may warn about them though. So now let's look at the implementation. So how JSR resolution actually works in Dino. And now we have a clear definition of a package. So you can create a dino.json or jsr.json, and you define your package name as well as the version. So that hits our goal of a clear definition of a package. And then we also have exports. So you can say, okay, at the main export, I want to import, like when you don't specify a path, I want to import mod.ts file. So it's this mapping of export to module. And then you can say, okay, at the base name export, I want to import this base name.ts module. So that hits our goal of packaged internal modules, as well as our goal of not exposing the internal file structure, because now we have a mapping, and you can just change the value of that mapping to whatever you like. And then with this came the creation of JSR specifiers. So this is patterned off of NPM specifiers, where you specify the scope and the package name, as well as an optional version constraint and optional export. And there's some examples, and you can see it being used in an import. And let's just go through like resolving this JSR URL. So it's looking at the package add stdfs. It's looking at this version constraint 1.x. And it's also using the export/copy. So the first thing that gets done is we do workspace package resolution. And we ask, OK, does this exist in the workspace? And if it does, then we resolve to that local package. And if not, then we actually go to the registry. So this hits our goal of workspace resolution. And then we have, after that, yeah, now we actually want to go to the registry. And so we have to figure out, OK, does this, what is this package? And to do that, we make a request to this URL and using the scope and the name. And this will tell us, OK, 404 if the package doesn't exist, and then otherwise 200 with the JSON. So you can go to that URL if you want to check it out, what it looks like. And then, yeah, so this is, well, I guess I'm showing you right now. So yeah, this is what that data looks like, and it has the scope, the name, as well as the versions. So that gives us, yeah, all the versions in the package. Actually, I think I had a note on that. Yeah, so something about this is it's much more optimized than pacuments like in NPM. So for example, like the Next.js package is 26 megabytes on NPM when you just request a similar file. And the problem is they have for every version all the data like within the package JSON right there in line. And we don't do that. We just have the version, and I think like we just added the date recently as well. And so if the Next.js package, like if NPM had to use a similar design to this, it would have been 67 kilobytes. So that's, in my opinion, a much better design if you're on a, like a 1 megabyte. If you're downloading at like 1 megabyte per second, you're going to get it in less than a second versus 26 seconds. And now we have to do version constraint resolution. So we previously got all the versions, and now we want to say, OK, get everything, or get the highest version. Yeah, we just want to resolve it. I'll get into how we do that now. So we attempt to resolve the constraint using the previously resolved versions, and that helps reduce duplication, because if it was previously resolved to a version, we don't want to do that again. And if not, we resolve to the highest matching version on the registry. And then we error if no matching versions match that version constraint. So that hits our goal of semver resolution. And then we want to do, finally, export resolution. So in this case, /copy. And to do that, we do another request to this name, scope name, and then the version that we want to look at. And again, we get, likely, well, now we know that the package exists, but in this case, we'll get a 404 in case that version doesn't exist, and then 200 response with the JSON. And that looks something like this. And in this case, we're mostly concerned about the exports key, and that contains all the exports in the package. So we can check if the export exists, and then if so, we resolve to the HTTPS specifier using that value. And then if not, we error. So in this case, /copy to copy.ts, and then we get this resolved URL. And now that we have that, we want to do actually figure out what we need to download within this package, because JSR, you don't get the entire thing. You just get what you import, like which export. And to do that, we use the module graph 2 key. And this is like a high-level representation of the module graph in JSON data. So it just allows us to quickly go through just using that JSON data and resolve all the modules we're going to download, and then download them all at once. And this is an optional optimization that clients can do, and they should continue working even if they don't have this optimization. So this eliminates waterfalling. So you can see here an example of module graph 2, and then within that, the copy.ts, and then it lists all the dependencies in that module and their locations. And so we can also use that for error messages, so we can surface errors before even downloading. And yeah, so we resolve copy.ts into module graph 2, and then we resolve the high-level module graph synchronously. So now that we've done that, we kind of do these steps. So we download all the specifiers in parallel, and then we queue the JSR and NPM specifiers that we found for resolution later. And then we error for non-JSR specifiers. So that hits our goal of parallel downloading within the package. And then we only download imported code. And it prevents importing outside the registry. A compromise we had to make there is we had to allow NPM imports, because it's just impossible to tell people, hey, use my registry, but you can't use all your dependencies on NPM. So in Dino, we don't download NPM packages if they have a dependency on something outside the registry. We don't download that right now. We might have a flag in the future to make it possible. It would have to be opt-in. And you'd probably have to specify who you trust. So anyways, that was a compromise we had to make. It's just too hard. And yeah, then we actually, when we're loading the modules, we want to verify that we're getting the right data. And there's within this version _meta.json file, there's a manifest key. And within that, it has all the exports, all the modules within the package. And then we can key into that to figure out the checksum of the module, and then compare that to what we get from the registry. So we only have to have a checksum for that version _meta.json file, and a single one in the log file. And we compare that, and then afterwards we use all the checksums in there against the registry. So that hits our goal of less noisy log file, because now we just have one checksum in the log file. And then, yeah, we continue resolution and loading, so we resolve all pending JSR specifiers, we resolve all specifiers within the package, repeat that until done. And then the final step is to resolve and install NPM dependencies. So another goal, yeah, was faster type checking. And the way we did that is we basically, for each package, we identify all the types used in the public API. We create a new subset of that package, which only contains the declaration file-like code. And we only include dependencies that are used in the public types API. And then we cache this code to reduce the work next time. So we just load from a cache. And then we use this code with a source map and type checking, so errors are still correct. And this is all done behind the scenes. The user doesn't see this. And we can do that because Dino handles all the type checking. So it can be pretty significantly faster than type checking all the sources. So you can see here, I have this, say this is my package, add, and then I'm using my fast add package. The public API is really only this, and not the red part that's showing there. So it's only the export function add with that function signature. And so we can just get rid of everything else, and we just send that to TypeScript. And so now we're only sending one module to TypeScript rather than potentially, I don't know how many modules. And then we also added the ability to use a local copy of a package, and we achieved that with linking. So you specify links, and then you can say, OK, the relative path. And once that's done, you just do Dino run, and it will use that local copy of the package. You don't have to do any install step, except for NPM packages, you have to do an install step. But for JSR packages, you just set that up, and then it will work. So some other goals that we achieved was like import maps are supported in libraries, and the way we do that is to have a pre-published step that's done by the client to inline the import map entries into the files. And then we also added yanked packages, which works similar to crates.io. I'm not going to get into what that is because I don't have time. And it's another benefit is it's possible to represent the entire JSR resolution with an import map. So you can use, as long as something supports the import map standard, you can actually use Deno to get out an import map and then use that with whatever other runtime you want. And now, yeah, we're getting into how Node compat works, and like how JSR works in Node. And the way it works is it uses a custom registry that provides a JSR. Well, you can set it to whatever you want, but you can run this command npx JSR add, and then the scope and the package. Or with PM, you can do what's shown there, and I think yarn as well. And then you can just import the package. So yeah, behind the scenes, it's just a custom npm registry. But I recently got this example working in Node.js with custom loader. So this is like pretty bare bones right now. I just got it working a few weeks ago. But basically, you can use npm specifiers or JSR specifiers in Node.js. And just using the Node loader APIs, we've managed to get that to work now in Node, as well as other like bundlers and different tools. So it's, I'll probably put this in a npm package eventually and try to make it easier to use, but yeah, this works in Node.js now too. Obviously, if a package is published with Deno APIs, it's not gonna work in Node, but as long as it supports stuff that works on the Node runtime, then it'll work. And let me go back. Yeah, there's a GitHub repo if you wanna just try that out. It's just like pretty thrown together at the moment. Come on. There. Yeah, so looking at the future, what problems haven't been solved yet? And yeah, there's a few things. One thing is we need a way to express bytes and text dependencies in the module graph. So a solution for that might be the upcoming import whatever using type bytes. And there's still like some problems with that where potentially you want to load something and then unload it. So we're trying to find solutions in TC39 to that problem. And then we also need platform-specific assets. So that's not possible right now. The way to do that is to publish your assets to NPM, which is not great. And then we're looking to TC39 for other solutions like the import defer proposal. It's pretty exciting. And then currently we don't allow global types in JSR. So if you want to declare a type that's global, it's banned right now, and that's just because of the way the the type checking works. We have a proposal for that, but we haven't implemented it yet. So yeah, that's my talk.
Awesome, thank you. Now, as you guys are taking pictures or you find something quotable, we ask that you tag Squiggle. And actually, if you look on your name badge on the back, there's a QR code. And if you scan that, it's kind of like a link tree. And it will show you all the different social media things that you can tag. So we would appreciate that, because just that helps other people know what they're missing. So give a little FOMO. But David, that was a fantastic talk. So keep the questions coming on Discord.
I'm actually going to get my water.
Oh, yeah, sure.
Oh, yeah.
Perfect. So while you're doing that, like I said, feel free to scan that QR code. And that, I'm all about the FOMO with the conferences. Okay, so Steve asked, was a lock file diff resolution an important criteria?
The log file diff, yes. So we spent some time. It's not really related to JSR, but well, I guess it is with the amount of checksums that were in that. But yeah, for sure. So we redesigned the lock file about maybe half a year ago. Ryan came to me and he wanted it to work similar to how it works in Rust, where if you have duplicate dependencies, it shows up really easily in the lock file, and you can see that. So yeah, that's definitely something we've thought about, and yeah, trying to improve more and more.
Awesome. Dan asked, are there plans or current support for the prevention of supply chain attacks?
Yeah, so by default, Deno doesn't run anything unless, like it doesn't allow you access to the file system or network. So one of the ways you can limit supply chain attacks is only giving your scripts access to what they really need. And so, yeah, I think like Dino's the best in that area and really, really strong. And then we're just adding, PMPM has it, but it's the ability to say, okay, I don't want like really, really recent packages. I want to wait like a little bit before getting them. So we're just adding that this week to yeah, all the dependency resolution. And yeah, but it's mostly the permission model that helps prevent those kind of attacks.
Awesome. Josh asked, how does JSR handle security? So you kind of touched, I guess, slightly on that. Would the recent NPM issues be possible?
Well, I would say it's still possible on JSR because people can just go and publish packages. It hasn't been as much of an issue in JSR, probably because it's not as used as much at the moment. So yeah, it's a lot of, yeah, it's mostly, yeah, again, it mostly comes down to the Dino permission system. But yeah, if you're using it in a node, it's slightly more risky.
Mitch asked, do you recommend still using HTTPS specifiers in Dino?
Yeah, so I think HTTPS specifiers are great still. And say you, like in your company, you just want to throw up a web server and have devs like pull in scripts. They're awesome for that, especially for CI automation and different things. You can just have a web server running locally, and then you can have a script just do Dino run and then a certain script. I occasionally will throw stuff on GitHub in a GIST, and then I'll use that in an automation script. It's still super useful, but if you're creating an actual yeah, app or something, I wouldn't recommend it as much, maybe for one-off scripts, but it's if you're having dependencies of dependencies, and yeah, it starts to get messy, and yeah.
Ryan asked, can you talk a little bit more about why a less chatty lock file, specifically minimizing the number of checksums, was a goal? So
it's just like way too much noise, because if you have a package and it has, say, 40 modules, you're going to have 40 entries in your lock file. So that's 40 lines rather than just having just the one for the, or 3 for the package name and then the checksum and then, yeah, so it's way less, and it's consistent for each package.
Alexander asked, what are, in your opinion, main reasons that keep people from adopting or using JSR?
I think I have to think about that one more. We've been thinking about it. I think the main reasons, like one of the things is definitely we're pretty strict on, like we have a lot of, like we have a package score, so we give packages lower scores if they do certain things, and it can be a little bit of work for someone to go and actually publish. So especially like we require explicit return types for a lot of stuff, and that can be a lot of work to implement and do. Basically, we're using the isolated declarations there from TypeScript. It's a bit more advanced, but that's essentially what's being done. And so we could add like more tools to automatically populate return types and try to make it easier, but we haven't done that yet.
Okay, I think we have time for maybe one more question. Colin asked, what's the rationale behind scoping all packages on JSR? Are there any plans for supporting unscoped module names?
I'm not entirely sure on what the rationale is. I know it does make typo squatting a lot more difficult, or because you have to get the scope wrong and the package name wrong. Yeah, I'm not as familiar, but there's not any plans at the moment to not make it work that way.
Awesome. Well, thanks again, David, for your talk.
Awesome, awesome. Thank you, David. All right. You know, as I walk around the aquarium, I have a lot of stories that start like that, I guess. I just love looking at the fish. But as a TypeScript guy, I really like the little plaques that tell me what they are, right? Because otherwise I'm just looking at penguins and I don't know that that's a rockhopper or whatever penguin it is. So that type information is super important. And you can think of those little plaques as your type comments. And things like TS doc really help with that. And so I want to introduce the creator of TSDoc and a software architect, or should I say sharkitect, Pete Gonzalez. Pete, welcome to the stage.
Thank you. Hi, I'm Pete Gonzalez. I work at TikTok. I am a core maintainer of the Rush Stack family of open source tools for large TypeScript monorepos. Today I'm going to talk about TSDoc, which is a project I worked on 2 employers ago at Microsoft and still support today. So we'll talk about what TSDoc is and why its story is kind of complicated. To talk about this kind of tool, we should first talk about the situation of doc sites. So if you've written TypeScript code, you've probably put a comment above your function explaining what it does. When you compile your TypeScript to make a DTS file, the compiler copies the comment, and then if somebody is consuming your DTS file as a library, when they move their mouse over like an API function, they'll see a tooltip that basically shows them that comment. So if you're making professional libraries, you probably also want to have a website with like a web page describing each of your APIs. It's kind of a small logical step to say, why don't we take the code comment and just generate the website from it? There's an interesting case with localization. Like imagine you wanted 30 different languages supported on your website. Would you have 30 different comments above every function, or would you have a database of localized data that then gets like synced back into your source code? We don't have time to talk about that today, but I just wanted to mention it. It's interesting. Doc sites have a long history. I first had exposure with C#, where they used / comments and XML notation. They had, like in my example here, you can see you could mark a code span with an HTML element, and you could document the parameters and return value of a function. You could even, the compiler would take all of the comments and put them in an XML file that had a synopsis of the entire API signature. And they even have a declaration reference syntax where if you hyperlink from one comment to mention a function from another class, they have a string that can uniquely identify any part of the API. So some years ago, JSDoc took these kinds of ideas and applied them to JavaScript. And that's the syntax that most people are familiar with today. It's a little different. They use the /** instead of triple slashes. They use Markdown instead of XML. It's generally a more friendly syntax with like @param and like a dash as a delimiter. And it supports plugins, so you can add new syntaxes for different kinds of scenarios. In fact, in the original JSDoc, Markdown itself was a plugin. It wasn't part of the core parser. So JSDoc was a command line tool where you just run JSDoc on your JavaScript file, and then it would generate like the HTML for you. So this filled a vacuum in the JavaScript community, and a bunch of other tools just started adopting the same syntax. TypeDoc is one tool that specialized in TypeScript APIs. There was documentation.js. The TypeScript compiler reads some tags out of code comments. Google's Closure compiler is a optimizer that reads quite a lot of different tags and uses them as directives to do tree shaking and advanced optimizations. So when I got involved, we basically were in the space, but we faced some new requirements. The reason was because we were developing a tool called API Extractor. I don't have much time to talk about it today, but in a nutshell, it has 3 features. One of them is API reports. So if somebody makes a change to a TypeScript file and it affects one of your public API signatures, this will cause a git diff that triggers an API review. It also has DTS rollups where it can take all the individual DTS files from each of your source files and then make them into one big file, sort of like how Webpack takes individual JS files and makes one big JS bundle. And API Extractor also had a doc site feature, which is the part we're talking about today. So just to sort of compare the engines, like JSDoc would take JS files and make HTML. I mentioned TypeDoc. It takes TS files and makes HTML. API Extractor is part of, since it's part of Rush Stack, it has like more fancy requirements. Basically, we take TypeScript files and then make API JSON files, and then there's a companion tool, API Documenter, that converts that into Markdown, and then you can have DocuSource finally make your HTML. And then TSDoc was like a library that's used by API Extractor. And we also had cases where engineers would work in several different monorepos, and they would build independently, and you would collect together the different JSON files, and then API Documenter would generate one consolidated website that would allow, for example, hyperlinking between packages that originally came from different teams and different repos. And it can also target DocFX, which is Microsoft's big fancy engine that it uses for all of its documentation for APIs. And there was also a case for like custom tools, where maybe you had a React web app that would like demo your cool React components, so you would write some custom tool that could take JSON files and convert them to your own custom file format. And we have an NPM package called API Extractor Model that can read the JSON and help you navigate the hierarchy and resolve hyperlinks. So from this, we ran into some problems with the JSDoc syntax that motivated TSDoc. So the basic requirements were it needed to be interoperable. So we had different tools that all had to parse the same comment and agree about its meaning, even with extensions. It needed to be rigorous, so some of the directives actually affected compilation, so if something got parsed incorrectly, it could cause problems. I can give an example of that. Like, you can see this function says if x is less than y or y is greater than z is part of its documentation, but when you render this with JSDoc, you just get if xz. So like, what's going on here? Actually, the less than and greater than are being interpreted as an HTML element, and then it gets discarded because it doesn't recognize the x element. That would be really counterintuitive just to have your documentation wrong in your customer SDK. Another example, here I have like a function, and when I compile it, one of the functions is missing from my DTS file. How did that happen? In this case, if you're using TypeScript with the strip internal command, it deletes APIs that are marked as internal, but this person didn't mean it to be internal. They actually had backticks and just were talking about the internal tag, but the TypeScript compiler didn't recognize the markdown, and so it accidentally trimmed something that wasn't internal. It also needed to be predictable. So I mentioned you would write your code, and then maybe later in time or further down in the pipeline, it would finally generate the doc site. So engineers couldn't see right away what their comments were going to look like on the website. So we wanted the syntax to be very predictable, where you could guess when you write certain punctuation how it's going to end up getting rendered. And then finally, we wanted it to be idiomatic. So we didn't use / and XML. We wanted to follow the same JSDoc-friendly syntax that everybody was familiar with. OK. So the plan for TSDoc was fairly simple. Start with JSDoc style syntax. We had a little bit of distinction between inline and block tags. We adopted common mark to try and standardize how the markdown worked. We had the idea to make a small parser-only library and then have the documentation tool be separate. And we were working on a spec, but we kind of thought the implementation of our library could be the spec. At the time, it was popular. The TypeScript compiler was saying, we don't have a language specification. The source code is the spec. And we made an RFC process on GitHub, like request for comments, where we would just basically post ideas or problems and then use community feedback to guide our design. So like from the RFC process, we had some interesting insights. Like for us, the real contract was in the DTS files, not the TS. So for example, if you wrote a comment and it didn't get put into DTS, consumers of the library wouldn't see it. So that actually wasn't a good documentation comment. We needed like lax and strict scenarios because some people had legacy code or didn't care too much about errors, whereas people who worked on huge code bases wanted stricter validation. We also found that packages, if they refer to another package, they need to know if that package is using TSDoc and what extensions it has. So we needed a metadata file that would get published with each NPM package. But we also ran into some challenges. One of them was like the declaration references. I had mentioned earlier that C# had a notation that would allow a hyperlink to refer to another API, maybe in a completely different package. Doing that for TypeScript was somewhat challenging. Like TypeScript has merged declarations where something can be like both an enum and a namespace at the same time, and you want to link to a specific one. Or you could just have an overloaded function that has like 3 different overloads, and you want to link to a specific one. And there's actually quite a lot of cases. So we worked out a fully elaborate syntax for that, and then there's actually a second iteration of that that still hasn't been published yet, but it was an interesting problem space. But probably the biggest challenge we ran into was Markdown. So common mark is a standard, but it's not extensible, which means that basically every Markdown parser is mutually incompatible. As soon as they add some kind of extension, whatever syntax they have won't be recognizable by another Markdown parser. And actually, Markdown's quite quirky. Like when you write stuff, it's often very hard for a person to guess how it's going to get rendered, and it relies on like live previews in the classic scenario to actually work around that problem. So we had this idea to simplify the Markdown, and that meant coding our own lightweight Markdown parser. And when I got into that, I found out the grammar is quite interesting. Like it's polynomial time, worst case. It requires like backtracking to parse all of the context. Most programming languages are not like that. And then there's these plugins in most Markdown engines that just use regular expressions to find random patterns and completely ignore the grammar. So this was like a lot of headaches. And there's like a composite grammar. So essentially, The TSDoc parser has a hierarchy of nesting layers. Like there's the comment framing in TypeScript where you just find where the comments are. Then there's like your Markdown has like backticks and backslashes that you can use to escape things. And then it actually, Markdown includes HTML as part of its language. So you have HTML entities and HTML elements and those rules. And then there's like the JSDoc tags superimposed on that. And then actually if you take this whole picture and have a nice parsed Markdown file that you generate, the backend renderers do weird things with Markdown that gets reflected back into your syntax choices. So it like really surprised me with its complexity. I don't have time to go into a lot of detail today, but I'll give one kind of fun example. This was a community request that we got in a GitHub issue. I think it was Sinversource reported it. But basically he was saying, I have like a case where I want my documentation to include a code sample, and that code sample includes a string that has a comment in it. So you can see he has like / in this like console log in his code sample. So if you're going to put this in like TSDoc syntax, you would have like your like description of what it is, and then you'd have triple backticks, and then you'd have your like code example in the middle of the comment. But we have like / inside a TypeScript comment. So this code actually won't even compile. The TypeScript compiler doesn't know what any of the comment symbols mean, so it just sees the end of the comment in the middle of a comment. So we like talked about how to solve this kind of problem. One idea would be to use HTML entities. So you could put like the entity instead of the second /, and that would get you around the problem. But you run into this like onion skin where that's like too far down in the grammar, and it doesn't actually work. It won't like render properly. So another idea we had was like, oh, well, we can use Markdown backslashes. That's like a higher up layer of the onion skin. That does actually work, but if you're going to properly implement backslashes in that way, you end up with like double and quadruple backslashes when you start considering the other layers in certain contexts. So that actually was kind of clunky. I started to think maybe we go all the way to the top of the layer and think about just the comment framing. What if you just ended your comment and then started the comment again with like a *//*? That could be like a special thing we recognize and treat as like an escape. It does work unless you were going to nest a comment inside another comment inside a code sample, and then it like falls apart. But it's close. So the final solution that I came up with was to extend the framing with this idea where you can put a plus immediately after the star, which is a place where nobody ever puts characters. And if you do that, we consider that wrapping a line, and we could use that as a way to unwrap it. And this actually works, and you can nest it, and it has some other like nice benefits, like if you just had a really long URL or something, you could use this to wrap to the next line. So I was like really proud of this until I talked to my friends about it, and they like thought I was crazy and had gone down some crazy rabbit hole, and why do we need this at all, you know? So if we zoom out and just kind of like think about how we got here, like, so today, TSDoc did meet the requirements of API Extractor pretty well. We've shipped an ESLint plugin for it. We haven't made a VS Code extension yet, but we really would like to. VS Code itself today still, this is like 7 years later, is still agnostic about comments. It doesn't really do JSDoc or TypeDoc or TSDoc. It just kind of recognizes comments that are like common and applies basic heuristics in its parsing. JSDoc and TypeDoc are still popular. You can use them if API Extractor's architecture is more than what you need. And TSDoc itself, I feel like, is missing a lot of features. There are a lot of stuff that we wish we could put in it. But because it met the need of API Extractor, a lot of people who would contribute to TypeDoc end up actually going and working on API Extractor bugs instead, because it's like a higher priority for them. So we're actually looking for contributors if somebody wanted to get involved with this project. Looking back on it, so some retrospective, if you're designing a syntax, don't do composite grammars. I actually feel like the C# / was a brilliant solution. We could have maybe just used that and gotten rid of the requirement to be idiomatic, and we would have had a much easier time if we went that way. Another idea would be if we had made a VS Code extension right away in the very beginning, then as you were typing stuff, that could give you live previews, and we would maybe be able to get rid of the requirement of predictability. That probably would have simplified our life a lot as well. I did find that hand coding parsers is super fun. Like Antler is a very popular parser generator today, although I doubt you could make a Markdown parser with it that would be fully complete. But I just want to say hand-coded parsers are generally better than generated parsers. They have better error messages, and it's just more fun. So that scene is still alive. And if you want to get involved with that kind of thing, like I said, we are still looking for contributors to TSDoc. So that's pretty much the material I had today. I was talking a little bit fast because I only had 15 minutes and kind of a lot to cover. but I'm interested to hear people's questions.
Thank you, Pete.
I usually watch my YouTube videos at 200%, so I'm used to best.
Same.
Oh, and I have laptop stickers. If anybody wants TSDoc laptop stickers, you can pick them up for free later.
Nice. We got some questions. So the first one, this is from Mitch. What's the difference between JSDoc, TSDoc, and TypeDoc?
So they all look the same, but they're different. So JSDoc formally is whatever the JSDoc tool parses. So their website explains the syntax, but it's not a complete grammar. So basically, whatever the JSDoc tool does, that's the formal definition of JSDoc. TypeDoc is a different project that essentially does the same thing, but it was designed for TypeScript. So TypeScript has like interfaces and types and a lot of stuff that don't show up in JavaScript code at all. Today, JSDoc can kind of handle that. There's like a plugin, I think, that can map TypeScript into JavaScript, but it wasn't really designed for it. So TypeDoc was essentially designed for that. But TypeDoc, and we actually used that before we built API Extractor, but it doesn't scale very well when you start having lots of projects. It's really designed for like one single project. And then API Extractor had like the two other requirements that I talked about, and then just does doc sites as one other thing.
Nice. From Colin, are you going to work on a big O of N parsable markdown alternative next?
Markdown? No. I think like if you read the specification of CommonMark, it describes like block scoping and backtracking. Basically, the spec tells you how to parse it because it's so heavily context sensitive that you can't just describe the syntaxes. You have to describe like how the parser would work. It's very bizarre. So I think if you're going to be standards compliant, there is no way to be any faster than that.
Makes sense. From Dan, is there a name for the markdown dialect that you specified?
Yeah, it's called TSDoc flavored markdown.
Do other tools support that, or how does that work with like doc parser or doc renderers?
So, like many of my projects, for some reason, it's very hard to get people to understand what we're talking about. Like the idea that there are different markdowns. To most people, markdown is just like, oh, well, you use some stars to make stuff bold and underscores to make it italicized, and like, okay, some tools have some others. You can do exclamation mark and make an image. What's the big deal? But if you were trying to agree about whether @internal means internal or not, in edge cases, you need a grammar. Otherwise, you'll always be able to create cases. In fact, if you give me any two markdown parsers, I can construct a string that they both disagree about, like how to render it. So that's like a big problem. And you can compare that to XML, where XML is an extensible markup language. So essentially, you can add new elements, and you can add nesting structures, and like it has namespaces, and nobody's extensions will ever conflict with each other. So like it's perfectly extensible. You'll never have that problem where you try to parse somebody else's XML document, and you can't just ignore the parts that you don't recognize. So that's kind of like the difference. So essentially, Markdown is missing that because its whole spirit is people write stuff that you could just read the ASCII and it looks good to people, and then also we can make HTML from it, and there's a lot of magic of how that happens, but it doesn't matter because you can see the HTML right away in simple cases.
Mm-hmm. Well, great, Pete. Thank you so much for your time. There's a lot of other questions and comments in support of the project, so definitely check out the Discord. And let's give Pete another round of applause.
And help yourself to a sticker if you want one. I'll leave them here.
Awesome. Our next speaker is TJ DeVries. And a fun fact about TJ is he loves NeoVim, but he works at Terminal. So please welcome TJ.
All right. Oh, hey, it's me. Very cool. That's not what you're supposed to look at, but that's all right. We'll get there in 1 second. So my talk is about, we're going to write an LSP from scratch, approximately, in just 30 minutes. So you'll have to stick with me. We're going to go a little bit fast. The goal of this is not only like fun and to make you laugh, of course, as any good conference talk is, but hopefully what it does is it shows you that we can start with not a lot of knowledge. We can go read some of the spec, and we can come out understanding our tools better. I can pretty much guarantee all of you are using an LSP in day-to-day work. If you're not using it directly because you're just vibe coding only these days, The vibe coding tools are all using LSPs too. That's how they figure out if your code's broken or not. So we're going to do that. We're going to start by just deleting our main.go and hope that we can get the rest of this going. So we're just going to start. We're going to write this in Go today. And in Go, we start by making a package main, and we just start with some main function here. Inside of this, we'll just get started by just making sure we can print hello world to make sure we're running, and we'll run go main go. Cool. That's not an LSP, though. So what is an LSP? We can hop over, not this way. We can hop over to the docs right here, and we can see that the main idea for LSP was to help solve the problem of, hey, we have all of these different languages, and we have all these different editors. Can we make them talk together a little bit more easily without having to have Vim Python mode, JetBrains Python mode, VS Code Python mode? Just like we just have a Python LSP. They made 20 LSPs, but that's fine. That's a different talk. I can't solve that problem. So effectively what it is you start up some server, and that talks to your editor over this protocol, and they send JSON RPC messages back and forth. These messages look like this. They start with, we can pop this up a little bit bigger here, something that says something like a content length. It tells you how many bytes to read. And then there's two registered nurses, that's a carriage return and new line, that's what I like to call them. And then a JSON blob that is actually the message itself. So to start writing our LSP, what we need to do is we need to be able to make a message like this so that we can send it from our editor, or from our server back to the editor. So we'll write a simple encode message here. And it's just going to look something like this. Encode message, it's going to take anything. We don't know what it is. In Golang, you can just write, I don't really care, as long as it can do these things. And it's going to return a string. So we need to turn this message first into JSON, right? So we can say something like data, and we're going to do JSON marshal this message. That's the way that you do that in Go. That's like JSON.stringify or something like that. It can also return an error. If we have an error here, we're just going to panic, because if we don't know how to turn this thing back into JSON, it's time to freak out. So then we need to do exactly what the specification said, which was we need to say how many bytes we're going to send, put this little content length here, separate it, and then write our message. So that's actually not too hard. This one's the easy part. We can use printf here, which is string printf, in case you don't know it. We can say something like content length. No, not content type, nice try. And then we're going to say how long this is, our new lines, and then the data itself. So if we do this, we're able to write out a message and put this back. So we'll just make a silly example type here, which has a struct, and we're going to say something like name, and it's going to get encoded like this. We can print encoding this message, and it's going to say my name. If we run this with go run main go, we should see content length 13. You can't actually see the new line and return characters, but they're there, you can trust me. And then it says 13 characters for that's how long the JSON blob takes. So that's step one, right? Now we know one half of the protocol. Now we need to be able to read messages back from the protocol so that we can understand what the editor is telling us. The editor is going to tell us all of the interesting things that are going on in the editor. Which files did we open? What's the current context? And eventually, in this talk, we'll also do go to definition and some diagnostic stuff, because we have to show squiggles at SquiggleConf. That's actually what inspired the talk. So what are the first messages that we have to send? Well, inside of the specification, it actually tells us. It says what are our life cycle messages. And the very first thing is that the editor is going to send an initialize request to us. There's two main types of messages in LSP. The first is a request, which says, hey, I'm going to send you something. You need to send me something back. Okay? And then the other one is a notification, which just says, hey, you should know this. Okay? Initialize is a chance for the editor to send something to us and say, hey, set yourself up, here's some configuration, here's maybe like my root working directory, all of that sort of stuff. And then let's talk a little bit about what we can communicate to each other. So an initialize request looks something like this. It sends a method, a string that's called method, and it says initialize. That's how we know we're getting an initialize message. And then it has some params, which are these initialize params. We don't care about too many of these for today. If you were writing a real language server for a real language, you would want to, this is where you would find out where the root directory is and all of those sorts of things. This is the chance for those things to do, but we don't need to do that right now. So that's always the first message that we get. So why don't we, right now, we're going to try and just be able to decode that message. So decoding a message is going to look something like this. We don't know exactly the shape of what the message is going to be until after we've read the method. In JavaScript, this is like a little bit easier. You could just call like, you could do JSON.parse on this, and you would get back like basically just an object with keys. In Go, we have to do a slightly different strategy. So we're going to do something, say, like we're going to get type, and it'll be a message. And it's going to have an ID, which it might be empty. And it's going to have a method, which looks like this as well. So these are just ways to tell Go how we're going to get this information back. And what we want to do is we're going to try and decode this content length message that we get in. So we get in, really, a list of bytes. Those are nice to use because we know the length. And we're going to return something. So the first thing that we're going to do is we're going to use a very convenient function called bytes.cut. Bytes.cut basically says, hey, give me a list of bytes. Give me the front half of this, the rest of it, and if we found it or not. And we're going to split this on those new line and carriage return characters that we had said before. So this is like our header, content, and if we found it or not. All right? If we didn't find it, then we're going to say, let's return an error, and we'll say something like errors new. We'll say missing header. And that's our first error here. So now we know this function, it really needs to be able to return an error in case this isn't ready to actually be parsed. So we'll return an error here. The next option that we have here, right, is that we need to say, hey, let's read the header and let's pull out the number from the end of the content length, right? And so what we want to do now is we're going to say content length is something like this, where we say, let's try and convert SquiggleConf here. If you don't know what that is, that's just Go being really attached to how C used to name things. A to I is like ASCII character to integer. They couldn't write out that many letters, apparently, right? And so this is going to take the bytes that we have here from header, and we're going to read from after length of content length here to the end of that string, right? So we're basically saying, hey, give me everything after content length. And this could also be an error, so we should handle that. And if this error isn't there, we weren't able to convert it into a number. But now we know how many bytes we actually need to read, which is awesome. So now we can try and parse out here we can do our first sort of reading of what this JSON blob is to find out what the method is, right? Because we need to do different things based on what the method is. And so we can do something like this. We'll say var message, and we'll try and unmarshal that. And if we have an error, we'll once again quit out a little bit early. So now what we can do is we can do something like this. We'll return the message method, and there was no error here. So now all of these we're going to change to strings. In Golang, if you're not familiar, usually what you do is you provide a default value and then an error if it cuts out early like this. So what we've got now is, we should read from content. We should read up to content length right there. Great. So now we should be able to read a message that looks like this message that we were just seeing here. We'll be able to read an initialized message and get that in and find out that we have an initialized message. So we can try and do that. One trick that we'll use that's a little bit nice, we won't go into this in too much detail for Golang, is it has a really nice library called a scanner, or well, it's part of buff.io. So we can go scanner.new here, and we can set a scanner.split function here, which we can go like this, and we can actually just pop this guy out because in the interest of time, sorry, I did say we're writing from scratch. I did paste it in during this, so I think technically that counts, right? And so this basically says, hey, how are we going to split messages? We're going to get in some bytes. it's going to do exactly what we just did for decode message, and then it's going to decide whether we're going to advance and what the new token is going to be in our stream. Because remember, the LSP is actually a long-running process communicating with our editor, right? So they need to send messages back and forth. In this case, we're going to use, which is the most common method, communicating over standard in and standard out. So we can do here, we'll make our scanner like this. And effectively what's going to happen is, yep, those are right. Okay, that's good. We're going to read our standard in. That's what we're going to communicate with some editor. In this case, we'll use NeoVim. We're going to split on these messages. And then for as long as we have messages, we're going to get this data. So this is really nice because now we can say something like, hey, what's the method that we have? And we can log this. We'll log this to a little file that we've got going on here. And we'll say, yep, printf like this. And we'll say, we're going to pass in our method. If we have an error, that's also a problem. And we'll continue going on. So how are we going to test this? Well, we're going to hook it up to a real editor. So what we've got going on over here is I made a fake language called Squiggle. This language, it looks surprisingly like JavaScript. Ooh, we said ID here needs to be a string. It's actually supposed to be an int. My apologies. We'll restart that. That's our error. Look at that. Nice. That's why you handle errors, because then you find them out. Perfect. So we just got an initialized message. That message was sent to us by NeoVim to the server that we're doing. I have a little bit of machinery to just do go run main.go and connect them up with standard in, standard out going on behind the scenes. If you're interested in what that code looks like, this will be on GitHub after this. If we want to see the entire message that was sent to us, we can send something like this, and we can print the entire message. So open this back up, and you can see, wow, that's a lot of stuff. LSPs communicate a lot about their capabilities with each other. Unsurprisingly, both editors and languages contain an insane amount of variety of what features they use and what features their tooling supports. So that's the very first thing. And what we'll notice now is that if we need to actually respond to this message. So far, all we've done is the first half of the request cycle, which says, yes, I've read this message. But what did we say requests need to do? They need to respond. Thank you. Someone in the audience is listening. Love that. Yes, even after 4 o'clock. That's awesome. Okay, so how do we respond? We write back an encoded message, right? We already wrote the encoding part. What does that message look like? Once again, we can refer to the documentation, my favorite phrase. An initialize expects an initialize result as the response. And this is basically going to be something that just is like a JSON object that has a key named result, and then it's going to contain this information. It says it's going to have capabilities. The only one we really care about for this moment right now is telling NeoVim, please send me when files change. Normally, when you write a little bit more advanced one, you send incremental updates. We are not going to write incremental reconciliation of text across multiple different files in this demo. Sorry if you thought I was going to get there. Instead, we're just going to ask it to send the entire file. Okay, and so for us, we're going to say something like this. We've got to make a new type, and we're going to say an initialize response, right? And it's going to have a result. That's the thing that we just saw, and that's going to be an initialize result. It's going to get encoded there. We need to write that out. It has capabilities and server info. Unsurprisingly, LSPs are a little bit familiar with what this looks like, right? And so we can go back and we can say something like, what are our capabilities? We don't care about these ones right now, and we're just going to send back an int. And we will tell NeoVim what server we are. This is useful for if you're going into the logs of any LSP, you can go see what's connected, who's doing what, etc. So we're doing a handshake right now with NeoVim, right? We're saying, hey, it's asking who we are, and it's telling us who it is, and we're going to respond back. So the way that we write that, we can do func write response, and we'll say some message, which we really don't care what that looks like. We're going to, first, we'll just log this as well so that we can see in our logs that we're writing messages. So we'll just respond to this, and we'll say encoded is encode our message. So we'll write our encoded message. And then, like I said, for LSP, generally speaking, the protocol's in, standard out. So we were reading from standard in. We're going to write to standard out. And so we can go IO, write string, standard out, encoded. Okay? So that's just going to let us write that back onto the same channel. It's possible to do TCP or other protocols. I mean, you can send strings however you want. I guess hypothetically, carrier pigeon. Whatever you want to do, you can send those things back across. So instead of just printing off here that we received a message, we need to reply. So let's do that reply. Right now, what I would do is I would say, let's make a switch off of the method, and we're going to do case initialize. So what we're going to do now is we're really just going to write our response of an initialized response, and that looks good, except we're definitely not v1 this. We're probably more like, I don't know, v0.0.0.0.beta.final or something like this, right? That's probably more where we're at. And this one that you see here really is just saying, always send me the whole file. If we had sent a 2, that would say, send me incremental updates. We are not going to manage that situation. So if we restart this here, we should see, oh, close, what did I do wrong? Invalid server message. Let's see. We got this message here, and then we did not, this is the danger of the live demo. Did we write this before we received this message? Case initialize, write response, result, capabilities, text document sync. Oh, maybe this doesn't like this. Maybe we'll just, in case that's not a real, let me just, no, okay, result, here we go, squiggle test version, invalid server. Oh, I didn't say the ID. Did someone just say that? Thank you, good call. Yes, we need to get back our ID. In this case, it's 1. Thank you, good call. We have to put an ID. We need to say what this message is responding to. Requests have a response, or this is the response to a particular request. So we need to send the ID. Thank you, great call. So now when we open this, we'll see, hey, we've done this, and now we're getting new messages. We got a new message, text document did open. This is NeoVim telling our server, hey, we've opened this message. We've opened TJ DeVries get squiggle test examples definition dot squiggle, and here's the version and here's the text that's inside of it. If we start editing this file, you'll see down here that we are getting new, see those ASDFs growing at the bottom of the file here. We're getting all of the updates live. So NeoVim is sending that message to our server is logging that information. If we delete these 2 lines, it's going to keep updating. Awesome, so now we have the ability to save what the current state that the editor sees into our LSP. Why do we need to do this? They're different processes. I don't know, as the server, what's going on inside the editor. That's like kind of the whole point of the protocol. So for us, we can do something here where we can say, let's just make a new type. We're also just going to delete these. We don't need these anymore. We're going to say, let's make a type state. And it's a new struct. And we're just going to keep track of all the documents that we have, which is just some map of strings to strings. Okay? You would obviously do something a lot more complicated if you were trying to manage a bunch of different real documents across a bunch of different files, etc. But for now, this is fine. And we'll just make a global state here, which has some documents. Cool. When we get a did change, we need to now handle this and update the state of our LSP. We need to save where those strings are and what they're doing. So first thing we need to do something like cased tech document, and we can handle did open. We'll skip that in the interest of time, and we'll just do did change. For us, there's not going to be any additional stuff for changes versus open, so that's fine. So we need to make a var, and this is going to be some message, which is going to be something like text document did change params. We haven't defined this yet. How do we find out what it is? We go to the documentation, we look at language features, and it says document synchronization, and we get a did change text notification, right? We're seeing in our logs, we're getting this message, we look at the docs to say, how do we do this? And then we're going to go implement it. So a did text document did open is going to send to us something like this, a notification with text document did change. Sorry, I cheated a little bit because I knew what that one was going to be. And then we need to make this params which is a did change text document params. The only things we really care about here are that we have a text document and we have these content changes. All right, so what does that look like for us? We'll start writing those out. We've got type, text document did change params. This is going to have a text document inside of here, and it's going to have a content changes. What is a text document? Great question. We click here and we find out. The thing we really care about, we're not going to handle versions, is this URI. So we have a URI that's going to look like a string for us. That's really all we care about. And so we're going to have a text document. It has a URI. Very cool. We go back and we ask, what do content changes look like? Now, these are more complicated if you're doing incremental, but for us, it's always just going to be a new object with the key text and be a string. So we can do that here where we say this, and we'll just say text is a string. That's the only one that we're going to be handling. So when we go back to our did change params, this is actually not quite right, because remember, this is going to be text document notification of text document did change. And what's that going to look like here? It's going to have a method with, going to say text document this, and it's going to have params, which is this text document did change params. Okay, so it's got both of those inside of it. That's the base message that we're getting back from the editor. When we go up to here, we're going to run into a little bit of a problem here, though, because so far we've only brought back the method. We didn't say we need to basically reparse this into this new struct for JSON for Go. And so we can go here and we can just say, OK, fine, I'm not just going to give you back these. I'm also going to give you the rest of the bytes in case you want to parse this again. So we'll update our message here. And then we are just going to return this content for the content length. Great. And now we have content. So that's what we're going to use to actually decode this message. So we can decode the message into or we can decode that content into our message. If we can't read that, we can't do it. And now we're just going to update our map to say, hey, this URI, which is this file, contains this text. Now we're going to be able to start syncing our state with the actual state of the file. So if we quit this and we open it up again, we'll see that nothing interesting is going to happen yet. We are still just doing this. And oh no, unexpected end of JSON input. What did we do here? I did this the wrong way. I said, instead of returning everything up to the end of that, I said, let's return everything after that. That's not what we want to do. We'll open this again. Here, we'll run this. And now we should see, once again, we are syncing the state of these items. We did not do that again. What did we do here wrong? Let's look at what we did for these items. Content chain. Oh, sorry. I did the thing that I said I wouldn't do. This is the notification. So these are the params. Params, this, and we'll do the same thing here. Okay, so we were reading the wrong type of thing in Go, and it doesn't like that, but it silently lets you read that until you access them. Okay, awesome. Now we have our new messages showing up, and we're syncing between the two items. Up until now, our LSP does nothing exciting. Who cares? We're just syncing strings between two places. How are we going to make this interesting in the last 5 minutes of this presentation? AI. AI. That's what we're going to do, okay? Thank you, innovative, I know. What are we going to do? Well, normally you'd write like a compiler, and that would tell you for real where like a definition is inside of a file. We don't have that kind of time. Product's breathing down our neck. We need to ship today. So what are we going to do instead? We're just going to ask AI where the thing is defined underneath our cursor. So I wrote, and we'll do this every time. This is when we do text document, and this is definition, right? We're going to make sure that we need to grab the message for a request for text document definition. Fortunately for me, I already wrote this one secretly here. And this is going to, we can now, we'll parse this out. And then what are we going to do this? Well, we're going to ask our magical black box here to give us the definitions, which Magical black box. Is that not what I call it? I called it magical black box. Magical black box. Where's my completion for that? We'll add it up here manually. Sometimes the LSP doesn't like us. Magical black box. Okay. And if we go back to where we were, we'll be able to say black box here, and we can say, am I missing something here? Magical black box. That's not the right thing. Okay, whatever. This is generate or get definitions, right? We'll just go check out our definition file right here and see. What did we call this? Handle definition request. That makes sense because that's what we're doing. Handle definition request. Okay? And then we're going to say, what do we need to pass it? We need to pass it the code. So this is where we're using this here, and we're going to pass our message into this, right? So this is going to, instead of us actually figuring this out, this is just going to ask Claude and say, hey, you're a definition finder. Given a source code and a position, please tell me where it's defined. And you guys are going to be blown away by the speed at which this works. Actually, it won't work yet, and this part is part of the fun here too, is when we ask to go to the definition of X here, it's going to say, hey, nobody supports definition. Remember, at the beginning we said we need to tell the editor, hey, me over here, I know how to do definitions. So inside of our capabilities, where before we had only said text document sync, we need to say we're also a definition provider. So we're going to tell NeoVim, right? We're going to tell NeoVim, hey, NeoVim, I'm a definition provider of true, like this, okay? Like this. So now, when we reopen this and restart this, we're going to be able to go here, and when we, yep, we're still getting those, that's great. Ask for a definition of X, it's going to say looking for a definition. With AI? With AI? Yes, it's defined on the first one. Did my mouse not move? Hello? Did I miss this? Oh, we didn't write the response, of course. We found the definition and then we didn't write the response. So we have our response. We have our error right here. I was so excited by the AI that I just completely blacked out there. Yes, so there's our definition response. We'll be able to do that. Once again, if we have an error, we should just print what that error is. We'll restart and give ourselves another chance here where, yep, we're getting those. We go to here, we go to definition. The cursor should move very fast. Yes, there we go, right? So this works for anything. I just made the world's first everything LSP. But going to definition, that's only so cool. We have to put some squiggles in the file. This is not definition conf, right? This is SquiggleConf. So how are we going to do that? Well, what we're going to do is we're just going to say, because AI is expensive and my pocketbook is not limitless, only on did save will we ask the AI to say, hey, what are the diagnostics about this file? And probably unsurprisingly here as well, we're going to ask, instead of handling the definition here, here, we're going to say, hey, what are my generate diagnostics? And this function takes what? What did I write for this? I switched the order. Nice, I was really trying to confuse myself on this one. We need to get out the message here. We're going to get from the message this params URI here, and then we're going to once again pass to it the actual code that we're asking for diagnostics about. And this is actually not this. This is going to be notification text document did save. Great. And then we need to once again write that response back to NeoVim and not just put that only into our editor. So what does this do? Once again, if we go back to the spec and we looked at what language features are, and I want to ask, how do I put diagnostics into the editor? the LSP can at any point publish these diagnostics out. And they're just a list of JSON blobs, which just says, hey, here's where the diagnostic is. Here's the level of the error. This could be anything you want. In the past, I've had it bleep out VS Code for me and say, don't type this in my editor. You can put anything you want there. So for us, when we save, we'll request these diagnostics and we'll write them back to the editor. So if we open this up, and then we open up maybe something like bad name. We say something like let hello is 1, and then we do something like console log help, right? Notice I spelled that wrong, okay? When we write this file, AI is a dice roll here. Great, look at that, right? We've got squiggles. We've got squiggles. Hello's assigned a value, but it's never used. And now I think you'll really like this one. Because we're just asking AI, hey, AI, between you and me, what's wrong with the file? Those of you who know Fibonacci may notice there might be something wrong in this file. Incorrect Fibonacci implementation. Fibonacci is not n-3, but n-2, right? So this just goes to show you could put anything you want in there. It doesn't have to just be a syntax error. It doesn't have to be whatever. This kind of thing's very useful if you're writing your own tools, for your company. I mean, you can see very quickly we're able to spin up this entire communication protocol. We're able to add in any kind of external tooling, anything you wanted, instead of asking the magical black box that is AI. Maybe you could use some real tools that do type analysis or something like that that don't take 5 seconds to respond. But you can put anything you want inside of there, and then you can get squiggles in your own editor too. So that's it for me. Thanks, everybody. Appreciate it.
Thank you, TJ. That was a fantastic talk.
Thanks.
I think my favorite, well, maybe not my absolute favorite comment, but I loved RN, registered nurse.
Oh, thank you. Yeah, that's how I remember which order they go in. Because otherwise I sometimes get it confused.
Smart,
so, yeah.
smart. Mm-hmm. So Mitch asked, how did you figure these things out about LSP?
Great question. It honestly was very similar to what we did there. I mean, we didn't spend as much time reading the docs as it took me to do it the first few times, but I think something sometimes people are a little bit afraid of is like going and reading a specification or going and reading and kind of like deep diving on one of those things. And sometimes it's like, if you spend 15 minutes reading the introduction to LSP, you're like, boom, got it. I understand the rest of it, and you can go figure out the parts that you need. So really recommend reading that friendly manual.
Yeah, from a tooling perspective, it's amazing how much difference good docs make.
Yes.
As far as a good tool to being able to use the thing.
Yeah.
So Mark asked, what is marshalling and unmarshalling?
Oh, great question. So that's basically like JSON.stringify, that turns an object into JSON, that's marshal. And unmarshal is like JSON.parse, if those are more familiar. It's just a way to convert Go objects into and out of JSON.
Perfect.
Yep.
Andrew said, this is giving me great ideas for in-house tooling for my teams, but what's the right way to distribute a custom LSP server?
I mean, if it's an internal tool or something, I mean, you can just tell people where to maybe install if they just want, like if you write it in JavaScript, you can put it on JSR and have them download it from there, right? So whatever way you would, that's sort of the beauty of LSP, right, is it's like you just have to have a binary and then some way to tell the editor where to look for that and what files to attach it to, which is relatively straightforward most of the time.
Okay, perfect.
Yeah.
Relatively.
Yeah, well, it just depends. I mean, like, yeah, but usually it's fine.
Okay. Becca asked, what are some of the most creative, useful, or powerful applications of LSP servers you've seen?
I'll punt that over to Dylan Mulroy was telling me Effect has the best one out there. I don't know where Dylan is. I think Gleam has one. I think one of the things that a lot of people don't know language servers can do is called code actions. So if you're not familiar with that, basically every editor has support for them, and they let you do cool things like, you probably saw a few times in the talk, there was a red squiggle under an import. I can press my keyboard shortcut for code actions. One of the options in Go says, hey, just fix all the imports for me. And it figures out which packages need to get imported based on what functions I'm using. So those kinds of things where the editor can automatically do stuff, refactor, import, format, those sorts of things are very powerful. A lot of times those are implemented in code actions, and I've seen people do a lot of very cool stuff there.
Awesome. David asked, can you run multiple LSPs for the same language? So if you wanted to create a custom LSP.
Yes, you definitely can. And like in JavaScript, I think the average LSP for file is like 7 or something like that. That's been my experience every time I open up a JavaScript file that I'm not familiar with. One thing that's really cool that I've done for a few languages where maybe one language server is really good at definitions and another one's fast at completions. Like we showed at the beginning, if you understand capabilities, you can actually send to those servers and say, my editor doesn't support definitions. And then that will just make that editor or that other language server turn those off. So you can actually, in some ways, like sort of fine-tune that if you have like a lot of different things that need to happen among sort of competing language servers.
Awesome. Brandon asked, do LSP servers run on localhost and or HTTP? Not sure how it would apply or something else entirely.
Yes, so the format that we showed of sending messages just sort of over standard in, standard out, you could do that as well over like TCP, you could run them other places. I don't find that people do that often. Most of the time it's just simpler, particularly like maybe if you have an environment with installed packages, it's sometimes harder to make sure like your remote machine has that exact same setup, which can lead to weird things where you get errors and you're like, that file is here, I'm looking at it on my file system. So that happens sometimes, but so generally it is, but the protocol is like transport agnostic.
I really like this question. What's one LSP horror story that still haunts you?
UTF-16? I don't know. I know there's a few people in the audience who understand that. Just like for some reason, I mean, it's like a Microsoftism to have UTF-16 and things, maybe less so now, and just like, it makes it very hard if your editor, like NeoVim's written in C and kind of expects things more in like byte format and stuff. So you just end up with this thing where it tells you an error's happening, and there's like a Unicode character somewhere on the line, and they don't line up, and then everyone's like, this is so stupid, why don't the squiggles line up? And then it takes like a lot of hours to find those bugs and fix them. So that one hurts a little, yeah.
You have several people in Discord commenting on your NeoVim situation.
Oh.
I think it's funny because it's like inevitably any YouTube channel I make, it's like, what theme are you using? But they were asking about is it autocomplete or AI?
Oh yeah, I'm using SuperMaven right now for that, yep.
Awesome. Well, thank you so much, TJ, for your talk.
Thank you.
So, fantastic. Give TJ another round of applause.
Bye.
How's everyone feeling? Woo, we made it. I'm sure your brain is as waterlogged as mine is.
Yep. Nobody. It's like the puns aren't even funny. The beginning of the day, there was so much like, oh, we'll give it to you.
Yeah, we haven't heard nearly enough groaning from you.
At least groan. Give us something.
All right. Do you want to talk about the scavenger hunt?
Yes. So we do have a photo scavenger hunt. So you'll want to break into groups of 2 to 4 people. So if you are looking for a group to join, you can just send a message to hashtag, is it hashtag if it's like a channel?
Yeah.
Photo scavenger hunt. And then at 5:15 sharp, we will post a list of 9 riddles describing Bostonian landmarks for you to take group pictures.
6 minutes from now.
Oh, there you go. I need to hurry. Talk faster. Landmarks are all within a 10 to 15 minute walk here of the theater. So feel free to take your time and just enjoy the sights. Grab a few snacks along the way, and then post your photos on social media, tagging SquiggleConf. As I mentioned earlier, there's a QR code on the back of your name tag to be able to give you all those account details.
And if your team, if you get all of them, then you'll be entered into a raffle where the entire team will get tickets to the next SquiggleConf. Woo. As Amy said, share your photos with us. We made it really easy. There's a picture of your badge, of the back of your badge right there.
Yep, so this is like a link tree, as I mentioned, and has links to everything. And then for dinner, you are on your own. So, and if you're looking for dinner with friends, new friends, or just to see what people are doing, there is a food channel within Discord.
Yeah, and I'm sure there's lots of great recommendations. We have a few as well, if you can find us. The first, State Street Provisions. This is, I believe that was recommended for lunch as well. Right. Really great steak tips.
Comfort food.
Comfort food,
seafood, burgers, lobster rolls. There you go. How do you even?
Joya.
Joya.
Yeah.
I don't even know how to pronounce that. Joya Restaurant. We actually ate there last night.
Yeah, I enjoyed it.
Oh, did you plan that one? This is kind of an Italian-inspired menu with handmade pasta, different pizzas, creative seafood, and I had the steak tips last night. Very good.
Oh, they're so good.
Yeah, very good.
Also, the cacio e pepe pasta is very, very good. Ned Devine's. This is an Irish pub. This is where the social event will be happening tomorrow as well, but you can go there tonight and check it out. And it's an Irish pub. It's got pub food.
Yeah, the TripAdvisor had a lot of good things to say about the fish and chips, so if that's your thing.
And?
Ooh, Wagamama. So this is great if you like ramen, curry, rice bowls, and more.
Mm-hmm. All right, and that is it for day one. I hope you all had a great time. We have a lot more exciting talks tomorrow, and we will see you at 9:30 for the next round. Thank you so much for being a part of this.